and then you go to design and quick layout. And that's my quick layout. It's my favorite one. You can also get to the chart title, clicking all this stuff. Yeah, also, I'll show this again real quick. Look at all these options. That's so many cool things. It's so nice.
Gary! I was just looking for the sports channel, Gary.
Hey everybody, how are we doing this morning? Can everyone hear and see me? We just got started here, so is everyone hearing and seeing me in the chat right now? There will be crab raves, I promise there will be crab raves. Yes, you guys can hear and see me. The points sometimes take a moment after I start the stream. Oh, I love all the yeses in the chat. Awesome. We try to get started right at 9. I had an issue with the intro screen. I was like getting it set up and it wasn't looping properly. I was like, and I was trying to fix it. And I was like, I got to start class. And so I was like, I'm always like getting things ready here and all that good stuff. So I'm glad we've got so many different intros. Hopefully you guys like it. And Streamlabs should be working. I hope Streamlabs is working this morning properly. Sometimes it takes just a moment for it to start up. That's why I didn't say at the right start of the stream, which, you know, what's interesting is at the very start, I waited like 10 minutes yesterday to tell everybody about Streamlabs. And then the points, I think, like weren't, you guys had 0 points. And I was like, that's interesting. I hope everything's working properly. And then you guys started to get points. So I think Streamlabs might take a little while at the start. So we're going to cross our fingers. I've been doing everything the same way. I've got Streamlabs going on in the background. You know what I can do? I can do a test of Streamlabs to see if it's working. Let's do a quick test right over here. We'll do a quick poll just with 2 options. So let's go. Let's do like a pretend quick poll right here. So if Streamlabs appears in the chat, it should be working. Oh, Streamlabs. Oh no, it's not appearing in the chat. Streamlabs, what are you doing? Oh no. So if Streamlabs is not appearing, that's weird. And I need to figure out why Streamlabs didn't do its thing. So I'm very, very sorry if Streamlabs didn't appear, and I'm always trying to figure out the issues with this. But it didn't do the poll, and it worked 100% yesterday. We've had like 2 or 3 streams where it didn't work, but I noticed sometimes it takes just a moment or two. Let me look over here at the chat real quick on this. It says it was running the poll in the background on the other chat screen I have. That's so weird. It says I'm live. It says 0 viewers, but it's doing Twitch. Streamlabs is not working today. I'm so sorry. I've only had a few streams where it didn't work, and I'll look into why it didn't work. I'll try to figure out why it didn't work. Maybe I need to have it open first in the background. I'm going to look at 1 or 2 more things. I'm very, very sorry if it... Let me turn CloudBot on and off. Just turn it on and off right there. Turning it back on right now. And then we'll talk about class and all that good stuff. Okay, CloudBot is back on right now. Let me cancel this poll. Let me try running the poll again and see what happens. Okay, so, whoops. Well, maybe it said in the chat. Hey, what's up, Tyler? Good to have you here, Tyler. You can tell them all about StreamBot and all the good stuff. We had it working 100% yesterday, and so good to see you. So we'll give it a moment to we'll see if during the stream StreamBot starts working. And there, Tyler's trying to look at his points right there. We've always had at the start of the stream, it seems a little bit like it takes a moment for it to build up, and so I don't know if it's a thing with like YouTube. I think they design these things for like Twitch, and I've always wondered if like there's always this small issue. So please work, Streamlabs. Please work. I might have to take a list of people's names and give you guys like 150 points for being here today. I'm totally willing to do that. Stay the whole class. Man, it's like technology. Everything worked so perfectly yesterday. So let's close this poll and let's cancel. Okay. So Streamlabs, you need to do CloudBot. It says you're off. Don't be off. Okay, let's start. So now CloudBot's back on. So let's hope it's working. We'll give it another 5-10 minutes. So about that. And you guys can see me in the chat right now, right? Everything seems to be good. Let me say hello. I think you guys see my chats in the stream. Okay. So let's talk about a few things here, just some house cleaning stuff. So let's hop over back into here. Good to see you, Sarah. Thank you so much. Is there a link to download Jump? Yes, we've got that. Let's go grab that link real quick. So I'm going to drop the link in the chat right here. So this is going to be a playlist link, and it's got some videos for you. So let's hop into the playlist right here. This is kind of our house cleaning start of class stuff that we do. And so I need to find the right playlist. Let me control find here and go to project. And we almost found it. There's project 1 videos. And let me go to the download Jump. Now you can download Jump 14 or 15. I would suggest Jump 15. If you've already downloaded Jump 14, do not worry. That is perfectly fine. What's up, Joe? Thank you so much, Joe. I'm so glad to see you guys are always welcome to swing by, and it's so good to see you guys, especially at the start class. That's awesome. So no, it's so good to see everybody. There are some links on Canvas and videos on how to do it. Is it free? Yes, it's free for UT students. You do not need to pay for anything in this class. You have inclusive access. Please tell me if you like, Brian, should I be paying for this? And I will make sure you're not paying for it because we get it free from UT. And I'll say this, the biggest thing, and let's hop over here to a screen where I can kind of talk to you guys real quick. We're going to open up a Word document and let's do this. It's so good to see you, Joe. Definitely win that NBA 2K game. You got it, man. Okay. So a few things. We got the rainbow even going in the background right now. So a few things right here. Jump is completely free for UT students. It's actually a pretty expensive piece of software. And we get it for free because kind of they want us to train you on it. That's what Isaac and I were talking about yesterday, is that Jump wants to train you on how to use their software. So that way when you leave UT, you're like, oh, I need to use Jump. And that's quite fine. It's a very good piece of software. It makes everything a lot easier. You can do a lot of the statistical concepts, but I'm totally open to you guys using Excel, Python, anything you want. And you can put it on your CV. Exactly. You can put it on the stuff you had. Gosh, Tyler, you guys are nuts. So you guys can learn this, put it as one of your technical skills. It's a great thing to have. It just helps in aiding you as a student and the things you know how to do. I'm trying to think if there's any other big questions, but downloading Jump is pretty key. Also, I was putting out videos last night on how to do things inside of R. So if you want to download R, did anyone see the videos I posted last night? Did anyone see Stats 1, or did you go to the channel this morning and see like a new video posted? You can always go to those videos. You can like those videos. You don't have to. But yep. So check out those new videos. I'm trying to do like 1-minute videos explaining stuff. And if you want videos on how to do things inside of Jump in 1 minute, I'm going to do these 1-minute videos. You'll use Jump on the projects, but not on the test. So, yeah, and I bet I can make a video on how to download Jump. That'd be really good, like a new video on how to download Jump, and R, and ask for videos, email me, and that brings us to kind of our next topic. But once again, if you want a video like, hey, Brian, can you make a video on how to do this for the mean? I'm going to check to see if points are now available. Come on, points, you got this. We waited like 8 minutes yesterday. Let's see if points are working now. So, do you know any companies that have and use Jump? Yes, Eastman Chemical uses Jump. So I can confirm, unless they've changed. I hate to say I'm not like talking to Eastman every day, but I know 5 years ago. Yes, Streamlabs is working now. Woo! It just takes 8 minutes. I'm so sorry, guys. I've noticed this. That's why yesterday I waited just a little bit. I was like, I'm just going to wait a little bit. And I'm going to tell you guys about it. So good. Anaconda Navigator comes with Python, Jupyter, and oh, man. So Anaconda Navigator comes with, okay, because I was emailing you about this yesterday, Isaac. So that is so cool. Okay, I need to look into that and keep talking to me. Thank you, Ethan, for Isaac. I don't know if I said Ethan, but Isaac, thank you for the emails yesterday, and thank you for that Python.py script. So that was really big. That helped out a lot. So sorry for the points not working at the start. I think it just takes a moment. We did have one stream where it didn't work. You are Ethan now. There are so many students where I'll flip their name into something else, and they'll start cracking up. I had now I can't remember if it was Jessica or Stephanie. I think her name is Jessica, and I'd call her Stephanie, and she would always crack up. And I would call her during office hours, and I'd get it wrong, and she'd let me go the whole time. And I'd be like, have I been calling you Jessica this whole time? She'd be like, yes. And I'd be like, oh, I'm so sorry. She'd be like, it's all right, I'm Jessica now. And so she would just crack up about it. But if I get something wrong, my mind starts to get really anxious about it, and then I'll start flipping it. So I'm very sorry if I say someone's name wrong or stuff like that. So, Caleb, hopefully. So, yeah, so if I flip it, just tell me. If I pronounce your name wrong, please just tell me. I'll always try to get things correct. And then hopefully my brain doesn't start doing that thing where I start overthinking it, and then I can't remember the right one from the wrong one. It just happens to me a lot. Okay, we got everything on track right now. We know that we could get Jump, we could get R, lots of great things. Please, please, please email me video ideas. As a content creator, it helps for you guys to be like, this is what I want to see. This is what I want a video of. If you're like, hey, Brian, can you make a video going over how to do a scatter plot inside of R? and I've got a few on how to do it in Jump, but anything you want to see, I'll make a video, and I've just got time because I'm still quarantining, so all that good stuff. Last but not least, when you email me, this is the start of class. When you email me, please use the email titles. Many of you have already seen this. Let's go right here. Here's how to do the email titles. Stat 201 dash your initials. So those are my initials. And then go right here and do the title of email. So this is what I want you guys to do. Let's see here. Like someone say, show me how to do mine. Someone say, show me how to do mine. Or do an example of yours in the chat right now. So you'll put the title here. The title, you won't say title here. You forgot the mini. Oh, you're right. I did that for you guys because you're right. Oh my gosh. You're right. There we go. Oh my gosh. William, email me, William, I'm giving William 100 points just for that. So, Keaton right there. So you would do KB right there. That would be yours. And there we go. There's Isaac's right there. And so exactly, you guys get what's going on. Sorry, I forgot the mini. You are right. William, email me. I'm going to throw some points on yours. I'm going to try to add the points for everyone who did the extra credit email onto theirs this weekend. But please, when I get things wrong, tell me. Be like, hey, Brian, you told us to put mini. You're right. I don't always do that. But since I just had a semester end, and I kind of want to distinguish if someone's emailing me from last semester to the mini term. So I put the mini on there so that way I would know if somebody is from Stats 1 mini term or if someone is from Stats 1 previous term. So it's very easy to tell, like, oh, this is somebody emailing me from last semester. This is someone, you guys get it. You guys know what's going on. But this helps me so much because, one, I get so many emails that start out with things like, hi, Brian, or don't worry, I'm not a doctor. We'll get like, hi, Dr. Professor Stevens. I'm not a doctor. I'm not a professor. I have my master's degree in business analytics. I've done 3 PhD courses. They're extremely hard. One of these days I might get my PhD, but that day is not today. There we go. Put a comma right there. Don't call me that. You can just say Brian. The best thing to do is just be like, Brian. That's what I call myself. That's what you can call me. I'm perfectly fine with that. I don't like being called Mr. Not like I hate it, but I'm Brian. That's how people know me. So then usually emails start out with, I am Adam. I am in your, it's not a sentence. Well, that is a sentence. I am in your class. I was just wondering, could you maybe, if possible, no. Don't do this right here. This, don't worry. Just be like, Brian, when will we have our tests during mini term? We went over this yesterday, and don't worry if you have a question that I answered, and then Adam. So that's fine. This is how I kind of like your emails to be, just straight to the point. So do not worry. Yep, I'll explain that in a second, Mona, right here. So, and let's make Mona a mod right here. Mona, you are now a mod right there. You got it. And then please email me if you're not a mod. Like, let's make Nicole a mod right here. Let's make Valerie a mod. So you guys are all mods right there. Okay. So this is how I like your emails to be, straight to the point, and you get extra credit just by doing this right here. And you can still email me since you just joined the class. Email me the extra credit email. It shows you know how to do the title. This is how you would do the title to it right here. I guess this person's name is Adam, so let's change it to their Adam Stevens. So that would be the title of their email right there. And then the title of their email would be, they can call it EC email. That's fine. It doesn't have to be called extra credit email, but awesome. I like that right there, Coleman. Let's make you a mod. So this is how you would do your email. And this, is a fine email. Remember, the extra credit email is just to ask me a question. So does everyone understand pretty well right now how to do emails in this class? It makes my life super easy. And once again, how quickly do I respond to your emails? Like, who can, once again, I know I asked you guys this yesterday, but how quickly do I respond to your emails? Like within maybe a day, within maybe like 10 hours? How quickly will I respond to your email? Speedy fast, so quickly, less than 10 minutes, 10 minutes, literally within the hour, 3 minutes, very fast. You guys got it. So I ask all my students, please try to keep this, format. That way I see it very quickly. And I'm like, okay, a Stats 1 person emailed me and I know it. So always impressed. Thank you so much, Claire. Fast enough that it got buried under my other emails instantaneously. If you email me, I'll email you back right away. So I want you guys to know, and there we go. So please email me, and I will make sure that I email you back. Email me any questions you have, and I will make sure to answer them all. Once again, my email address is super easy. My email address is just bstevens bs@utk.edu. You can also email bs@utk.edu. I took that. No one took it, so I took it. So if you want, email bs@utk.edu or bstevens@utk.edu. Both of them will go to me. Hey, good to see you there, KK. So Josh and everything. That's awesome. I wonder, do I know them? That's cool. I guess I do know them. So that's really cool. I guess, did they take class? Is it Kyle? Because Kyle would have those initials. Is it Kyle from, is it Kyle? I don't know if I want me saying that because his initials are that. And then I'm trying to think of students I know. So you'll have to tell me if it is them. I'm gonna show you guys something else super cool here. This is our start of class. During start of class, we kind of talk about, you know, housekeeping stuff. We get ourselves in line. And so I got something really amazing for you guys. You guys are gonna love this. So check this out. I went the wrong. No, don't do that. Okay. Let's see. Was it Kyle? From Animal Crossing. That's the Animal Crossing person, right, Claire? Is it is that the one that like plays all the music? Okay, so check this out right here. If you were to go to yesterday's stream and hover over it, you would get all of these what they're called is called chapters. Does everyone see where it says stream start? That's what the start of today will be called. It'll be called stream start. And then look, you can literally see it in the video, but you see where it says syllabus, where I'm hovering over it says syllabus, and then wait, look right here. All of a sudden, lecture chapter 1 stats start here. Then what do we get right here? Chapter 1 homework, chapter 1 quiz, chapter 2 homework, and wait a minute, chapter 2 quiz. So you can now see what is going on in the video at certain times. So you can just kind of be like, oh, and if you really want, you can go down here to the timestamps, but still you can just see it visually underneath this right here. So that's what I'm going to try to do to every video. Please remind me if I don't do it. But these are the kind of things that I'm setting up that I think make your life easier. And you can go back and be like, okay, what did Brian cover today? Here's all the different topics. And you can literally see it visually within it. So I'm trying to make this as intuitive as possible. I know we do a lot during class. And so you'd be like, wait a minute, I want to go back and see what we did today. Pretty easy to see what's happening. So I really like that. You can also see like the chat from yesterday. And I'm probably going to unlist these videos. So let's talk about one last topic. I know you already answered this, but how many attempts do we get on each quiz? 5 attempts, and there's no penalty. You can do all of them if they want. You can do all 5 attempts. Are you okay with email threads, or do we need to send... as long as it's within the same thing, I'm totally cool with it. So if you're still expanding upon extra credit stuff, that's totally fine. And like the one you sent me yesterday, Isaac, about even if it didn't have the right title, don't worry. You can expand upon that one that you sent me yesterday. Thank you very much, Taylor. So you're welcome there, Sophia. So you can expand upon stuff within the same one. Don't be like, okay, I got to start a new email every time I email them about Python and stuff like that. Now, if we're still talking about Python, just probably don't, if you're talking about Python, don't then ask a question like, hey, Brian, I'm stuck on this homework assignment, because maybe I might be slower to respond to the Python one because I might have other ones like, Brian, I'm stuck on this homework assignment. Usually those are the ones I respond to as quickly as possible. There was one last thing I was going to show you guys. One last thing right before we went to lecture. What was it? Oh, I need someone to tell me. I need to know. Oh, I forgot. It jumped out of my head. No, that's what happens when you're ADD. No. Being ADD was so much fun until 10 seconds ago. Do we get multiple tries on homework? Yes, you get infinite tries on homework. Yep. Jump is failing to install my computer. What should I do? Coleman, email me immediately and we'll try to get that figured out. Send me a screenshot of what is happening and just call it like stats01. And so you would put this right here and you'd put like jump issues. And I want to, actually, that brings up one last good topic. What you'll do when you take a screenshot is use things like snipping tool. And please take a screenshot like this. I'm going to tell you guys a secret pet peeve I have. You ready for this? A secret pet peeve Brian has, I shouldn't tell people this because now they're going to feel bad whenever it happens, is people take screenshots with their phone. So I get a lot of screenshots that are from people's phones. And I secretly hate that. Because it's a huge file. It's very, very big. But if you're on a PC, you've got a snipping tool, which allows you to go right here and just take a snip like this. And then you can send it just like this. It's really awesome. If you're on a Mac, you've got Command-Shift-4. If you've never tried Command-Shift-4 on your Mac, go ahead right now and hit Command-Shift-4. Go ahead and give it a shot. If you're on a Mac, hold Command-Shift and hit 4. Your screen will freeze, and then you can take a screenshot of the video. You have a video how to work jump, you got it. It's in yesterday's video, and whenever you're stuck, email me and I'll help you out and I'll try to direct you to the right spot. So take a screenshot via snipping tool or Command Shift 4. If you send a screenshot from your phone, that's all right. But it's a really great way to take pictures either with snipping tool or Command Shift 4. It's very easy to see. It's very easy to read. It's not a huge file usually. It's adjusted for size, but it's just a good kind of like how to take great screenshots on your computer. I've also got a video on how to do that, but I think that does it for all of our housekeeping at the start of class. We're good to go. We're excited. I know Command Shift 4 is awesome, Valerie. Valerie is totally right, and you guys' points keep going up for all this interaction, all these questions. With that, let's go back to lecture right here. Do it. I was not quick enough. No, you guys got to see the screen right there. If you have a Mac touch bar, you can use... Oh my gosh. Sarah, I get my upgrade in like 8 months to my... UT gives me a new computer every 4 years or so because they update faculty technology. And at the start of next year, which is like 8 months away now, 2021, oh my gosh, I will get a new Mac and it'll have a touch bar, I'm sure, because my old one doesn't. But I'm so excited for that. I want that touch bar. I want that touch bar. It's so cool. Macs, I grew up on PCs, but Macs are really great. And PCs are great. I'm using a PC right now. But yeah, Jump wasn't hard to download on PC once you watch the video. Awesome. So awesome. We will talk to you guys and get these things figured out. The Touch ID is so handy. That's awesome. Yeah, I know. I want to start learning to use that touch bar. Awesome. Okay. Here we go. Let's take like a deep breath before we're about to get into some serious topics. So let's do this. Now, if you watched yesterday's lecture, we started to talk about how to display and summarize data. So we talked about how to display and summarize data. So today is a quite long lecture to start on chapter number 2. We covered a lot of the homework assignments for this, but get ready, and I did upload the annotated notes, so check them out. They're in the modules. I'll try to annotate more today, and I will upload the notes if everything remembers properly. So let's take a look at how to display and summarize categorical data. But I need your guys' help to start. I'm stuck here. Brian forgot everything from yesterday. I need you to tell me what are categorical variables. Let's put a little sign right here saying Brian doesn't know what categorical variables are. Where are my pens at? What? Where's my draw at? Brian doesn't know what categorical variables are. I need some categorical variable examples right here. I need some examples of categorical variables. Who can give me examples of categorical variables? Who can give me examples of categorical variables? And all of a sudden, you should be seeing them in the chat right now. Oh, good. Did they update this? What? I think they updated it. Why would it update? Whoa. It updated or something weird happened. It says pens now. State, gender, hair color, eye color, favorite color, eye color, race, hair color, eye color, name, gender, eye color, grade level. You guys got it. State. All these things right here are categorical variables. We see what's going on. Great job right there. Class level. Nice. We're just saying all the ones that appear. Favorite food. Oh, man, gosh. Don't get me. There we go. Ethan says car brand. Let's make Ethan a mod right here and Carly a mod. You guys got it. These are all categorical variables, and you guys are all getting points by interacting. Remember, every time I ask questions, be here, be interacting. You should know what a categorical variable is like that. Categorical variables are things that put things into groups. Even your name is a categorical variable. State right there. You got it. School year. And school year can kind of be quantitative. Don't worry, Camden. You're totally right. It's kind of one of those iffy ones because, like, are we talking about someone in 9th grade, 8th grade? That's kind of quantitative, but still it's categorical. Like the people who are in 9th grade, the people who are in 8th grade, it's still like a category or a group of people. And then you could say like, I've been to school for 9 years, or I guess it would be 10 because kindergarten. So all that. Favorite pizza. Oh my gosh. I would have to say like, I think chicken jalapeno is really great. Like that's a good combo right there. What was the word you used to describe the variable? It puts things into groups. So categorical variables are like a grouping variable. It's like if you had like boxes and you were putting stuff in the boxes, it would put things into groups with each other. So we see right here that a categorical variable puts things into groups. So that is what a categorical variable is right here. So is a specific type of categorical. Oh, and then there's 2 types right here. We've got ordinal and we've got nominal. Now, I so rarely talk about these. These are not super important, but we've got ordinal and nominal. Great job right there, Jared. Amazing job. So the school class level is generally, if I think freshman, sophomore, junior, senior, I think that's really good, like a categorical variable. But if I think like, also you can't say green eyes or exactly, Mona's totally right. Green eyes and brown eyes, they're just groups of individuals. So ordinal means it has an order to it. Like freshman, sophomore, junior, senior is ordinal, but green eyes versus brown eyes is nominal. So look at kind of the roots of the word. Ordinal means it has order to it. So when you think about ordinal, it has like an order. You got it, Hannah. Amazing job. I love it when you guys are like explaining in the chat also. You're doing an excellent job. Keep it up. That really helps out. So ordinal means it has order to it, like freshman, sophomore, junior, senior. But then nominal means it has like no order to it. There's no order to it. You see how it ends in ominal or ordinal, nominal? I can't talk today. But there is no order to nominal. The steak preference example is good too. I totally agree. I just want to talk about like get a medium rare steak. So you guys are awesome. Exactly, Isaac. I love it too. So you guys got it. Great notes. Be taking these notes too. You'll know them instantaneously, and I can't trick you. It'll be like steak preference. You'll be like, that's the one we did in class. That's ordinal because it goes from rare to well done. I know that, Brian. You got it. So now let's take a look at, we've got a few different ways to display, but we've got a key word right here. We've got univariate. We've got univariate. Let's break down these words right here. I don't know if I like this new thing better. That's kind of weird right there. Let's go to the blue. Maybe that. My pens are different today, and I don't know why. I'll have to look into this. Did the computer update? We've got univariate, one variable. Coleman, you're exactly right. Isaac, you're exactly right. It means one variable. So these are univariate categorical displays of data. So everything you see on this chart right now, take notes on these. Like right now, if you're watching this afterwards, pause the video. And a stem and leaf is univariate, but Kyle brings up a good point, and you'll see the notes will get to this. Stem and leaves are univariate quantitative. Stem and leaves are univariate quantitative. These are univariate categorical. So if you notice, we have different types of displays based on something being categorical. Great question, Kyle. Yeah, you got it. That was a really great answer because like, wait, we were doing stem and leaves yesterday. Yes, that is univariate quantitative, where a bar chart is univariate categorical. And I wish I could play this. It's a clip from How I Met Your Mother. We'll see this in a moment here. But here's what you should remember. Remember this saying right here. I want to see it in the chat if you want. You can make a bar chart of your favorite pies. You can make a pie chart of your favorite bars. Think about this. If someone said to everyone in class, like, what's your favorite bar, given you're 21, everyone would start naming off their favorite bar. They'd be like, Barcade. Okay, that's the only one like I know. In Yacht Club, it's the Barcade. So they'd be like, they'd like name off their favorite bar in Knoxville, or you could ask people their favorite pie, and they'd be like apple pie or Oreo pie. So cool beans right there. People are giving their favorite bar now. So if you notice, that would be a categorical response. You can make a bar chart of your favorite pies, or you can make a pie chart of your favorite bars. Does that make sense? In your backyard. Especially under quarantine right here. But so remember that saying. There you go, Kate. You got it. You can make a bar chart of your favorite pies. You can make a pie chart of your favorite bars. So with that in mind, bar chart and pie charts are connected. Leaderboard right there. So we remember bar charts and pie charts are forever connected. Bar charts and pie charts, the hill right there. Turned 21 over quarantine. So who knows? I'm sorry, Camden. I'm sorry. You'll find out. You've got so much of the world to experience now. You got it. Nice job, Brooke, right there. So let's go ahead and start looking at some of these. We're going to start taking a look at these, and let's see what's going on. We're going to start off today with the happy topic of the Titanic. Woo, the Titanic. Yay. It gets happier when we start talking about bivariate data. The PowerPoint for Chapter 2 on Canvas is not showing up with this information for me. It's showing up as a blank PowerPoint. Oh, I think I know what it is. I need to fix that. Do this. Sorry, Sarah, and I'll fix this because someone said this last semester. You should see where it says Close Slide Master. You should see buttons at the top. I'm going to show this to Sarah just so other people don't get hit by this also. You should see a button that says something like, where is it at? It should say like Close Slide Master. Do you see at the very top up here, it says something like Close Slide Master? Someone else said this. So go to Close Slide Master. Does that appear at the top of your screen, Sarah and Morgan? Very sorry about that, and I probably need to update it. So go to where it says Close Slide Master. Sorry for the spoilers there, Tristan. Let's see if Sarah and Morgan can confirm that that's the issue. Did that work, Sarah? When you go to Close Slide Master? Very sorry about that. I'll try to go in and fix those, and I'll upload these annotated ones too. That fixed it. Good deal. Let's head back to the lecture right here. Awesome. Whoops, clicked the wrong button. Now we click the right button. Okay, there we go. Sorry about that. Someone else said that last semester, and I didn't update that. So I'd already kind of encountered that issue. Very sorry. Try to fix every issue between semesters, and I forgot about one. Okay, so what do we have right here with all the people on the Titanic? And thank you. Always ask a question when you are wondering what is going on. When you're like, wait a minute, Brian, what's going on right here? We'll try to fix it. It changed my drawing tools. Okay. So when you look at this on the Titanic right here, you would say to me, people have said this many times to me, Brian, these are quantitative responses. And I say, no, they're not. They say, Brian, they're actual real numbers. How can you not say to me that 325 is not more than 285? I had someone who was so intent on this, and I'm not mad at them, but they were like, Brian, you're wrong. And I was like, because I can be wrong. I've been wrong multiple times. Matthew gets it. Matthew knows what's going on. And I was like, no, I promise you, this is categorical data. So here's how you know if something is categorical. You'd say, well, Brian, those are real numbers. You said real numbers are quantitative. I want you to pretend you time traveled and you went to the Titanic and you wanted to collect data on this. Someone write a question in the chat right now for how you would collect data if you walked up to someone and had to figure out this information. If you had to figure out that information, how would you collect data on it? This will help us out right here. How would you collect data on this right here? Okay, now I'm getting spooked out here. Maybe we should not talk about the Titanic, because I swear I draw this. And then it better not do it again. Ask them what class they're in. You guys are totally right. So what ticket class did you buy? You got into die right there. What class are you in? Now think about it. What class are you in is not a quantitative response. So we wouldn't say to them, like, how many first class people there are. That's not how they collected this data. They would say, what ticket did you buy? Right there. And Andy, nice job. What class are you in? That's how you're asking the question. So you're literally making a category. Like, ask what ticket class they have, Alyssa says. You are totally right. What class, Christina says. You guys got it. This is a categorical question right here. So we know what's going on. Now, there's a small difference right here. This question was brought up yesterday. The question was, what is the difference between a frequency table and a relative frequency table? Great job, Isaac, right there. It's pretty much the way the question is asked, because we're not saying, the question is not how many people were in this class on the Titanic. You had to go up to them originally and say, are you in first class? Are you in second class? And you had to get a categorical response. So will there be more than one person with the same class? Exactly. Because think about this. There are 325 people in first class. There's 285 people in second class. So just time travel and imagine that you're walking up to these people and you're saying, what class are you in? And Brian's like, I am in first class. So you would literally go and put a kind of tick mark here. You would collect data on that individual and put that they are in first class. Then you'd walk up to another person, they're in crew, and you would just keep collecting individuals here, and you would just get more and more people, and you would keep collecting information on them and counting how many people are in each class. So you can categorize numbers as a categorical. Kind of. Always look to the question, Camden. Great way to ask it right there. Always look to the way the question is asked, because think about brown eyes and green eyes. If you want to see, like, or we could just do eye colors because there's more than brown and green. There's blue, there's black. So if you did eye color, you wouldn't, the question is not how many people have this eye color. You'd walk up to someone and say, like, what is your eye color? And they would say green, and then you'd have a check mark in a green box. So you're just counting the individuals who have green eyes. Now, you will get a count of how many people have green eyes, but that doesn't mean it's quantitative. It's just a count of how many people. Does that make sense what count data is? This will come back for the last lecture, interestingly enough. But so what would be a question? So yes, the question itself is the best way to do it. The question itself, like, what is your eye color, will result in a count of how many people have green eyes, brown eyes, blue eyes, black eyes, yellow eyes, red eyes. I guess you can have those colors without context. But we would get a count of how many people have those eye colors. It's not quantitative because it's a count. Look to the question itself. What was your eye color? Don't be like, okay, wait, we have numbers here. Brian said numbers are quantitative. Well, we're getting a count of how many people are in each group. So it's a little tricky. That's where people have been confused. That student was so intent on Brian, you're wrong, because you can't exactly, that'd be nominal. I think Coleman's pointing out that eye color is nominal. You got it. So now we see a small change between these two slides, a very small change that the previous slide just said frequency table, and this slide says relative frequency table. A relative frequency table is just out of 100%. Yep, the question itself would result in a qualitative. So this is a qualitative response right here. What class were you in? First, second, third crew. It's just a kind of quality of the person right here. This one is almost ordinal, but it has this one that breaks the trend. If we didn't have crew, and not trying to put down crew, but especially if you look at the statistics on the Titanic, so it's almost ordinal because the first three have order to it, and then the last one's kind of breaks the trend and goes nominal. So that's why I don't even really care about those terms that much. We don't use them that much in this class. But even if we thought of crew as a lower class than third, I'm not saying anything bad about crew. I'm not trying to put down crew. But, you know, if you think about the preference that was given to people getting off the ship, crew did not do too well when you look at the statistics. So you might say, well, how were these people treated? Crew was probably treated the worst. So you could go ordinal in that degree because crew was probably like a fourth class on the Titanic. So, and first, second, third is very much ordinal. So I don't know, fun variable. So does everyone understand the difference between frequency table, which just gives us the actual counts, and then you're right, it could be how much they paid. Yeah, so it's ordinal by how much they paid. Isaac, amazing comment right there. Does everyone see the difference between frequency and relative frequency? Frequency gives us the counts, which is how many there were, and relative frequency is done as a percentage. It's still categorical because of the question. Claire says, amazing job. You're asking the same question. Same data in a different format. Nice job, Thomas, right there. You guys got it. You know what's going on. Relative is just relative to a percentage, and then frequency is just the count. Think of frequency and count as synonymous words. That frequency and count are the same word. Nice job. Thank you for all those yeses in the chat. That really helps me a lot. If I see no's, then I'm like, okay, we got to go into further detail. So what do we have going on right here? You kind of do. You can make one or the other. I can make them very quickly in the program. You can see them right here. We've got bar charts right here, which previously we had a table, just a relative frequency table. And now we have a frequency bar chart. And down below, we have a relative frequency bar chart. So relative is still categorical. So the key term relative right there, amazing question. Thank you for that question, Josh, right there. Relative only means that we're changing the scale on here so that it's in a what? I want to see in the chat. Relative only means that the scale has been changed, that it's what? What does the relative change about this? If it's just a frequency versus a relative frequency, what changes about it when it goes from, exactly, everyone gets it. Relative just means we're going to change it from a count to a percentage. That's just the change right there. If we say relative frequency, you can do it from 0 to 1, or you can do it from percentage. You guys got it. Ben, nice job right there. So let's make Logan and Natalie a mod right there. Oh, trying to scroll up, making some more mods. And thank you guys so much. I love the positivity in chat, and I love the answers because you guys are doing amazing. Remember, you guys, I think a lot of you are going to be maxed out on points within like a week. And I'm like, just don't stop coming to class. I should have put the threshold higher, but I didn't. So you guys get to get all the benefits of that. So bar charts and pie charts. Remember how I was saying pie charts and bar charts can display the same thing? Here, we're displaying the classes of people on the Titanic. And look, instantaneously, bar charts, pie charts. Boom, you got it. Bar charts and pie charts display the same type of data. Same data, bar chart, pie chart. Same thing, just displayed differently. Pie charts are not really a favorite amongst statisticians because if you look at this, like look at this, what are those? Old memes, that's what they are. So right here, we have two kind of slices of the pie, and it's a little hard to tell which one is bigger, but if you go back and look at the first and second class, you can see that it's pretty easy to tell that first class has more in it than the second class. So it's way easier to tell with the bar chart that first class is higher than second class. Back at it again with those pie charts. Damn, Daniel. Exactly. So old memes. I was like 4 years old. So exactly. Pie charts are not a favorite among, I would say, statisticians. You can still use them, but I don't know. I mean, it's all right. It's just preference. It's all good. So would there ever be a time when one would be preferred over the other? Bar charts are kind of usually better. Like bar charts are sometimes just easier to read. I don't think you'll see a lot of pie charts in journals or in. I mean, I say that, and this one's going to show me like they're used everywhere. Um, a histogram is a bar chart for quantitative data, but I wouldn't call a histogram a bar chart, but it kind of is. So great question, Isaac, right there. Histograms are quantitative. If you notice, histograms aren't in our thing right here. So histograms are bar charts for quantitative data, but I wouldn't say bar charts display quantitative data, but a histogram is going to be like a bar chart for quantitative data. So you'll see that, and it'll be coming up here at the end of lecture, but really great question. So there is a difference. Yep. Bar charts specifically mean categorical data. Please remember, this is huge on this slide, that everything right here is categorical. Oof, that's way too dark. Everything right here, so she can't really, doesn't make it look nice and clear. So everything right here is categorical. That is something you must identify with everything we're talking about. Bar charts, pie charts, frequency tables, all this good stuff is categorical. Ring charts, once again, ring charts are just a thing that exist. Other than knowing, great notes right there, Isaac, great notes. Univariate category and histograms are quantitative. You got it. So here's how you make them inside of Jump. I know I'm going a little quickly through these slides, but they're mainly a reference, and I do have videos on how to do this. So if I go through slides quickly, like if I'm like, here's how you do it inside of Jump, it's just because if you want to go back and do it inside of Jump, analyze, distribution, all this good stuff. And I do have videos going over each one of these, so don't worry. There's a very isolated video I have that shows you here's how you make a bar chart, here's how you make a pie chart. This kind of looks like a histogram, but you can tell because it has class level and everything on it. This is definitely, here is a frequency table, and this right here is a bar chart. So let's do a different color right here. This right here inside of the purple is a bar chart, and then I've highlighted the frequency table in the yellow. Pie charts, you can make them, but I don't know. Here's a bar chart in Graph Builder. Great thing that we have inside of Jump right there. So that's that. Here's using the tabulate. I've got a lot of good videos on tabulate. So once again, this is a frequency table, which if you notice, what's highlighted in yellow right here. So there's the frequency table in yellow right there. I'm not liking this new annotate as much. I'm getting used to it slowly. And here's the frequency table here. This thing, you got a color coordination. That yellow thing right there is that yellow thing there. And this purple thing right here is the same exact thing as this purple thing. There's a lot of ways to do the same thing inside Jump. Between a histogram and a bar chart. Great question right there. A histogram is quantitative. It's kind of pink, isn't it? Pink, purple. A histogram is quantitative and a bar chart is categorical. They both display one variable. Jared, great question. Definitely not a dumb question. So histograms are univariate quantitative and bar charts are univariate categorical. We'll cover that a lot today. So remember, histograms are quantitative and bar charts are categorical. Big thing right there. Big thing. That's a huge difference between the two. I know I said a histogram is kind of a special case bar chart for quantitative data. It's just kind of the way it works with the bins. More on that in a little bit. Does that make sense, Jared? Histograms are univariate quantitative. Bar charts are univariate categorical. Big thing right there. And I really think this slide right here, I keep going back to it, is a great summary of what we're talking about. And histograms also start off with the y-axis while bar charts do not. Yeah, I think you're right. Devin's kind of right on that too. Nice job, Devin. So let's go down, down, down. There's a pie chart. Cool. I don't like them. And I think we have the Pareto coming right up. Here we go, Pareto. Boom, Pareto. Not yet, though. More about Pareto in just a moment, but look at this pie chart. Now, you would think that these things don't exist out there in reality, but I promise you, I have seen, and I'm going to go take a I'm going to go take a snipping tool. So I was trying to say a snapshot. Let's do this. You would think these things don't exist, but I swear, and this is an actual picture, and I can't believe these things happen. So this is a 2012, and I don't think there's any bias in this, but this actually appeared on a news station right here. So look at this right here. This actually appeared. I cannot believe this. I'm just like, really? Don't worry. Multiple places do things like this all the time, and we see all these bad statistics right here. So Yes, it's like, what is going on? I don't think there's any agenda to this. It's just like, what is going on? So exactly. I like it. I know the interns, I love it. I love it. Do you think the person who was on air was like, okay, 60, they're like looking at it. I'd love to see the video that goes along with this. I'd hate to think that I got duped and it's fake. I know, like, fake news right there. I'd hate to think that this is fake and someone posted and was like, look at this thing that appeared, because I've never seen the video going on it. You guys can Google it if you want, figure it out. But yeah, I don't want anyone to think I'm getting it. It doesn't even like because there's no agenda here. It's just a bad graphic. Um I know, how did that clear? I probably agree. Nailing did the math. 63 plus 70 plus 60 equals 100. If it's on the news, yeah, that's true right there. That equals 100. Nailin's right. Over 100% of Americans. I love it. I love it. So it's so cool, and that's the power of snipping tool. A lot of people were probably fired. Probably one intern. Yeah, that'd be pretty interesting right there. Did it on your calculator? Yeah, Nealon, you're right, man. That's the calculator doesn't lie. It tells you what's up. Can't drink marijuana alternate within the student. You're right, and that's the thing right here. Is because you kind of notice. That's why I like to point out that graphic. Is there's a lot of similarities. I like that, Jack. Because heavy drinking and use alcohol can overlap. Use marijuana and use alcohol can overlap. And so you've probably got these overlapping categories. And this is just, if you notice right here, the 50% doesn't even line up. They say the 3D option's really bad, that you shouldn't use like 3D options for graphics. There's so many like ins and outs of making graphics. And has anyone ever heard of a program called Tableau? Has anyone ever heard of Tableau? Tableau, I actually have a student who works at Tableau now. They emailed me to tell me about it. I was like, that's so cool. I think Sarah has. Tableau is a really great graphical software. Making Graphic, Mona's heard of it too. So has Taylor. It's a really great graphical software, and making graphics is very important. Knowing how to make great graphics. That's so not true. Oh, I wonder, what do you mean, Isaac? You'll have to tell me. But yes, making graphics is a very important skill, and I really like making graphics. It's very, very important. So we've got one more 3D visualization. So I guess it depends. Isaac, yeah, tell me more. Say that I'm wrong. I like that. I like when someone says, I disagree with you, Brian. I'm like, ooh, why do you disagree? I think 3D can be useful. Let me say it this way. I think 3D can be useful, but should never be included kind of for the fun of it. Thank you, Coleman, right there. That'd be fun to do a podcast. We want to do more interviews and stuff. So thank you guys. You guys are so positive. I love it. Let's go right here. And I will say this, right before we talk about Pareto, I noticed that there was like a, what was it? A 260-second delay. And so I'm going to remember this. I'm going to go back to this video. Okay. So there was a tiny bit of a delay, more than I liked, on the audio and the video in yesterday's stream. And I went in and fixed it. So I should be like, when I snap or something, I should be on cue with everything, because I went in and put in the delays in the video, and the audio should sync perfectly now, or as best as I could get them. I like synced it like 3 times. What do you want to find cross-section data between 4 different variables? Oh yeah, oh gosh. Isaac, amazing answer right there. Isaac, you're totally correct that you would need some sort of 3D visualization. You'd probably get multiple plots. That is a very good advanced question. Graph the data in 3D space and find most dense regions. Oh yeah, that's like a surface plot right there. Isaac, amazing. Chicken. I do not know what that is, William. I do not know what that is. But yes, that right there is an amazing visualization. Do we need to do that? No, we won't be doing that in this class. That is a really good advanced question. And I always like the advanced questions. So ask them if you have them. I've got people doing really just like, they'll teach me things, and that's how I learn too. I told you guys about the TI calculator yesterday. You guys, topography, you got it, surface plots, all that great stuff. Especially, you might be using ArcGIS or stuff like that. A lot of really great stuff if you're doing like, actual surface plots. So and don't worry, these are not ArcGIS stuff. So we've got a Pareto chart right here. It was a joke about the Pareto. Oh, I get it. Sorry, William, it went over my head. Just so we've got the Pareto chart. Okay, you guys ready to learn about a Pareto and understand what they mean? We had our 5 seconds of fun. What is a Pareto chart? Here's the way to remember every time what a Pareto chart is. I want to see it in the chat. You ready? Put them in order. Pareto, put them in order. Put it in the chat. Pareto, put them in order. Who's got it? I want to see some people saying put them in order. Let's see it in the chat. Pareto, There we go. Neelan's got it right there. Put them in order, Thomas says. So does Nadai say it right there. And Emily and Joshua. Or Josh, sorry about that. So we've got all this right here. Put them in order. What are we talking about? Put them in order. We're talking about all the bars. Every one of these bars right here has been put in order. So if you look at them, it's just a bar chart that's been put in order. Now, it does have a bunch of kind of extra niceties sprinkled on top of it. It's got right here a kind of frequency right here. There's the frequency, which is weird because it's got decimals. I've never liked that about this, but this is from Wikipedia, so it's got to be the best one. It actually is the one from Wikipedia, no joke. So right, you've got the percentages right here. So you've got a relative frequency scale, and you've got a frequency scale, and then you've got a cumulative right here. This line right here, which is not necessary, it's just extra, is a cumulative, either relative or cumulative. Well, there's the relative, excuse me. Cumulative relative or cumulative frequency. If you notice right here, it's like we stacked the bars on top of each other. So would that affect, it's still, and great question, Camden, this wouldn't be bimodal or unimodal because it's still kind of Wikipedia's getting your degrees. Exactly. We wouldn't call this bimodal or unimodal because it's a categorical variable. It's a categorical variable, so this will not be bimodal or unimodal, but get ready. In literally seconds, we'll be talking about that topic here. Does it make sense, as best as I can draw these bars, that if you look at them, they're just stacking up right here? Don't worry, you don't need to know how to like perfectly draw these things, but what you should know, here's the big takeaway from this. Bar charts, pie charts, because those two go together. Favorite bars, favorite pies, remember that? Bar charts, pie charts, favorite bars, favorite pies. Paretos and tables or frequency tables all display what? You guys say in the chat. Bar charts, pie charts, Paretos, and frequency tables all display what? I want to see the full thing. I want to see the full thing. Who's got the full thing for me? Bar charts. You got it, Emily. You're so close. We need one more thing before it. Everyone's getting so close. Everyone's saying categorical. You are right. That is a correct answer. Univariate Scholar says, amazing job, Scholar. You got it. Univariate categorical. So if you notice right here, these are all univariate categorical displays of data. And that is the biggest thing. I didn't mention ring charts just because I don't use them. I don't know. I'm not going to put that on the test. Don't worry. Ring charts. It's in our book. It's in the notes. I don't know. I don't like them. I don't use them. So don't worry. I'm not going to put that on the test because there's better displays in my opinion. So I don't use them. So we got it in the chat. Nice job right there, Jose and Valerie. Amazing work. Elizabeth and William and Cooper and Josh. Great job. Thank you guys so much. I love it when you guys are answering, following along, getting those points. So many people are already over 200. That's insane. But guess what? It is time right now to get to the thing we were doing in all the notes yesterday. We're going to switch topics right here. All of a sudden now, we are now going to display quantitative data. So I need you guys to help me out here because Brian just forgets everything every day. It just goes right out of his head right there. Tell me, what is a quantitative variable? Like what's an example of one? People are already over 200. My gosh. What is a quantitative variable? What, like height? Nice job right there. Be careful. Social security number would actually be an identifier. Great job, Olivia. But it'd be an identifier because it would identify people. Like you could identify someone by their social security number. Actual real numbers, yes. And although social security numbers, net ID is probably also going to be an identifier. Think about this. If you want to think about something being a quantitative variable, think about someone gloating to you that their net ID is bigger than yours. Be like, my net ID is 5 higher than yours. You'd be like, it's just an ID. It's just an identification number. But then if someone said, my GPA is 2 points higher than yours. Well, what do you have? A 6.0? I have a 4.0. Oh, no, I'm not saying I have that. But Aaron Rodgers touchdowns. You got it. Like touchdowns for quarterbacks. Exactly right there, Claire. Great job. Amount of employees at Google or another companies. You're right. So you could say like, I guess that might actually, let me think right here. It would be depending on how you did it. If you did like amount of employees at a company, that would be it right there. But if you asked them which company do you work for, that'd be categorical. So if you say like how many employees are at a company, you could take data from all the top like 500 companies, and then you'd say how many employees are at the company, and that'd be a quantitative question because you would collect that. But then if you ask people what company do they work for, that would be categorical. So it can easily shift between the two. Always look to the question. Number of bones are broken. Right there, Isaac. You got it. Salary, things like this. Because someone might say, I've broken more bones than you. If you can ever put something in the account of more, like Alyssa says, how much money do you have in your bank account? If someone can say, I have more money in my bank account. number of points on my license. Oh no. So things like that right there. Exactly. That would be, I have more points on my license. Like, yes, that's not a good thing, right? Number of places you've lived. Exactly. Like number of homes or states you've lived in. All those things right there. Years of experience in the workforce. Great job. You guys know what quantitative is. It has to be a number that you can kind of do mathematics on. Here's the biggest trick that I kind of use in my head. If it makes sense to do something like this, it's quantitative. If this distance right here makes sense, when you do 10 minus 4, number of people in the chat, you got it, Devin. Like we can say like how many people are in a stat to a 1 stream, and then I could make a graph of that. I could say like here's the distribution of what we see for people in a stat to a 1 stream, and hopefully we see something like this maybe for especially for the summer, where maybe our streams kind of look like this. Does this make sense? Can anyone tell me if this was the distribution for stats 1 over the summer? Could anyone tell me about how many on average we would have? See, that would make sense right there. And that is a histogram. A number of people sub to stat 1, you got it. Sub to stat 1, like the streams. Woo! 55, 60, you got it. Somewhere in there, the center's about 55, 60. I guess it'd be about 55. Somewhere in there, the 50s or the 60s. Like mid 50s, I should say. I shouldn't say 50s or 60s. 55 or so. All right, you guys got it. You know what's going on. Amazing answers. Remember, when you're talking, when you're interacting, you're getting those points. And that can be up to 2 points on your final grade. And so many people are going to get that bonus with the way we're heading. I like that. So, what do we have? Dot plots apparently isn't a word. That's all right. We'll just go here, click it, and ignore all. Now dot plots is a word. Okay, so we have histograms, stem and leaves, and we have dot plots. There's another one right here. I should add this. I want you guys to see it. I think we can do a whole section on it. Box plots. I think that's going to be chapter 3. Box plots. I'm adding it in right here. Let's put chapter 3. I think that's where they put it. They recently reorganized our book, which I've been teaching from the same structure for like 8 years, so I get slightly confused. But I do want to mention that right here. We will go into more detail on box plots, and I kind of want to do this. I'm going to put box plots. Let's go right here and put it right there, because box plots and histograms are pretty much best friends. So when you think about a box plot and a histogram, they're going to display the same type of data. Now be careful, we had bar charts and we have box plots. But a histogram and a box plot, just so you can see what's going on, let's do this. Let's change screens for just a moment here. And let's bring up some data. You can instantaneously see a histogram and bar chart right here. Now I want you guys to tell me, I'm going to choose a variable right here, and I want to make a histogram and a box plot. I said the wrong thing a second ago. A histogram and a box plot. Should I choose tip amount, time of day, payment? Oh, thank you so much, Devin, right there. Married, age. What should I choose as a variable? What should I choose? Any ideas for what variable I should choose? Should I choose tip amount? What variable should I choose? I don't know. I forgot. We're going to make a histogram. Age, you got it. Because these are quantitative. Does everyone see how the blue is quantitative? This is ordinal categorical, because day can be put in order like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. How did I forget? I'm forgetting my Spanish right here. I think of it because in Spanish you do Monday first. Lunes, martes, miércoles, jueves, viernes, sábado, domingo. I think that's right. So any of the blue ones, you are right. Nice job, Isaac. These mean quantitative. So let's go ahead and take age. This is categorical nominal. This is categorical ordinal. You see how it goes in order. And this is categorical nominal. And it kind of looks like a bar chart. So we're going to take age right here, and then we just click OK. And then look, what do we get right here? We get a histogram and a bar chart. Oh my gosh, I said it again. Histogram and a box plot. Histogram and a box plot. To see the difference, if we were to go to Analyze Distribution and go to Married, you would see right here a bar chart. That's actually a bar chart. Now I'm talking correctly. There we go. Let's just put them side by side so we can see the difference. I think this is kind of what Isaac was alluding to, is that you'll notice that they're both kind of green right here. You'll notice that we have a bar chart, but it's categories on the bottom. Where on the histogram, you've got an actual numeric axis right here. And so this is quantitative because we have age, and this is how old someone is. And then we've got married right here, and this is just a group. So this is categorical. Was someone married or not married? That was the question. Here's the people in the married group. Here's the people in the not married group. And you know what's even cool? You can kind of see the different shapes of the histograms for the married or not married. You can see the ages of, and look, what do you notice about the married people? What do you notice about the married versus the not married when you look at the data? This is one of the cool things about Jump. That's why it's like a decent program to learn. Do you see the difference right here? Bar chart looks like it's difference. Married would be nominal. Great job, Mona, right there. The not married are younger, and the married are older. You can see it like we've got someone here 70, And then if you look, you can just see the distributions. You can see the within. So it's pretty cool right there. And in R, you can even do cooler things. You got it, Andy. Married or older. So it's pretty fun. You can even highlight this right here and see kind of the distribution of this age. You can just kind of go down and see like where these people are at. So pretty neat on how to do it. And this is the box plot up here. I better make sure I don't say the wrong thing. So that is how you make some quick graphics inside of Jump. And that's kind of why we use Jump. Pretty fun and easy to use. So let's go back here to our lecture screen. Cool. So that was a histogram and box plot. There's a married person. We'd call that's definitely yeah, I think I kind of changed the data. I'll tell you more about that data in a moment here. Well, I'll tell you, Mark Rober, who has the really great channel, Mark Rober, I think his name of his channel is Mark Rober, but I kind of like changed his data, and I might have made a mistake because I think I like changed his data so there was more things to find, but he collected data from his hairstylist. It's at one of the end of his like science fair videos. He's like, if you want, analyze this data I have. And then I analyzed it, and there was like really not much to find. And they actually didn't have it posted. And I emailed, I know Mark Rober is awesome. I emailed his team, and they sent me the data. And then they posted the link, so the link was working again. I don't know if they removed it because the data was, I hate to say this, it was kind of boring, which means there wasn't much to find. And so then I kind of altered the data. And I think I went through and I was like, married, not married, and I didn't look. So then I created something like that. So there's mistakes in data, and I did kind of tell that. That's awesome. It's hilarious. It's a good job, Isaac. Okay, so what do we notice right here? You guys are fun in chat. Stem and leaf plots and dot plots. These are your main types of graphics for quantitative univariate data. Quantitative univariate data. So quantitative univariate data. Let's take a look. We've got earthquake data right here, and we've got the magnitude of an earthquake. I want someone to report for me. Like, tell me the magnitude of an earthquake you've been in. I think I've only been in like a 3.4 or a 4.4, and I always kind of notice it when it happens. Even though it's only like a 3.4 or 4.1, like, there are 4 point. I wonder if anyone's ever been in a big one. They'll have to tell us. Because there was an earthquake in Knoxville, like, middle of last year, maybe 5. 5's now, you're going to feel a 5, I would think. Or, oh my gosh, 6. Now that's scary. We're getting into the scary territory. But there was like, it's like, I know that when we had the one in Knoxville, I was like, I noticed it and I was like, that's weird. It's like, you just like, did like the room just start like vibrating or something? And I was like, what's going on? Yeah. And I kind of noticed it. And then it like, people like my sister like was like, we're in an earthquake. And I was like, what? There was one a few months ago. I guess that's what it was. It's like, it's so weird. 1.5. Yeah. So does everyone notice right here that we're giving actual real numbers? We can say like, let's see right here, woke you up. There we go. So we see right here that Camden was in a 5.0 and Matthew was in a 6.0. We can actually take the differences between that. We can take the difference between the 5.0 and the 6.0 right here. Now notice how this is a frequency histogram, and this is a relative frequency histogram. Frequency histogram, relative frequency histogram. What is the only difference between the frequency histogram and the relative frequency histogram? All of a sudden, our knowledge that we learned a moment ago is helping us out between the frequency histogram and the relative frequency histogram. You got it. It's just in percentages. That's it. When you say relative, it's relative to a percent. Elizabeth, nice job right there. It's relative to a percent. So this just means it's in percentages. Woo! Yay. Percentages. Awesome. And this is just, it still is like the count. And here's where I think people get confused. And please slow me down if these graphics don't make sense. I've seen them 100 thousands of times. And so I'm used to it. If you notice this right here, there were something like 230 histograms in this bin. I'm going to zoom into it a little bit here. I'm going to have to fix the screen when I zoom back out. But this bin right here, hopefully I didn't just make it look horrible for the rest of the class, because I'm going to have to fix it later. This bin down here, that bin has like 230. I think when I do it so small, it doesn't like it. It's like, did you mean to do that? That bin, which I've over highlighted now because it won't let me get little tiny highlights. I'm going to fix my pens later. That bin down there that I'm hovering over, to make it very clear, this bin right here, that bin right there, has about 230 or so earthquakes in it. And I want you guys to tell me The earthquakes in this bin range from what to what? The earthquakes in that bin range from what to what? This bin, right? Oh my gosh, now it's way too wide right there. This, no! The pens changed, and they will not let me do little tiny things now. I'm going to stop complaining about the pens. Don't go away. Good. Stayed. 7 to 7.2, you are totally right. And I will say this, when you read from left to right, it would be, in technicality, it would go from 7.0 to 7.1, infinite repeating. And exactly. So technicality, 7.2 is the start of the next bin. That's not going to be on the test. For all intents and purposes, it's just like a super technical thing. I don't care about the super technical. It might as well be 7 to 7.2 because numbers don't exist. We could talk about how a number is an infinitesimally small point, but if there was a 7.2 earthquake, it would be in the next bin. If there was a 7.2, it would technically be in this bin right here. A 7.2 would be in that bin all the way up to 7.39999. So you start with the leftmost number on it, and that's like the leading number in the bin, and then you go up to, but not inclusive of the last number. So there's a very technical thing right there. That's not on the test. I think you guys understand what's going on right here. Look at all these earthquakes down here where we don't have that. Coleman, nice job, Coleman. I love it. He didn't put enough 9. Numbers don't, each number does not exist because it takes up no space. There is no space that a number takes up. Not Tristam knows what's up. Tristam's got it right. Not enough 9s. You're infinitesimally short on your 9s there, Tristam. I mean, Coleman right there. Sorry. Tristam got it right. Don't worry. But you guys are doing great. You know what's going on. We got it. So let's zoom back out and hopefully things look right. There we go. I got it. Fixed it. Yay. I set that up really nice and neat. And then I was like, please don't break. I worked so hard to make it look like it's one screen over here. Okay, so yes, this is how you do it inside a jump. This is what you just saw me do a moment ago. Once again, these are just slides showing you like, hey, here's how you make it inside a jump. Cool options. So, yep, go back to these slides if you want to make it inside a jump or watch me do it. I believe in numbers, so no one will say with me. Stay believing in numbers. I like numbers too. Any good statistical software will automatically pick the bin widths. So what you notice right here, what are bin widths? Bin widths are the thing I was just talking about. In the previous example, the bin width was 0.2. If you look back at the answers everyone was giving, all those previous answers are 0.2. Where if you look at the bin widths on this top one, what are the bin widths here? Now I'm gonna put 2 confusing things. Now be careful. Be careful. Who thinks I put a trick? Whoop. Nope. Don't do that to me. I don't like the new pens. I don't know why that keeps happening. There's a ghost. So what is the bin width here? Be careful. I tried to trick you. I'm trying to trick you. What is the bin width here? I will give the answer and I'll make it less confusing, but I've definitely tried to trick people here with this. Thomas, you're totally right. It is 2.5. Let me try not to trick people now. The bin widths are literally the widths of each of these. These are bin widths. Please don't disappear as I draw each of these. Gonna fix the pens later. I'm gonna stop talking about it too. Those are bin widths. So does everyone see that the bin widths are like the length? Just think about this. Each one of these is a bucket. Like if you think about this as a bucket right here that collects the data, you can see like how many things are inside of that bin. It's like a bucket where you put data inside of it. It's kind of like a bar chart, not really a bar chart, but the idea of like it collects the data from 65 to 67.4999. So exactly. Does everyone understand how bin widths work? Now this bottom one is always the not fun one. We can just say that the bin width got bigger. This is a horrible test question. I would never use this bottom one for bin widths. The bins here look to be something like maybe, if you look at that right there, that's like 3.75. Stop trolling me, new pens. 3.75 or so, something like that right there. The length of the bin at the bottom right there. So don't worry, I would not make that a test question. I think these ones up here, here's a super easy one on the bottom. What is the bin widths of this one over here? What is the bin widths? If you know bin widths, you can tell me. Space Pen, I know. Space Pen's going to return tomorrow. It's like an Avengers thing. Like Space Pen will return tomorrow's lecture. Somehow my pens changed. There's like a new option for it. Space Pen will return tomorrow's lecture. One, you guys got it. You know what's happening. Don't be tricked by this. I'm not trying to trick you. It's just how graphics are displayed. So maybe like, Brian, don't put that trick on the test. Well, I think this would be a very, very fair test question. Let's see. Sarah's got a question. But what is the significance of bin width? Great question. So bin width will change how the graphic is being displayed. These right here are both the heights of individuals. We got the heights. It almost looks like I can point over there. It'd be so cool if I could break the barrier, but I can't. It's a barrier. I can't get through it. So we've got the heights of individuals up here, and then we've got the heights of individuals down here. Now, if you notice, it's the same data. How can it be the same data and look different? Well, I'll show you. Let's hop back. Let's do a screen transition right here. And let's do some data right here. So I'm going to change the bin width inside of R, inside of jump, for people's ages. So we're going to take this graphic right here, and we're going to change the bin widths. So to change the bin widths inside of jump, you take this hand tool right here, and you just pull up or down. So if you notice, it drastically changes how the data looks. You could put everything inside of one bin. So if you now look at this data right here, this data, it changed it for me automatically because it's like, do you really want that? And I was like, yes, I do want all the data inside of one bin. So now this is a bin that goes from -20 to 80, and it has every single observation in the data set. Let's go here and put in a count access. And now this is all the individuals in the data frame, which is 232. Does everyone notice how it says there's 232 people in here, and this bar would go up to probably about 232 here? Who thinks this is a good way to display the data? Who loves this visualization? And it's like, that, Brian, that, you got it. That's your visualization. Keep it. That's how I'm going to display my graphic. That's how I'm going to talk about it. We're going to just show everybody like that. It's great. Camden says, excellent. You guys got it. This is what I want on the projects. No, don't do this. Whatever you do, don't do this. If you notice, the box plot up here does not change. No, oh, there we go. And look, now I'm making smaller bins. And look at the scale. Does everyone notice that the scale on the right changes with it? Because when we have all 230 people, I'm missing some people. There we go. Now they're all in one bin. But notice the scale on the right gets smaller because it kind of goes up to the top bin. And now there's only like 70 people in the bin that is like the lower 30s. So if you notice, that's kind of where the median is somewhere in here. So you can kind of get all the information very quickly, and there's about 70 people. Does everyone understand that this is the count of how many people are in each one of these bins? That's a key thing to identify right here. Like, it's like, oh, there are 70 people who have ages starting here. It's probably 30 to 32.5, probably. We'd figure it out, but don't worry, it's not that important. There we go. This is much easier to understand. This would be 20 to 30, 30 to 40. The bin widths here are 10. Can everyone identify that the bin widths are 10? And you can actually fix this if you go here. And now let me go to the OK. And there we go right now. So that's probably a much better way to display it right here. We have each bin width. Oh, did I put in 5 for the bin widths? Oh, I put in the scale at the bottom. Where's my bin widths? Huh. Increments, 10. Minor ticks, offsets. Well, why can't I? Oh, I need to change the bin widths the other way. So let me do this. There we go. Okay, now my bin widths are 10. I'm going to pull the scale a little bit here. I'm going to pull it right here. And there we go. That's probably how I'd want to display it. I don't like it when the bars hit the very edge. So do you want smaller bins for histograms? The good news is, here's the amazing news, Camden, is that Jump will do a kind of what it believes is the best way to do it. This is in art, not a science. So when Jump makes it, it will kind of choose the bin widths for you. So here is what Jump chose by default for me. Here's what Jump chose by default. And here's what I created. So if you look at the similarities between the two graphics, it's displaying the same data. It's the exact same data. Both of these are the same data points. If you notice, the box plots at the top are identical, but Jump chose this one, and then I created this one right here just by preference. So bin widths are in art, not a science. There's no, I mean, you can do really bad art. Like everyone, I know we say art is just preference, or like art is purely subjective, but this is bad art. This is bad art right here, and this is bad art. So you want something where people are kind of like, that's still bad art. This is good art. That's good art. That's, I don't know. Someone might like this. I don't know who would like that art, but that art is a little not so great art. Does that make sense right there? That the bin widths just control kind of how big we set our setting for where the data is put inside of it. So there's no exact answer to it. So you just want decent art? Yeah, decent art. Because unless your art is really bad, There's some bad art out there. If you make some bad art, I'll be like, that's some bad art. I should put that. I should put that as like my comment on your project. Bad art. So these are kind of bad art right here. This is, let's put a grade on this art. This art is kind of C work. I wouldn't love this art, and this is F work. They didn't do like one bin. This might even be like C minus. The one on that got a C minus is better than the other one. I don't know. It's so subjective, but you're pretty much all right to let Jump use the defaults. So don't worry. Jump puts in pretty good defaults. If you put in the defaults, you're probably all right. Okay, right here, what do we see? Wait, Brian, these are numbers. I need people in the chat to help me out and start getting some points on this. Remember, you get points when you talk. These are numbers. But what kind of data is this really? It's policy number. Like when I call up State Farm and I'm like, hey, I'm calling about, you said you would pay for my rental, or you pay for my tow. Which they did, and then they didn't. Not saying that happened. Sorry, company that I didn't name. Identifier, exactly right. Identifiers. Those are identifiers right there. They're not actual, I mean, they're numbers, but they're not like numbers like the way we treat numbers. They're numbers that identify a policy number. So they're not real numbers. Sorry, numbers. You're not real numbers. But they're not like, it's not like, haha, my policy number is more than yours. Cool story, bro. So we get to one of our last graphics today. Well, we got a lot more, don't worry. We get to stem and leaves right here. Where we got to slow it down. This is my slow it down stance right here when we talk about stem and leaves. Now, wait a minute. Stem and leaves are what? Everyone have in their notes right now. Stem and leaves display what kind of data? Like box plots and histograms. Stem and leaves display what? Box plots and histograms, stem and leaves all display what? Box plots, histograms, stem and leaves, univariate quantitative. Kyle, you're exactly right. These are all univariate quantitative. I know it says quantitative right here, but stem and leaves display univariate quantitative, one quantitative variable. Now, here's the coolest thing. This is what I was trying to do yesterday. If you stayed yesterday, you should know that if you were to just take this right here and display it like this, what do you notice about the histogram and the stem and leaf? Like, I wish we could just like, we can bring it, we're gonna have to shrink it down a little bit right here. What do you notice about the two of them right here? And actually, we need to flip it because the axis is wrong. Let's go to picture tools. Let's flip it. Where is my rotate? There we go. Look at that. It is reversed. But what do you notice about the two of them? It's almost like a stem and leaf is a histogram where you can see the numbers. Does everyone notice this? And there is some skewness. Nice job right there, Keaton. Basically the same thing with the same skew of the data. Exactly. So stem and leaves are just histograms where you can see the numbers. Does that make sense to everybody? A stem and leaf is just a histogram where you can see the numbers. So we should be able to do this pretty instantaneous. Let's hop back over to Jump and see how quick and easy this is. We're going to go back here. So let's make a stem and leaf. We're just going to go here to Analyze Distribution. We're going to go to people's ages. And we've got the histogram right here. We're going to go to Stack. Just makes it look nicer. And then we go here to Stem and Leaf. That's how quick and easy it is. And what do we notice when we get the stem and leaf? Whoa! What is this? What is this? Can someone explain to me? Is there someone here who is 70,000 years? Wait, there's a count. Count is the frequency or something like that. What is going on with this? 03 represents 3? What? Why are there all these zeros here? Oh, Jared says there's 4 people who are 70 years old. It's like we had 4 people who were 70, which we could probably go over here and look at the histogram. And whoa, wait a minute. On this histogram right here, what do I notice? There's like 4 people who are 70. Whoa, I didn't even know it would highlight it over here. Can you click that? Whoa, this is so cool. I can't highlight like that. If you notice right here, these are the people in their upper 40s, or did I get I got the lower 40s, excuse me. So that's the lower 40s, but there was nobody in the upper 40s. If you go here to the teens, let's go ahead and highlight the teens right here. And I like doing this kind of visual stuff here because I think it's nice and easy to see. I'm blocking it. Notice how it's highlighting the upper teens right here. So these are the upper teens. And these are people who are 15, 15, 16, 16, all this stuff right here. Thank you so much, Joseph. It's really, I'm so glad. Someone once said to me, wait, you can do all this stuff live? And I'm like, yep, we can do it live because we love streaming. So there are 13 people who are in their upper teens. There are 13 people in their upper teens right here. And you guys know what's going on with all these people in their 70s right here. The oldest person in this data set was 70. The youngest person in this data set was 3 years old. Then you have people who were 10, 10, 10, 10, 10. Each of these represent somebody's age. Someone explain to me in words what this means right here. In words, what does this mean right here? There's one computer and 2 screens right there, Camden. There's 2 screens. I've got a tablet and I've got a really nice Sony monitor or Dell monitor. It's a very good Dell monitor. So, got a screen here, a screen right here. So you can see this screen at the bottom of your screen right here. No one in their younger 60s. And it's not just 60 years old. There's no one from 60 to 64. Does that make sense? No one was... Oh, wait, no, I'm sorry. Correct. I'm sorry. I'm very wrong. There's no one from 65, and Ethan's correcting me right there. There's no one from 65 to 69. These would be the individuals from 65 to 69, because does everyone see when you're 70, which is the leftmost number? Andy, 100% right. Nice job, Andy, right there. No one was 65 to 69 who came and got their haircut. Exactly, upper 60s. Another way of saying it right there, Valerie, amazing work. There was no one who came in to get their haircut with an age between 65 to 69. If you notice, there's no count right here. I guess it could say 0, but it doesn't. But there's nothing there, so it's 0. No people in their upper 60s. You guys got it. I always thought stem and leaves were so hard to understand, and then I realized it's just the histogram, which I totally destroyed. It's just the histogram where you can see numbers inside of it. That's all it is, enjoying their gray hair for 5 years. Exactly. We'll hop back right here, do one of those transitions, and we'll hop back to the screen right here. So if you notice, all a stem and leaf plot is, take this note, a stem and leaf plot is a histogram where you can see the numbers. So let's revert this slide back to the way it looked so we can actually read the numbers. Tell me how old the person is right here. There is one individual. Does everyone see how if there was one right here, there'd be one individual? Tell me about this person right here that I'm hovering over. Can anyone tell me their age? How old was this person? This is beats per minute. I'm very sorry. This is people's heart rates, I think. Age, heart rate, number. Yeah, pulse rate. Their pulse rate. There we go. Their pulse rate was 88, or their age was 88, just changing what it is. So if you notice the 8 and the 8 go together right here, does that make sense? This is the 85 to 98 beats per minute. Sorry, this is beats per minute. We went from age to beats per minute. We're taking someone's pulse right here. And so the answer is that this person right here had a pulse of 88. Does that make sense? Tell me this person's pulse right here. Tell me this person's pulse right here. I want to know about this one person. Does everyone see how there's one person? A stem and leaf is more specific, just shows you the numbers. That's what a stem and leaf is good for, and everyone's going to get this is 56 because it's this individual right here. If you notice, it just lines up nice and perfect to that one. How many people had pulses in the lower 60s? How many people had pulses in the lower 60s? How many people had pulses in the lower 60s? Keep getting those points. You're right, Matthew and Emily and Devin. Nice work. You right. There are 4 people who had pulses. Nice job, Laura, right there. We'll make Laura mod 2. Amazing work. So many people watching and following along. You're understanding how to read a stem and leaf. Amazing work. Getting all those points. You guys are going to have like max points in like a week. It's awesome. Joseph, let's make you a mod 2. Okay, so we've got right there what the stem and leaf is showing us. Tell me all the ages of these people. Like these 4 people, what are all their ages? Can anyone put commas between them? Thank you, Jack. I like that. So tell me, what are the ages of these people? Man, you guys already have a quarter of the points. What have I done? Devin, amazing work. Devin, you know how to read this right here. Who here did not know how to read a stem and leaf plot before today, or you had seen them and you're like, this makes no sense to me. I have no idea what's going on with stem and leaves. But now you're like, aha, it makes more sense. I get what's going on with the stem and leaf. It's just a histogram where you can see each of the numbers of the observations. You get it now? That's what I like. I always thought they were so complicated, but I'm like, wait, it's just a histogram where you can see the numbers. Makes more sense. That's what I like to hear. And if it doesn't, please ask. We can go into more detail. Wasn't a fan of them. They're pretty interesting. I will say this. They're better for small data sets. Do stem and leaf plots ever get more complex? You can do back-to-back ones. I think we have one in here, a back-to-back, which I'll tell you about that when we get to it. But, I mean, they don't really get too much more complex. They do have a key at the bottom of them usually. I think we have that coming up here in the graphic. Here's how to do them inside of Jump, which I did. And if you notice, the key at the bottom is very important. The key is going to tell you what the numbers represent. That 5-6 represents 56 right here. That's what it represents. And this 1 means there's one individual. This is just how many observations are inside of here. So there we go right here. I see it now. Awesome. And so This is just explaining. I don't like to read slides. I usually like to, like, this is kind of like a book. So if you ever see me be like, okay, we talked about that, we're good. Now, this is a slightly more complicated version of it, slightly more complicated. I do want to point something out right here, that Professor A, Professor B is a what kind of variable? Professor A, Professor B is a what kind of variable? Professor A or Professor B is a what kind of variable? This is a tricky parts in the notes. Oh, Jack, sorry about that. Glad you caught up live right here. It is categorical. Think about this. Remember, how do we know if something's categorical or identifier? Identifiers can never do what? Identifiers can never do what? An identifier can never what? If we ask someone the question, it's an identifier. It can never, ever, 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 ever repeat. You guys are right. I was repeating, or I was repeating never. Identifiers can never repeat. So someone can't tell us they're Professor A student and then another person tell us they're Professor A student. So we can't have someone be like, I'm in Professor A's class. Well, then they would have to be the student who's in Professor A's class. So because we have multiple students in Professor A and Professor B's class, and just because theoretically there can be, it can't be an identifier. But like a student ID number would be an identifier, or a net ID number. Usually, sometimes identifiers have ID in them. Nice job, Thomas. Glad it makes sense. An identifier can't repeat. Think about this. Can you say the group of students that are in Professor A's class? Yes, that makes it categorical because it's a group. So I don't spend too much time on this slide because we don't do too much back-to-back stem and leaf, but you could go in here and start writing all of these numbers down, like the 92. Let's make it clear. The 92 is represented by this student right here. So let's go and get the student who made the 94, and then their grade would be right here as a 4 right here. And then over here on this side, I might miss somebody. If you were to start filling this in, there's the 97 and the 99. You would go right here. Is there another? There's a 95. Don't want to miss that. And there's another 99. Oh my gosh. So you'd go right here and you'd put 5799. Thing is, graphical software will do this for you. It's not finished. You're right, Claire. This one's not finished. You'd have to start filling it in and start building up the back-to-back. So all a back-to-back stem and leaf plot is 2 stem and leaf plots put together. These are in the assignments. Just knowing how to read them is important. So we will not have you actually make these. It's just a stem and leaf plot for 2 groups. Does that make sense? So you're making 1 stem and leaf plot for Professor A, 1 stem and leaf plot for Professor B, and kind of putting them back to back. So this 4 right here represents someone in Professor A's class, where this 9 right here represents someone in Professor B's class. So you could go through and fill out this whole thing. Can you have more than 2 groups in a stem and leaf plot? You could make like a 3D one where you could like turn it around. That'd be so cool. It'd be harder. I bet there's ways. Sarah, I really like that question because I viewed it in my head. It's like a 3D graphic where you could like turn it and it has like quadrants. It'd be crazy. There we go. More 3D graphics. So the middle number is the single stem. Amazing job, Cameron. Cameron points out that this middle number right here is the stem for everything. It's just like a number line. It's the same thing you've been seeing right here. Let's mark it in green again so we can see. I like the color coding on this. So as everyone knows, this green line is the same thing as this green line. These are not observations. The observations are over here in the yellow. These are the observations. So when you look at this right here, the observations are in yellow, and the green line is just a number line. It's just an x-axis, as Camden says. Just an axis of numbers telling you kind of these are the 50s, the 60s, the 70s, the 80s, or the lower and upper 70s, the lower and upper 80s. And then when you go here, the observations, I'm going to erase this when I do it, but all the observations are over here. Ooh, we got some color mishmash right there. So the observations are in the yellow, and the green line is just a number axis. It's just giving you the context for the numbers. Does that make sense right here? That green line is just an axis that they both share. You could like split them apart if you wanted and put them to their own stem and leaves. I think you get what's going on. That green line is just the same thing as these green lines here. So it's just an axis telling you context for the numbers. What graphs would be better displays of these 2 data sets? I'd probably use, and we haven't talked about this, I'd probably use stacked histograms or something like that. Stacked histograms are just multiple histograms. Yeah, it's all preference. You should just know that here's your big note for this. Like, if you're ever really like, okay, what should I write down, Brian? Back-to-back stem and leaf plots display 2 stem and leaf plots. And so you'd have quantitative data for the stem and leaves, but here's the confusing thing. Professor is categorical. Let's change the color on that. I know I said stem and leaf plots are quantitative, but since there's two groups, the professor variable is categorical because you'd ask somebody, who's your professor? And they'd say Professor A. So professor is a categorical variable. Does that make sense right there? You can do stacked histograms or back-to-back stem and leaves because stacked histograms are like a histogram for Professor A, a histogram for Professor B. So the thing again, Sarah, great question, is professor is a categorical variable. We're making one stem and leaf plot for Professor A, and we're making one stem and leaf plot for Professor B. So a very quick note on this. Let me go to a new slide. I'm going to put a new slide on here. Let me delete all this, and I'm just going to write on it. Back-to-back stem and leaf plots. All stem and leaf plots are quantitative, but back-to-back stem and leaf plot, stem and leaf, is going to be a categorical X, we would say, and a quantitative Y. So the variable you are analyzing, like people's scores, people's test scores are quantitative, but then we're breaking them apart by the professor. So the professor, which might explain people's test scores. Whenever I say the X variable, I like to say explains, like maybe the professor explains someone's test score. So the Y variable, we'll talk about this more throughout class. The Y variable is like, why did people score something on the test? So you do need, for back-to-back, yes. If we just do stem and leaf is just quantitative. All stem and leaves must have some sort of quantitative aspect to them. But if we do back-to-back stem and leaf, they would be broken apart by a categorical variable because you're saying Professor A, Professor B, and maybe that explains someone's test score. And when I say explains, that makes it the X variable. So does that, good job. That's what I want right there. All stem and leaves are what? I want to hear in the chat, all stem and leaves must be this. All stem and leaves are what? And I'm going to ask a tougher question after this. All stem and leaves are this. They must be this. All stem and leaves must be what? Quantitative. And stem and leaves are generally univariate quantitative, but a back-to-back stem and leaf is what? Is it univariate quantitative or is it what? Would back-to-back stem and leaves be univariate, or something else? Back-to-back stem and leaves is actually a what kind of graphic? Multivariate works or bivariate. So this is what we mean by a bivariate display of data. So this is our first bivariate. If you notice, we have variable 1 up here, which is professor, and we have variable 2, which is somebody's score on the test. So this is a bivariate. Does everyone understand what bivariate means? You're displaying two variables. You're saying people's scores by their professor. So that's like a bivariate. You could use that trick too, like someone's score by their professor. And then we want to say, does someone's professor explain their score on the test? So the X variable would be professor because professor might explain the points. And what do we want to understand? The Y question, like why does someone score certain points? That's always my trick to remember which one's which, all that good stuff right there. And so the professors, and so Kyle, I hope not to make it too confusing. Two professors would mean that there are two levels to the professor variable. So the bivariate nature of it is that there's professor and test scores, because we could have 5 professors and test scores, and that would still be bivariate because the professor variable would just have 5 levels to it now. Levels is how many different kind of answers there are to the question of professor. That's a word we use, levels, for it. Like how many different levels? Yeah, Kyle, great question. No, and say everything you're thinking, because that way it really helps. Like the more you talk, the more you think about it. You bet, Jared. We're going to do a speed run of all these graphics right after that. Jared, that is a great suggestion. You got it. We'll do 2 speed runs to cover these topics. So we're getting near the end of these. Dot plots. Dot plots are cool. Yeah. This is what I say when I get to a slide when I don't have much to say, because I like it. Brooke's excited about the speed run there. Dot plots are kind of like histograms. They just put dots instead of it. I mean, maybe some people might like them better. Here's the reason to maybe like them better. It's because how many people are in this bin right here? It might be hard to see with a histogram, but you can tell there's 1 observation there, or there's like 7 observations there. Cool. I mean, it's preference. It can display the same thing. Here's we'll do this topic. You know what? Let's do a speed run right now because we've covered a lot so far. and we're doing great on time. We're doing excellent. This is probably, I'll say this is probably one of the longest lectures of the semester. So I think we will get to lecture 3 today, but this is one of the longest lectures, and we're going to pause right here and do a speed run, and we're going to cover all the different types of graphics that we covered. And so let's do that. Let's do 2 speed runs. You ready? I'm going to try to go sub 4 for these speed runs. Let's get some speed runs in here. You ready? Let's do it. So let's go to the speed run screen. Here we go. Oh no! I don't like that transition. We're gonna I'll tell you why, because right here we got the better transition to speedrun. Let's do this because this one has its unique transition. We're gonna see some Mega Man here. Watch one of the corners. Pick a corner, top right, bottom left, bottom right, and watch that Mega Man. Here we go to the speedrun. Let's do it. Speedrun. Okay, we got our new sheet of paper right here. You guys watch those Mega Mans right now. We got our speedrun ready to go, so let's do it. Okay, for this first speed run, what we're going to be covering is we are going to be covering what are the different displays of univariate categorical data. So that's about all I can say. I'm going to start cheating. There's some rules to this speed run. You can say what you're covering, but you can't start explaining it. You just have to make sure people know what you're doing. You have to declare your speed run, and then you have to do it. So this is univariate categorical data. Univariate categorical data. Let's go. Okay, with univariate categorical data, what does it mean? Let's type it out nice and big here so everyone can see. Univariate categorical data. Univariate categorical data. I'm going to get DQ'd right here if I don't make that bigger. Univariate categorical data. We need to break down this word. Univariate categorical data is going to be one variable. Take a look at that right there. One variable. I love it right there. People are following along and know what's happening. Univariate categorical data is one variable. And we got a problem right here. My pens are not working. I'm going to get DQ'd. I'm going to do one thing right here. We're going to reset this speed run, and I'm going to reset Word because I don't know why today my pens are being so weird. 1 second. I got DQ'd. I didn't have my pens. Pens, are you going to work? You there, pens? Whoa, what is going on? Ink to math. We don't want that. 2 seconds here. I'm going to try to fix this. What is going on? Huh. Well, that makes things interesting. I know, big sads. Why is the pen's not working? I'm moving it. Does anyone know how to get pens working? And it was literally working yesterday. I've got my Ink Tools pens. This is what was going on in PowerPoint too. That's weird. PowerPoint. I know so much. Oh my gosh. I agree. I want to draw them out. I know, Camden. And this is the first time. I don't know if they updated Word or what. I'm going to do something really crazy here. No, I don't know if that'll fix it. Okay, I can do it. I'm going to do it. I think they're going to DQ me on these because I can't draw the graphics, and I always like drawing the graphics. We're going to do it. You ready? I'm so sorry, guys. That's the first glitch today. Don't like that. Okay, so you ready? We're going to restart this. Let's restart the speedrun. Let's get back together here. We got this. No, it doesn't have a battery. It is working. You can see I'm moving the screen right now. It is working. It's just when I go up to my pen thing, the pen options are not there, and my draw tab is not there. So there's no draw tab, and the I just don't know why. I think sometimes it gets a little bit weird on it. Ink Tools, and then it just doesn't have the options. Oh, look. See, yeah, I didn't write in. I just scribbled. So it's all good. Okay, cool. Well, okay, before I spend about 5 minutes trying to figure out what's going on, I'll fix it. I don't know why. Today it just acted weird. Next time I'll make sure when I boot up that the pen's working. First time I've seen this sort of error, but it's like weird things happen live. Okay, you guys ready? We're going to make this speedrun happen. We got this. So let's do this. You ready? Here we go. Okay, we're going to give a #1 speedrun right here because we are talking about univariate categorical data. So let's type it in right here. Univariate categorical data. And we're going to do displays right here because we're going to make visualizations. Thank you very much right there. They believe in me. We can make this happen. Uni means one, and variable means variable. Categorical is the thing we're going to be doing, and displays means we're going to make a visualization of it. So the very first one right here we have is a frequency table. And so let's go right here and type frequency. Now the thing is our pen's not working, but we got this. There's still a way to do it. We're going to go right here inside of jump and make a very small window that we can still see what's happening. So to make a frequency table inside of jump, it's just going to give us the frequency or the count of a variable. So let's choose a categorical variable here, which is red, such as payment method, and let's take a look. Well, we'll bring it on the screen right here, and look what we have. Let's remove this other graphic. This right here, I've even got it highlighted, is a frequency table, which gives the count. Now, this is a frequency table, not a relative frequency table, because it's not in percentages. If it was in percentages, it would be a relative frequency table, but look at the counts right here. That is the count of the people in this bar, and that's the count of the people in this bar, which brings us our next thing right here. The next topic is a bar chart. And you just saw a bar chart. A bar chart right here is still a univariate categorical display of data. Just look at those bars right there. If you notice, we had to go up to someone and say, what payment method did you use? This person said card, this person said cash. But you know what? You can ask people their favorite bars, or you could ask people their favorite what? I want to see it in the chat. Does anyone know while I make this graphic right here? You can ask people their favorite bar, or you could ask people their favorite what? Their favorite bar or their favorite what? Who knows? Favorite bar or favorite pie. You guys are right. We've got favorite bar. We've got favorite pie. You know what's going on. We got a bar chart. We got a pie chart. Look at this right here. Now, I am displaying two different types of variables right here. So if you notice, this is married, not married. We could add percentages to this. You know what? I think we can. Let's hop back into here and go to show control panel, and let's try to put in some percentages on this. I think we can go here to labels, if I remember how to use this. Label by percent. Wow, we've done it. So what have we done? Is this a frequency pie chart or relative frequency pie chart? Is that a frequency pie chart or relative frequency pie chart? It's got percentages, so which one is it? Frequency or relative? Relative frequency, that's what it is. It's relative, where the one right here is just a frequency. This is a frequency bar chart, where this is a relative frequency pie chart. Now, if you're wondering why it's highlighting different amounts, it's because I displayed card versus cash, and I displayed married versus not married here. Two different things, and just to make it very clear, let's show this. Let's display the same type of variable, the same thing we displayed a moment ago, which was card versus cash, which was payment method. Let's go to pie chart right here. Let's go here, go to labels, label by percent, click done, we got it. And now when we click this, do you see it's displaying the same thing? So what do bar charts and pie charts do? They display the same type of data. So we've got pie charts right here. You can make a bar chart of your favorite pie. You can make a pie chart of your favorite bar. And last but not least, we have ring charts, ring graphs. I don't like them, so just ignore them. Hopefully they don't DQ me for that right here. I think we've covered all the different... Oh, we got Pareto. Oh, no, we're not done yet. Pareto. Let's put Pareto right here. Someone might remind me. They say, Brian, you didn't win the speed run. A Pareto chart. We need to jump back here. So what is the only difference with a Pareto chart? I need people to help me. I don't know. I got to go sub 5 on this. What is the only difference with a Pareto chart? What will a Pareto chart do? Where I try to find it inside of jump. Here's the Pareto. Hopefully people can see it. It puts them in order. Paretos put them in order. So let's do day, because day has a lot of levels to it. The green means ordinal right here. So now you notice, boom, look at this right here. We've got highlighted. Let's remove the highlighting. So now the Pareto chart has put them in order. We don't want the bar to go this high. So if you see right here, we've got a count. And we've got the cumulative percentage right there. So that's just cumulative percentage, and that's just count. And you can see most people got their haircut on Saturday. If you're wondering what these lines are, this is just the frequency increasing as though you were to stack the bars. We did that earlier in lecture. Take a look at it right there. But this is just a bar chart put in order. So that's why I kind of put it as a subcategory under bar charts. All Paretos are bar charts. Not all bar charts are Paretos, because it must be put in order. And those are all of our categorical displays of univariate data. Does everyone understand these right here and have them in their head and know what they should look like? If you do, you've done a great job on it. So that's our quick review of those topics. But guess what? we're hopping right into our next speed run, and I can get it ready really quickly by going right here and just going to quantitative. That's got it right there. Next speed run coming right at you. Here we go. So I get to write this. That's fair game. They said I could. The judges have not DQ'd me yet. So let's do this. And we have univariate quantitative data. Let's start with our favorite thing right here, a histogram. Now, a histogram kind of looks like a bar chart. It's not, I mean, it kind of is, but it's kind of not. Don't think bar charts are histograms. Just be like, well, they kind of look a little bit similar. So if you notice right here, we've got a Pareto, which is a bar chart in order. That is not a histogram. The histogram is going to be quantitative data. Please take a look that all of these are quantitative, identified in JUMP by blue. So we can take something like tip amount and we get a histogram instantaneously. Let's make it appear on the screen a little bit better here. And there is a histogram. So the histogram right here is a univariate quantitative display of data. This is the histogram. Histograms have with them bin widths. If you notice, the bin width here is 5. It's not 10 because you look at how big this bin is right here. This bin is the width of it, or that's the bin width of that bin. So each of these are individual bins. We can add a count axis to it. Let's go here and go to histogram options, count axis. We'd even add in a probability axis, which now this is a rather interesting histogram now. This is a relative frequency histogram along with a frequency histogram. The probability would make it a relative frequency, and the count here makes it a frequency. So I've added 2 axes. I'm not a big fan of that, but maybe someone would do that. What do we notice above the histogram? Above the histogram is a what right now? What is above the histogram? I need some people to help me out because above the histogram is a box plot. So can you have frequencies anything if they have percentages? Percentages is relative and then counts is frequency. And then the box plot, which usually goes with a histogram, the box plot is also a univariate display of, and I just exited out, I shouldn't have, of quantitative data. Last but not least here, we have one more graphic, I believe. Well, we have 2 more. We have a stem and leaf. Now, people are always confused on stem and leaves. I understand. Don't worry. Stem and leaves. When you talk about a stem and leaf right here, what is a stem and leaf? Let's take tip amount. Let's view it here visually and go back and view this because I'm doing it quickly right now. Here is your histogram. The histogram is right here. Love them stem and leaves, you bet. All we're going to do is a stem and leaf is a histogram where you can see the numbers. Do you see how there's a whole bunch of people who were very young who got their hair cut and the older people weren't very often in the data set? So we're going to go here to the red arrow and we're going to go to stem and leaf and take a look. Whoa, look at all these people right here. Perfect, almost perfect representation of the stem and leaf. Let's make it smaller so we can see it. Now, usually you don't want to use stem and leaves for big data sets because it kind of gets ridiculous, like this one looks ridiculous. But look at all these people who are very kind of in their teens or younger teens or older teens. 19 right here. This person here was 19. Oh my gosh, those are 9-year-olds. I'm wrong. This person right here was 10, 13, 15. This is age, right? Or is this tip? Which variable did I analyze? I think it's tip. It's tip amount. These aren't ages. These are tip amounts. So if you look, this is the tips people were giving, and you can see these people tipped like $0 through $5 or 4.99. These people tipped between $5 up to $10, and then you can view the individual tips over here. What do you think about this person? Whoa, what did they tip? They tipped $40. They're completely off the scale. They're right here. And look at how they're represented in the box plot, the histogram, and they're also represented in the stem and leaf. We can trace this person right here to this bin in the histogram, also to this person right here. Here's 4 people who tipped $25, and those 4 people, I believe, are right inside of here. Or actually, they're right here. Those are 4 people right here. It's very hard to see, but those should be 4 people right there. Look, 4 observations selected. Those are the 4 people right there, and they're inside of this bin right here, because that bin would start at 25. So that bin right there starts right at 25, and those are the people right here who tipped $25. So this is all displaying the same thing. If you notice, box plots, histograms, and stem and leaves all display the same type of data. All that good stuff right there. We've got one last graphic, and we'll complete this speed run, is dot plots. Now, dot plots, yay, dot plots. All dot plots do is display your data as dots. So it's like a histogram, but as dots. Cool. We like that right there. And that's got this speed run. Hopefully that made a little more sense to kind of review it a second time. It's just a histogram, but it's dots. If you like that, do it. And we went sub 430. I like that. We'll get the pens working tomorrow about that. So sorry very much. They were working in PowerPoint, but differently. And then Word was like, nope, we're not doing that. Are we allowed to call these points outside of the box plot an outlier? Yep, they're pretty much outliers. We'll go into definitely more detail on that in 2 seconds. Great job. I'm glad it makes more sense. That's what I like to see. Makes more sense. Awesome stuff right there. And feel free to ask questions. Can you explain the line above the Pareto chart again? Yeah, let's talk about that real briefly here. Let me hop back to the lecture screen, and I'll go back over that again. That won't be a major part of the lecture, so don't worry too much about it. I mean, it's a good thing to know, but wait, where was it? Where are you, line? Where's the Pareto? Oh, because that's the other. This is quantitative. I was like, I thought we got to the beginning of it. Here we go. The line above this is I'm so not used to these new pens. The line above it is a cumulative frequency or cumulative relative frequency. It's like if you took this bar right here and stacked it, and then you took this bar right here and stacked it on top of this one. So if you were to go to this line right here, you would have the percentage of all 3 people who gave this excuse right here. So if you were to go right across here, we'll make it more clear. If you were to go across here, then you would have the cumulative percentage or cumulative relative frequency. So it's just kind of adding up each bar as you go across. Bivariate stem and leaf. Yeah. Can you possibly do the bivariate stem and leaf? So that one right there, let's talk about that real briefly here. Great question, Devin, right there. And I think I can still display. Let me do this right here. I can't draw. It takes away my powers when I can't draw. I'll use the one we already have in the notes. I really like drawing on these things. I can highlight in here and I can do those things, but. So the back-to-back stem and leaf is going to be two variables. One variable is categorical, one variable is quantitative. That's the biggest note to know. Have this note down about back-to-back stem and leaves. One variable is categorical, one variable is quantitative. Do you have that down, Devin? One variable is categorical, one variable is quantitative. So I want someone to make, and I can actually make one right here. I don't know how to make them in jump. I think I don't know how to make them in jump. I hate to say that. I could draw it out, but I can't write today. So what if we ask people, are you born in Tennessee or not born in Tennessee, and ask them their age? Born in Tennessee is categorical, and your age is quantitative. So we'd be displaying somebody's age, and we would be doing breaking it apart by whether or not you're born in Tennessee. So, and the reason, if you notice why I'm not too worried about this graphic, the main thing to know about back-to-back stem and leaves is that they display 2 variables at one time. One variable is categorical and one is quantitative. Professor plus test scores. Kyle, hopefully I understand that. That's professor would be categorical variable and test scores are quantitative. So the variables are the professor and the scores their class had. Yes, exactly. Variable 1 is professor and variable 2 is scores class had. So you've got professor as one variable, categorical, and then you've got score as quantitative. And so back-to-back stem and leaf, the back-to-back part of it means that you're doing 2 groups. And so you could do like 3 groups. It would look very odd and weird, and you'd have to do like some 3D display. But back-to-back are probably because one variable is 2 level. The good question right there. And really, this is about the most detail you should know on it. Once again, it's mainly like you should know this display exists. We won't go into super detail. If we were to read it, how would we go about it? With this right here? Good to see you, Shady. So email me, I think you're in our class. Email me your name and I'll confirm it, and I'll make you a mod if you want. I just want to make sure, because SpongeBob emailed me their name, so I know SpongeBob is. If you see SpongeBob in the chat, I know 100% they're one of our students, because they were like, "Here's my name," and I was like, "Cool, that's your name in the chat. You got it." That'd be great, Isaac. I'm gonna remind me the thing you told me to use. You told me the thing about it at the start of class. Send me it in an email, and then I'll start loading it on my computer, because I don't like the GUI or the thing I have right now to use it. I didn't really like it. So if I want to make some Python videos, that'd be a lot of fun. Yes, awesome. Thank you so much. This 7 right here, I know I've got a lot on this screen. I actually chose the right color for once. Represents this score right here. So, and yeah, if you're using a nice GUI, that would really help me, because that makes it, the GUI you used, all the better. So don't worry, highly unlikely you'll see, like, there can only be like not many questions on the test on this. I really care for questions more like, when do we use back-to-back stem and leaves? That would be the biggest questions I would ask. Okay, I think we can get through 2 and 3 today. I think we can do it. I think we got it. Our speed run was kind of the break right there. You ready? So here we go. Our big last topic for this part of the thing. Oh, I can't draw. That's killing me. Why? What is going on? Okay. I'll draw it on this, actually. That's what I'll do. So We have 3 big concepts, and this will even be on your project at the end of the semester. I want to see in the chat right now, shape, center, spread. We already see some Gaussian in there. We know the normal curve. So shape, center, spread. Check it out. We'll see if that works right there. So shape, I probably shouldn't do that. Shape, center, spread. Shape, center, spread. You guys know it. Well, what are these things? What are shape, center, spread? What's going on with this? Well, shape is merely going to be the humps or the central areas of the histogram. So the shape is going to start out with unimodal, bimodal, multimodal. Unimodal, great job right there. Shape, center, spread. We have right here the unimodal, bimodal, or multimodal. What does a mode mean? Well, mode means most often. So mode is most often, but modal is a little bit different. Modal is like a most often area. So while mode is most often, modal is like an area that is most often. So when we say unimodal, we're saying that there is one kind of common area. So let's take a look. I think we see bimodal first. No, that's uniform. Great. So we see over here, we see a uniform. And let's break down the word uniform. What is going on here with uniform? What does uniform mean? What in the world? What is uniform? What is going on? Uniform means one form. It doesn't have a modal area. So we don't see any really kind of most common area. Do not be tricked. These are not modal areas. Those are not most often areas. It's pretty much one form. It's pretty flat across. It's rarely is it perfectly flat. That'd be kind of weird in and of itself. But this is kind of uniform, meaning one form. Now this one is bimodal. And this is pretty good bimodal right here, that you see there's 2 clear peaks. Now, if your friend were to say to you, wait, I climbed this secondary mountain over here, who would be impressed if this is 2 mountains? We got mountain A, we got mountain B. So who would say that their friend who climbed mountain B did something impressive? Would you be like, whoa, you climbed mountain B? No way. That's such... No. Who's in chat? That would only really be unimodal. Sarah's not impressed. I wouldn't be impressed either. That's not... Thomas... Thomas is impressed. B is lame. I agree. So B is not really a mountain. That's kind of some skewness to a unimodal distribution. So I wouldn't really say that's like a second peak to a mountain. You really want to see a good clear peak. Now I know that mountain B, if you talk about mountain B over here, mountain B is higher than mountain A, but there's still 2 mountains to that range. You wouldn't say like, imagine if your friend said, I hiked all the mountains. Well, pretty much on the distribution with A and B right now, A is really the only mountain right there. You want them to be distinctive. Kyle gets it right there. And then skewness, you got it, Camden. Definitely. That's coming up here very soon under shape. So you see right here that we have 2 clear peaks in this bimodal distribution. Will there be a question whether it's hard to tell? Nah, I'll make it very clear. Oh no. Hopefully everything's all right. 2 people said that instantaneously. Gives me a heart attack when I see 2 things like that. We'll cross our fingers. Is there a cutoff between them being clear peaks? I'll make it as clear as possible. So Thomas, I'll make it as clear as possible. Are we still streaming fine, everybody? 2 people said something about the signal, and that gets me scared when 2 people say it. Everything's fine? Okay, good. When I see 2 things instantaneously like that, my heart jumps out of my chest. Okay, good. Awesome. Okay. It was just the back-to-back scared me. So there was a loading thing on the screen. Siberian put a loading. You're good, Siberian, good. So you might have put that in response to Isaac. It just scared me. Okay, good. So we just had a question about skewness. Well, okay, so here is skewness. And this is a unimodal distribution that is mostly symmetric. We have a unimodal distribution that is mostly symmetric. Yeah, if the quality goes in and out, just turn it down a little bit. You can bring it down to like 480 if you have a streaming issue. But things don't have to be perfectly symmetric. What do we mean about symmetric? You can fold it over on itself. That is mostly symmetric. It doesn't have to be perfectly symmetric, but let's go to things that are not perfectly symmetric. Boom. Here is one in the middle that is not perfectly symmetric. And we will be talking about this in just a second, but here's the hint. Is this right here. Here's our little monster dude. His weird eye. It's going to disappear, isn't it? Oh, it didn't disappear. That one is skewed. And tell me, which way is it skewed? Which way is that thing skewed? His eye disappeared now. I don't like these new pens. So which way is that skewed? Which way would that be skewed? Ah, careful. Right to the high, left to the low, whatever way. Ooh, we got some people who are in between. Oh, no. Oh, Streamlabs, let's do it. Let's do it. Let's ask the question in the chat. Right to the high, left to the low. If you know the last part of that, which people might, it's all right if you give away things in the chat. Don't worry. Let's do a poll in the chat. So, right to the high, left to the low, and someone's probably giving it away. It's all right. You can put it in the chat. Be reading the chat right now. We're going to do a poll right here. Which way is this skewed, right or left? So we should be able to do this poll. Let's start a poll. Right to the high, left to the low. I'm not going to say the answer left yet, but what is the answer to it? Right to the high, left to the low. So remember, exclamation mark. Exactly. Isaac might know what's going on right there. So what is the answer? Right to the high, left to the low. We got some votes coming in right now. Looks like people are changing their votes. We're getting a lot of vote in one direction. Yeah, sure. Are you sure it's right to the high, left to the low, whatever way the something goes? Right to the high, left to the low, whatever way. I think people get it now. Right to the high, left to the low. Let's end the poll. Great job. So let's close the poll. And it is right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low. And don't worry if you didn't get your vote in. Don't worry, it doesn't give you points or anything. I'm going to try to get the points working. If I do more, you got it. 100%. Yep, people got it. They were paying attention. They're like, I'm changing my vote. When I saw all those rights come in, I was like, people have learned. Right to the high, left to the low, whatever way the tail goes. So you can kind of cheat right here. You can draw your little picture. I'd like to think Terry Higgins, I think he was the one who started to call them these monsters or something, started to draw on them, and it gave me the idea, well, let's start just drawing on them. That's a big enough eye. Don't go away there, eyeball. You got it. Right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. So that's what we say right there. So nice and easy. Keep that in your head. Right to the high, left to the low, whatever way the tail goes. But be careful. I've seen many people tricked. I'm going to go way back in the slides right here, and I'm going to go to this one right here. Is this a little skewed to the left or a little skewed to the right? Is this a little skewed to the left or a little skewed to the right? Is this a little skewed to the left or a little skewed to the right? Is it a little skewed to the left or a little skewed to the right? I'd say the left. Little skewed to the left. It's not... It's almost symmetric. I mean, if you could say this is mostly symmetric. If you were to chop that off right there, it'd be pretty symmetric. So it's maybe a little bit left skew, but mostly symmetric. It's fine if you say a little left skew. I wouldn't say it's heavily left skewed. Like when we talk about a heavier skew, if you notice these down here, like that's the most extreme skewed one right here. Because if you look at his tail, it's a way longer tail. So that's a more extreme right skew. These are still left and right skew. They're pretty strong skew also. We do have a way of doing this inside of Jump to get a numeric measure of it. I think I can show that here in the background. So I'm just going to pull up the graphic so you can see it. I know it looks a little bit weird right now. Let's go to tip amount. Okay, tip amount right here. Is that right or left skew? Which way is the tail of this monster going? Right or left skew? Well, yep. If it were to be on the exam, it would be like this question. If it's on the exam, Matthew, it'll be like this one. I'll do a question like this on the exam. This is more right skew. So there is a way to do this as a numeric measure. This will not be on the test, but if you're ever wondering, like let's say you're doing other statistics, you can literally click on skew right here, and you can add the skew to this graphic or add it to here, and this is right skew because it's positive. So if someone was like, well, how do I know for certain? Well, there's a numeric measure of skewness. So there's a numeric way to find out because right is positive and left is negative. Think about a number line. The positive numbers are to the right. And what would a symmetric distribution have as skew? This is kind of a bonus question. What would a symmetric distribution have as skew? What would the symmetric distribution have as skew? I think it's not skewed, so what would it have? It's not negative or positive. If it was symmetric, yep, it'd be 0. So there's ways to figure out if it's mostly symmetric or if it's right skew or left skew, because right to the high numbers, left to the low numbers, and this is skewed to the right. And so if anyone, great job in the chat, amazing work right there. So that's just kind of an extra bonus thing. That's just some bonus material for you to kind of know outside of this class. Won't be on the test, but just people always like, well, how do you know what the skew is? Well, we can just numerically calculate it. So there's a numeric way to find it out, which it's so easy. It'd be like, oh, that's right skew because it's a positive number. So this slide, yeah, exactly. Is there a threshold where you say it's still symmetric? That's the gray parts of statistics. Great question there, Nayland. It's kind of like how confident with the left histogram? I don't know. The skewed left. Yeah, that's definitely skewed to the left. Those are definitely left and right skew. Those are pretty strong. They'd probably be like -3 and +3. Don't worry, you will not be calculating that. No one would calculate that by hand. You just let a program do it. So but you should know, like, this distribution right here. Well, let's talk about the thing first. It's got outliers. So we've got right here the last thing with shape, which is outliers and gaps. So when it comes to outliers and gaps, we have that usually gaps create outliers. So you see right here a gap, but I'm going to ask a big trick question, and I'm going to do something super cool right here. Someone who answers this is going to get 20 points automatically added to them. I'm going to try to do it in Streamlabs here. So let me pull up Streamlabs in the background, and here's my question. First person to get this right gets the 20 points. How many cities are in this bar right here? How many observations are there right here? First person gets 20 points added to their Streamlabs. First person gets 20 points added. How many cities are there? Hannah gets it. Nice job, Hannah, right there. You were quick. You got it. Hopefully, and I hope people know that, hopefully you're thinking, wait a minute, I was first. Someone said that one time. I think when people answer really quickly, there can be a bunch. Let me go here, and let me add 20 points to Hannah right here. I'm going to try to do this. I might start doing stuff like this, giving away points. Where is it? Oh my gosh, I am forgetting where. Oh, found it. So, did I type it? Yes, I can edit points. Cool. I think I just edited your points. So you went from 270 to 290. Nice job, Hannah, right there. Can you go over that briefly again? Yes, great question. So this one right here has tricked many students. If you got it, you understood exactly what's going on. So let's take a look. This one right here has 1 city inside of it. This has 2. This has 3. Because if we were to put little tick marks right here, it's very hard to do. It'd be like, really? Whoa, I do not like these new pens at all. I swear this whole thing is haunted. Oh my gosh, what is going on? Something is going on here and I don't like it. It's like, no. Whoa. There we go. There we go. Look at that. So if you notice, I don't like these new pens. So if you notice right here, we have like 1, 2, 3. It's because like this has 1 in it. This has 2. This has 3. These pens are haunted today. So ghost in the machine. Does this make sense right here that there would be 3 observations in that bin right here? People are over 300 points. This is insanity. Great job. So does this make sense right here? And look, wait, this one has 4 inside of it because if you trace this over, it's not quite at 5. So this is our 3, this is our 2, and the pens, the ghost is here somewhere. But does this make sense what's going on right here? That you can look at the heights of each of these bars, and this represents how many observations are inside of here. Does that make sense? Who's following me along with this right here? Totally haunted. So you got it now. Awesome. That's a tricky question. It's caught a lot of people because you say, wait, there's only 1 bin right there. Well, remember, the bin is where we collect the data. So the bin is where we collect all the observations. There's observations that go inside of there. There are 3 cities inside of here. There's 3 observations inside of here that have some sort of values that are contained in this range. Great job right there. So we just covered the shape of a distribution. The shape of a distribution has 3 key concepts. It's going to have the modality to it, the skewness to it, and also unusual features. So please take a note right here. Let's put it down. Here's your big takeaway for shape. Shape has in it some key concepts. Shape has inside of it, let's go right here, it has modality. So modality is how many bumps there are. Let's say how many bumps. And then we have here, can I untab it? If I knew how to use, there we go. So we go here, and then we have skewness. So skewness has either symmetric, or it has the way it is skewed, or skew direction. And then we go right here, and we have also the unusual features. And the unusual features are things like outliers, gaps. So hopefully this helps out everyone right here to understand the kind of key concepts we just covered. Let's put right here, key concepts. Like, you should know all of these like this right here. You should be like, oh, the shape of it has these key concepts of modality, which is how many bumps there are throughout it, which is just like unimodal, one bump, bimodal, two bumps, multimodal, multiple bumps. We also have uniform, which has no bumps, which is just flat distribution. Skewness is either symmetric or it has a skew direction like left or right skew. Unusual features, usually we have gaps that create outliers, and it's all in the previous notes. Great job right there. We do some kind of key concepts right here to help out. Let's center that text. I like centered text. Okay, I know this has been a lot of material today, but if you have been paying attention, hopefully it's all falling in place. We've been going slowly and covering everything thoroughly. So now we have center. Center has two key concepts. The concept of center is going to have either the mean or the median. This is the best thing. Oh, thank you so much, Devin, right there. We have the mean or the median. So let's start by talking about the median. Like, these are the things you should know. Is you should know either the mean or the median are measures of center. Like, take that down right now. The mean or the median are measures of center. So what is the median? The median is the middle number. You ready? I'm going to give some people some jobs right here. Devin, Alexandria, and Kyle just got a job at my factory right here. We're making I don't know, we're making computers. And so I'm going to pay $10,000 a month, $20,000 a month, and $100,000 a month. So it's going to be Kyle gets 10,000, Alexandria gets 20,000, and Devin gets 100,000 in that order. It's like great money. You're like, well, wait a minute. Devin's making tons and tons of money. I know, right? 10K a month would be amazing. Sorry, Kyle, right there. Kyle, are you still happy you're making $120,000 a year? You're like, man, but they're making 240 and 1.2 mil. So exactly. So I want you guys to tell me the median. 10K, 20K, 100K. What's the median there? 10K, 20K, 100K. What is the median? 10K, 20K, 100K. What's the median? Remember, you get points for talking. You're right. It's 20,000. You're right. And you can type 20. That I'll know what that is right there. Okay, now we're going to make, all of a sudden, this company is amazing. We make the best computers. We're selling them to Oak Ridge and everything. We are the company that makes the Oak Ridge computers. So we're a 3-person company, so we make tons of money. So now it's going to be 10K, 20K, or $1 million. What's the median number right there? And they have to be in order if I'm saying them this way. You're right. 10K, 20K, $1 million. 10K, 20K, $1 million. Things about to get insane, though. 10K, 20K, $1 million. You're still saying 20K because it's the middle number. How about 10K, 20K, $1 billion? What's the median there? Now, if you notice something, it's still 20K because it's still the middle number. So what do you notice that median kind of controls for? The median will control for skewness. The median is not impacted by outliers and skew. That's a huge note, that the median is not impacted by outlier and skew. It's always the middle number. And what happens? Here's when it's the middle number. There we go, a bunch of numbers, put them in order, and we take the middle number. Now, there is a formula that's a trick right here, which you see on the screen. It's not like a trick, like it's going to trick you, but it's a trick to find out the middle number. If you do the amount of numbers, which there's 7 numbers plus 1, and divide that by 2, you will find out the position of the middle number. So if you notice here, number position, the number in position 4 is the middle number. If you have an odd amount of numbers, what if it's even? Great question. Well, now the middle number here is the 3.5 number. So, oh, good. Yeah, thought something was wrong on the slide. We have 6 numbers we get right here, and they do it this way. I like to just say it's the 3.5 number, so I don't love this slide right now. But I would just say why you do this slide. I would just do it the following way. Changing the slide. This is what I would do right here. I would still use n plus 1, which is n is the number of observations. And I would do it this way. And then you just go to the 3.5 position, which is in between 3 and 4. Great question right there, Shady. All these questions, please ask. But does that make sense? We're going to the 3.5 number. So imagine if we had 4 people at our factory now, and they make 10, 20, 30, and 100,000. What would be the median with 10, 20, 30, and 100,000? 10, 20, 30, and 100,000. What would be the median? So you've got 4 numbers, 10, 20, 30, and 100,000. I'm giving a hint right here. You guys got it. You're right. It's 25 because 10, 20, there is no middle number. There's no middle number with 4 numbers. So if you do the formula, you would actually take the 2.5 number, which is 25. So 10, 20, 30, and 100,000, you'd go between 20 and 30, and that's your middle number. Now, software will find this out for you instantaneously, so don't worry. You just have to know that the median is the 50th percentile. That's pretty much a huge note right here, that the median is the 50th percentile. Please take that note, that the median is the 50th percentile. Does everyone have that? Median is the 50th percentile. We should know what the median is by definition. It's the 50th percentile. It's the middle number in the data set. It's Q2. You got it right there, Isaac. Nice job. So much interaction. You guys are going crazy on these points right here. Like, people at 300. If you looked when people came in you guys are interacting way more. Like, this is... I can't wait to see the grades. I can't wait for people to complain, like, Brian, your grades are too high. And I'd be like, you go to any of them and you talk to them. They know their stats. They interacted. They know what's going on. They're like, well, we can't have you give everyone A's. I'll be like, too bad. They earned the A's. They got the A's. Look at that, 280 points. I am really proud of you guys. Like, keep it up. Let's do it all semester. We're already like 12% done with the class. You just need to be like, okay, 2.5 more weeks. Go strong. Got it. Boom. I know stats. Okay, what do we have right here? We have the mean. I think you guys know what the mean is. We're back to some easy concepts right now. The mean is, what are the quartiles? We'll get to that in just 1 second here. Great question, Jared. So the mean, they're basically the quarters of the day, like the 25th, 50th. That's why the median is Q2. So Jared, amazing question. The median can be called Q2 because it's 2 quarters of the data. So that's why it can be called Q2, because it's 2 quarters of the data. You've gone through 2 quarters. And there'll be more on that in just a moment. So the mean, I don't think I have to talk about this one too much, but the mean is the average of all the data. Does that make sense? What does this represent right here? And I want you guys to do something. If you have a notebook out in front of you, I want you to write the following down. Y bar, this will really help you for later in the class. Y bar is the sample mean. This is very important for later. This will be a huge help. Y bar stands for the sample mean. N is number of observations. So that's number of observations. That's right there. Hopefully people heard me say that's number of observations because my handwriting is pretty bad. So I like right there. And then Y is each of the observations. So these are individual observations right here. Like if I ask people their height, these are the individual observations. So what you're doing is you're totaling up everybody's heights. Yeah, Devin, amazing thing right there. Devin, great answer right there. Devin, I need not give, I'm giving Devin 20 points. I really like that comment by Devin right there. Devin pointed out, so let me add points to Devin right here. I'm giving Devin 20 points. I'm going to do this 3 times during class. There'll be 3 times during class that I will give people like 20 points for like comments like that. I can't promise when they'll be, but I want you guys to talk as much as possible. I want you to say things that you're thinking about. That's a really great comment, and let me explain. The bar is what makes it the mean of the variable. The bar is what makes it the mean of the variable. So when you talk about x bar, that's the mean of variable x. You could do something like z bar. Now, I don't usually call things z, but if someone wrote z bar right here, what would z bar be? It'd be the mean of variable z. So it just, the y is the name of the variable, and then y bar is the mean of variable y. And then x bar is the name of the x variable. Pog is totally like a Twitch thing. I think it means cool. I think it does. I hope it does. So like Pog and Poggers, I think. Variables are trivial, I think. Yeah, it's just the name of the variable. It's just calling it. You can literally do things like, you could say like height, and you could do this. You could do height bar. So you could say the variable of height bar. Is it an insult? You guys have to tell me if these things, hopefully it's not that. I know a lot of lingo. I don't want to ever say anything that's like bad. So please tell me if they're like, Brian, that means this. I'm like, oh, oops. I thought it meant like cool. Like it's like Pog was cool in the 90s. And it's like a throwback cool word. If I'm wrong on that, please tell me. Like it might be something people are trolling me with. It means champ. Cool. I like that. Pog champ. Cool. Yeah, I thought it was like, I looked it up. Is it off Dark Crystal? That's fun. Devin, great little note right there, and I like it right there. A play of the game. That's what it means. Oh man, okay, that's why everyone puts it in like. See, I'm like a '90s kid, so when people say Pog, I think about just like Pog and stuff like that. Pog is. Oh, it is. Oh no, yeah, that's not what it means. Yeah, I don't think that's the way people are using it. yeah, so hopefully no one interprets it that way. So I might not use that if it could have like a people fear it has like a double meaning. Clips and Mizers also shared the phrase, yeah, that's what I thought it meant. I thought it meant like awesome, cool, like that's great. And so we see right here the mean. Thank you guys for helping me with my lingo. I try to stay on top of it. I try to know what the memes are. So I'm such a boomer. So mean, my parents are boomers. I'm not. So I'm actually a millennial. If people were wondering, I am a millennial, which I'm an older millennial, but I am a millennial. So I am millennial, but you guys are Gen Z. You guys are Zoomers, I think. Most of you, maybe not all of you. Someone could be a boomer in here. So I know what RIP is. I know what F is. So that was pay respect. So in the military, it just stands for person other than God. Oh, cool. Mean or median. Okay, cool. Check it out. You ready? Here's a big concept. We're having our fun. We've got just a little bit more class left. Here we go. So I want someone to tell me mean or median for this. Mean or median. And we're going to pull. We're going to get back on track here. We've been going a long time today, but we've only got 40 more minutes, and we're going to get through more material. So let's go right here, and let's take a poll in the chat. Mean or median? Which one of those? So be thinking about this. Are you going to use the mean or the median for this? Mean or median? I want to see it. Which of these would you use? And I'll explain why the answer is what it is. So I want to see the answer in the chat. Is it mean or median? And I just started a poll for it. What are the answers we're getting right here? There is a so do exclamation mark vote mean or median. And so I'm going to talk about this right here. I'm going to draw some stuff on here to help you out and give the answer. This one right here is a perfect test question. And think about this. We have tons of outliers. So how does this work? This graphic right here that I am drawing, I have to draw on the PowerPoints today because I can't draw on Word, is a very important graphic. I drew it out yesterday when I could draw. So I can still draw it today. We have right here the center. And we have here the spread. We haven't even talked about spread. Now, do you remember we talked about shape first? We have here normal. And I guess you could say not normal, which I'm just going to call skewed. Now, we have to first identify if something is normal or skewed. So this is either normal or it is skewed. Is this graphic here that I have behind this normal or skewed? Which one is it? Is it normal or skewed? I need some help with this. I forget these things. Is this normal or skewed? I don't know. It is definitely skewed. Yeah, that rings a bell right now. So it's definitely skewed. Very, very skewed. And so now we need to know the proper measure of center. If it was normal, it would be mean. There's a hint right there. And then the spread would be the standard deviation. Now, if it's skewed, it's going to be the median. And over here, the IQR, which is going to help us with the quartiles in a moment. So please take this down with my very crazy handwriting right here, because the answer to the question, does anyone want to change their vote? I don't know if you can change your vote. But since this is skewed, that's going to give you hints for the answer right here of what would be the proper measure of center. That's a huge hint right there. I can't give a bigger hint than that. That since it is skewed, the proper measure of center. Let's see how everyone did at the votes. Let's see. We did get the right answer, but it was pretty close. Make sure to know this. That's a pretty close right answer right there, but we got it. We got more answers. So it is median. Does that make sense? This is heavily skewed. What does the median control for? The median is not impacted by outliers. It's like I could take the most extreme data point and move it further away, and that would not change. If this moved further away, that would not change where the middle 50% is. The middle 50% right here, where the line, the demarcation on it would not change. So the median deals better with skew than the mean. The mean will get inflated by outliers. So the mean is a poor representation. Imagine if you worked at a company. So is that point the middle of the data? Yep. It might not look like it. I've never loved this visualization, but apparently there's 50% of the data right inside of here, and there's 50% of the data on the other side of here. So it should be, it kind of looks like it. It's not my favorite visualization of the semester, but that's where the middle is. Now, what is happening to the mean? The mean follows the skew. Does everyone see here that the mean, which is the balancing point, the 50th percentile, misspoke, the mean, which is the average of all the observations, is going in the direction of the skew. The mean, which is the average of all the observation, goes in the direction of the skew. So the mean follows the skew. It's inflated by the skew, which makes it not a good representation. The mean is inflated by the skew. It'll follow the skew, and it's a poor measure. Does that make sense? These are huge notes. This is something you should have down. Very important to know that these are the proper measures for center. And the last topic that we're really going to go deep into today is the measure of spread. The measure of spread. Can anyone tell me how many types of spread are there that we will mainly focus on? How many types of spread are there that we will mainly focus on? We will talk about this many, but we're going to really focus in on how many. I like that, Devin. There's 2 we will focus in on. There are 3 we will talk about, and there's 2 we will focus in on. There are 3 that we mention. I'll mention 3, but we're going to focus in on 2. You should notice right here in this graphic, here's the 2. And the type of spread we pick will depend on the what of the distribution. The type of spread we pick will depend on its what. The type of spread we pick will depend, just like the type of center we pick, will depend on its first thing. Remember, not stock market, but shape. Hannah, you're right. The shape or the skewness, which is part of shape. So if it's skewed, we'll pick a certain type of spread. And that's why we did shape first, because the shape lets us pick the center and the spread. If you remember, this was our first topic, our second topic, and now our third topic right here. So you have to know the shape of it to then talk about the center and the spread. So once you decide the shape, you can then say, oh, it's normal. We should use the mean and the standard deviation. The mean is a measure of center. Next stream tomorrow morning. Good to have you here. So if you're following along and having fun, love it. So same time, same bat channel, same bat time, 9 a.m. So normal is symmetric. Yes. Great question right there. When we talk about normal, the normal model looks like this. And I try to draw out my mic. I just get that last curve in there. Oh my gosh. I want my space pen back. Space pen ran away. That's normal and symmetric right there. So the normal curve is unimodal and symmetric. And this is when you should definitely use the mean and standard deviation. So this is very important right here. This curve is normal. And do you ever actually stream? Yeah, we might should do that. I want to play some video games on stream. So I might hook up my Switch or something. I need to get my super tech for that. So this is the one we won't talk about too much, but a very easy concept. If I put this on the test, you should be super excited. All the ranges is the max minus the min. All the ranges is the max minus the min. You guys should tell me what to stream. I want to do maybe Mario 1 speedruns. The max minus the min, it's not a good measure, because if you're like, what are the range of grades on the test? I'd be like, well, usually like 70 points. Because someone makes like a 30 and then someone makes 100. So when you think about this in context right here, we should do that. You guys should tell me what to stream, what video game. I thought about doing like a Isaac speedrun, or like loading up a new Isaac on Steam and being like, oh, whoa, this is my first time playing this game. You would know it's not my first time, because I'm not like the best player, but I can beat the game like pretty consistently. Odyssey, Assassin's Creed Odyssey. I haven't played Odyssey yet. I might. It's on sale right now. I think they've got it on sale. Maybe I should check it out. I don't know. I just like I put in, this is not a joke, I put in over 1,000 hours into Isaac. Breath of the Wild, I guess I could if I could get my Switch hooked up to this. Barkley, I have not heard that one. I'll have to look into that one. I do not know that game. So does everyone understand how to get the range? If someone Smash Bros. Yeah, I've got Smash Bros. I'm so bad at the new Smash Bros, though. I don't like it. I'm so unhappy with my skills. Like, I'm good at original Smash Bros. I should focus. We got 30 minutes. We got this. So we have a little fun every once in a while. Oh, Mario Odyssey. Yeah, I'm waiting to play that with my fiance. So I'm really excited. Like, whenever she and I get some time, I want to play with my fiance. And I have Odyssey. I've had it this whole time. And I played it a little bit, but then I'm like, okay, I really want to start a new game with her and kind of get all the... They're not shines or stars. They're... I can't remember what they are. They're the things like that you put on your ship. Okay, so here we are. We have range. Does everyone understand what range is? Range is just the biggest number minus the smallest number. Like someone made 100 and somebody... like Beat Saber. Someone made 100 and someone made a 30. Range is nice and easy. I think that's an easy concept. But the two concepts we want to focus in on are the IQR and the standard deviation. Nice note there, Alyssa. The IQR and the standard deviation. When it comes to IQR and standard deviation, everyone gets confused on IQR. They're like, what the heck is IQR, Brian? Well, I got you. Check it out. You ready? Here comes the IQR. Let's draw it out here. We're going to draw out some IQR right here. You ready? The way to know what the IQR is to draw 4 quarters. Nice job, notes in the chat. I love it. Here's our 4 quarters for our data. Let's make these bigger right here. Will they reappear again? Don't reappear. 4 quarters. There's our 4 quarters of the data. Like there's 25% inside of here, 25% inside of here, 25% inside of here, 25% inside of here. And it's just like these are people's grades on the test. Like this would be the middle person right here. Does that make sense? And the middle person made an 80 on the test. That's their score on the test. But this person was the 50th percentile. If the online test had an 80 as the average, that'd be pretty good, considering your quizzes are averaged with your test grades. Don't forget that. I'll remind you all the time. I'd be pretty happy with that. Now, the 75th percentile right here, if you notice, we're just adding up the money, might have someone who made like a 92. The top, which is the maximum, the 100th percentile, might have somebody who made 100. That'd be amazing. Now, they don't have to make 100, but I'd love that. And then down here, I guess we could go this, and because usually it's got that sort of direction. And I'm going to ask a really interesting question right here. I want to ask you this. What way is this data skewed? You got it. People might have already figured out the IQR on this. I like to visualize a rectangle and divide it into 4 bins. You got it. That's exactly what's going on right here. You can do that. What way is this data skewed? So Isaac says he does this and puts it into 4 bins. You see how there's 4 buckets, like bucket 1, bucket 2, bucket 3, bucket 4. There we go. There's the 4 quarters. Great job, Isaac. I like that. It is left skewed. You guys are right. Because think about this. If you look at the distance here for the upper 50%, it only has a range of 20. That's weird. And then this one has a range of 50. So there's more of a pull. Now I know it's like visually the same distance, but if you look at this is pulled more in this direction where this only has a range of 20. So that kind of tells you there's a stronger pull to the left. A histogram of this would kind of look like this a little bit. Does that make sense right here? Because it's pulled out to the left side longer, wherever the median would be. The median would be probably a little bit higher than that. I hate it when I hit Control-Z, it takes away my thing. Good, you can still see that. So that's probably where the median would be. So that's probably how this would look as a histogram because it would have a left tail to it. So we see what's going on right here, but the concept we're covering is the IQR. So what in the world is this IQR? Well, let's break down the words. I stands for inter. So when we look at the I right here, we need the interquartiles. The ones that are on the inside. The quarters, let's change the color of it, meaning that we're talking about these quarters right here, which are these quarters. They are the interquartiles. And then we're going to talk about the range of it, which means just the range of the interquartiles. So it's just how far apart are the two numbers. Just like you did range a moment ago. When you did range a moment ago, what was the range of the full data set? What is the range of the full data set? Can anyone tell me what the range of the full data set is? Does anyone have any idea what the full range of this data set is? What is the range of that whole data set? 70, you're right, Devin, amazing work. It is 70. So what is the IQR? What is the range of the middle 50%? How far does that middle 50% go? Who can tell me that? What in the world is this IQR? It's still just the same idea. I'll write a formula for it in a second, but it's still just the same idea. Nice job right there, Devin. You know how to do it. And what would it solve to? 32, you're right. If you notice, there we go, 32. It's just the distance between those two numbers. So and it doesn't matter which way you subtract them because you don't want them to be negative. I mean, it'll always just be a positive distance because like how far apart are these two numbers? It doesn't make sense to say negative because they're just this distance apart. And so that is it. Let's write it down right here. Let's put some great notes on this. This right here is the lowest number in the data set. It's the minimum number. You can call that min. This right here is the median. What is 100 then? 100 is the what number in the data set? 100 is the what number in the data set? The 30 is the minimum. It's the lowest grade someone got. 100 is the what number? Max. Nice job, William, right there. Nice job. It is the maximum. You got it. 100 is the maximum. I'll give another bonus way a little later on. 100 is the maximum. And then I need some words for, I don't know. It's almost like at this point we have how much money. I don't know, like what? It's almost like on that highlighted line we have how much money. Like how much money do we have at this point? Like we have. I mean, just kind of talk to me like you don't know. Yes. It's like we have 1/4 right there, like you don't know statistics, which I want you to know statistics, but don't let Claire. I hope you're not either. I don't want anyone to be at 30. So right here we have Q1 because there's 1/4. Well, wait a minute. I bet using that strategy, I bet we could come up with a word for this right here. It's almost like at this point we have a certain amount of money too. So at that point, I bet we have a certain amount of money also. I bet we got a certain amount of money here. And these are the things, if you have your notebook out, which you should, this is what you should have written down beside you. Now, if you look at this, what we have going on right here is we can write some formulas. The range is just going to be max minus min, which is just big number minus small number. And the IQR is just Q3 minus Q1. So it's just big number minus small number again. Just take a look at it right here. Big number minus small number. Just how far are they apart? That's what the range is. Just big number minus small number. Just how far are those numbers apart? And then when we do the same thing for the IQR is going to be big number minus small number. Just how far are they apart? It's just the distance those numbers are apart. That's all the range is. It's the range of the middle 50%. So this is a very important note I just took right here. Very important to have in your notes. Very important to understand what's going on right here. And we actually just did what is called the 5-number summary. I was going to ask you as a bonus question. And I said the answer. So I'm like, I said the answer by giving it away. This is the 5-number summary right here. The min, Q1, median, Q3, and the max. That is the 5-number summary, which represents each of the percentiles in the data going through. So we had a question earlier. What are the quartiles? I think it was Jared asked it. What are the quartiles? These are the quartiles. Amazing question. Knew where we were going. These are the quartiles, and they're known as the 5-number summary right here. So Q1 is the 25th percentile. Q1, think 1/4 right there. You could call it Q0. I like that right there. Isaac called it Q0. That would be the minimum. So it's just all these different points right here. That's what pops up in the calculator when we do it in the calculator. You got it, Devin. You got it. That will pop up in the calculator. Nice job. Going on right here. Same notes we just did. Cool. So we got it. We just got different percentiles right here. Like the 25th is Q1. The 75th is Q3. Please remember, just think about how many quarters these are. That's the 25th. That's the 75th. We got that. We know what's going on with the slide. Here's the formula if you didn't write it down. Once again, I like to actually work these things out. One time someone wrote a review of me and they wrote he reads the slides. And I'm like, well, yeah, I kind of read them, but I hope I'm not like reading slides when I teach. I'm explaining them and then going through them and doing examples from them. So I would hate for someone to think I read slides like that's all I do, because I wouldn't be good. I mean, that's not what I should do. So no way. I like that, Kyle, right there. You're right. So you see right here, here's the visualization of the middle 50%. So what we have right here is we have here 25% in this area of the data, 50% in the middle right here, and 25%. So this is an IQR of 13. All that good stuff right there. Nayland and Alexandria, thank you very much. So this is the visualization of the IQR right here. All that good stuff. Quick question. Here it is. Here's another 20-point question. Go ahead and calculate the IQR on this slide right here. Calculate the IQR. Who's got it? I'm trying to think through it in my head real quick. I'm trying to beat you guys to it. Who's got the IQR? Oh, no, my brain's breaking. Okay. Nope. It's not the IQR yet. Yes, I think Devin. Nice job, Devin. Devin, amazing work. Devin got it. So Devin, amazing. So quick right there. Now, another person gets 20 points. I'm going to add in the points to Devin real quick, but write the formula for how you found it. Write the formula for how you found it. Who's going to be the first person to write the formula for how they found it? I want someone to write the formula. First person to write the formula gets the points. Write the formula so people can see in the chat on how you found it. So you have to, so there we go. I'm going to give it to Jack, Isaac, and let me get the names right here. Okay. So let me make sure I add in your guys' points right here before I forget. So let me go back to Streamlabs. See, this is why it takes a little bit longer to do this. So great job. Be asking questions if you have it. I got to stop giving away points. People are going to be... Someone's going to get all the points they need. So let me go. They're going to be like, one day later, I've got all my points. I got all my points in one day. So let me see here. Was it Isaac? Isaac got the formula first too, and I'm going to give it to, I think, Jack. So there we go, and amazing work. And then I said Jack also. Nice job. And there we go, Jack. Great job. And thank you. Don't worry. If you talked, you're getting points also. Remember that. You're like, oh man, I wasn't super quick. Well, don't worry. You're participating and you're learning. That's the point of this right here, is that I want you to be participating in the chat. I want you to be learning. And the more you participate, the more you learn, the more points you get. Do not worry. There's going to be lots of opportunities. And just look at how many points people have. You guys are already so on track to get all your points. By the end of the semester, someone's going to have like ridiculous points. It's going to be insanity. So you guys are doing great. Look at that. You only need 1,000. What did I do? So stay here. Nice. I know, Jack. Great job. We've got here one of our last topics for these slides. We've got the standard deviation. So the standard deviation is just simply going to be the observation minus the mean is the deviation. Well, that's not a standard deviation yet. So I want you guys to see this is just a deviation. And this would be, you're saying, well, what is this notation? We covered it a moment ago, but let's review. This right here is just somebody's height, and this is their distance from the average height. Does that make sense? Like someone is, let's say, 72 inches tall, and then the average height is 70. So that's just somebody's deviation from the mean height. Like the average height is 70 inches, somebody is 72 inches tall. The 72 represents somebody's actual height, and then the 70 represents the mean of that right there. So is that it right there? That might be the code inside of Python. I don't know that one yet. Now here we go with the variance. I don't like variance. But do you know why we need to know variance? Watch this. Variance, all you need with variance is to do the following. And what would this solve out to right now? What does this part of the equation over here, if I reduce it, solve to? The highlighted part would reduce to what? The highlighted part would reduce to what? The part I've highlighted would reduce, if you reduce it, to standard deviation. So if you square, this is probably the most important note on this, that if you were to square standard deviation, here's standard deviation, you would get variance. The reason a lot of us don't like using variance, like people use variance. I don't like it. But variance is in squared units. So I don't like it because it's in squared units. I don't like talking about variance, but it's used. But I don't think it has good business application. I do business analytics because it's in squared units. I don't want to talk about something in squared units. I want to use the units of the problem. So then rather than doing variance, which is squared, you simply square root it and you get standard deviation. So what does it represent? It represents spread of the data. So variance isn't bad. And you're right. When you look at it, look at this part right here. So someone tell me in words what the highlighted part of the equation right here is doing. That highlighted part is just a what between the numbers. That's weird. That highlighted part is just the what between the numbers. It's just the what between the numbers. It's just the sum of the squared distances, which is a deviation. If you look at it, it's the sum of their squared distances divided by how many observations there are. So wait a minute. It's almost like this is a weighted, it's like an average distance. Does that make sense what a standard deviation is? Like a deviation is just how far is one thing from another? That's a deviation. But then if we're like saying like what is kind of an average deviation? I could go a little bit more in depth on this. This is like, close your ears right here and be like, la, 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 la. Because you might ask the question, why is it n-1? This is a great question to ask. And I will say this. Do I have a white pen? I don't have the white pen today. Dang it. I'm going to have to do this. If we were to do this, that's the formula for sigma. So Isaac asked about this yesterday, I think, with S and sigma. Standard deviation for a sample has the n-1 on the bottom because it kind of inflates it, because for a sample we're more uncertain, because it's going to make the bottom number smaller, which will make standard deviation for a sample bigger, because we're kind of increasing it more for smaller samples because you're more uncertain for smaller samples. This is a more advanced talk on this. I'm not going to put this on the test, but people always wonder, why is there an n-1? That's for sample standard deviation, and it's kind of an inflation due to smaller sample sizes, which will lead to larger sample standard deviations due to the uncertainty due to small sample sizes. But if you do population standard deviation, because that's sigma now, so population standard deviation does not have the n-1, and it just uses and technically it'd be capital N because it'd be population. So let's, in technicality, because a statistician's going to jump in here and be like, what are you doing? It'd be capital N, which is population size. So that's more technical way to write it right there. But don't worry, we're back to the normal stat 201 stuff right here. One thing you should know instantaneously is you should know the following. We've already highlighted the other things, but this right here is sample standard deviation. That right there is sample standard deviation. Little n is better notation. You can well, little n is sample size, where capital N is population size. So the small n means sample size, and the larger n means population size. So just small little changes, subtle changes we use in statistics. So then sigma, which we should also know, that'll come into use a lot later. Sigma right here is population standard deviation. So sigma is just the population. Population standard dev. So those are the key terms you should know, that S is sample standard deviation and sigma is population standard deviation. Make sure to stay to the end. We're almost done. We've covered so much good stuff. Now here's the amazing part. This is Brian's rant. You ready for a rant from Brian? I don't know why anyone calculates this by hand. I have no idea why would you calculate this by hand? Why? Because you can spend a lot of time calculating this by hand. So we're going over to R. We're hopping into R right here because watch this. For all the time that people might spend, it's literally one line of code. It's so easy. We just go here, and I'm going to take empty cars, and I'm going to take the miles per gallon of cars. And then all I do, if I want to get the standard deviation of this, I just go SD, and there's the standard deviation. Done. Probably if I want to get variance, I think it's just var. I never use this code. Oh, there's the variance. What is 6 times 6? Does anyone know what 6 times 6 is? What the heck is 6 times 6? It's almost like if we take the standard deviation and what we get the variance. I think you got it. There we go. Because you're thinking 6 plus 6. I think I know what you got right there. I love it. I don't know. I like it when people mess with me and stuff. I love it in the chat. You guys got it. So now you see the concept and think, I could have estimated the variance instantaneously. Yep. It's in jump. All it is. And I'll show it here. Great question asked. Thank you so much for that question. We'll go right here. It's just, if you do analyze distribution, the standard deviation is right here. It's that easy to get into jump. So when it's that easy to get in jump, did everyone see it? That all I have to do is do analyze distribution. Thank you for asking that question. So that way it's in the video also. Yeah, I can't imagine. This has 232 observations. You have to make like a table. You have to do the deviation, then you have to square it, then you have to sum them all, then you have to divide by n-1, and you're just sitting there working a whole table. I've done it by hand. I've taught. It's a math problem, but we don't do math. R is completely free, and if you want to download it, get a hold of me, and we'll talk about downloading it. Math should only involve variables. I like that right there. So if you notice, we're more interested in what does this mean. When you look at this right here, let's go back into R. The MT cars right here, and I can make this into a histogram just by doing this. So here's the histogram of it. We can make it a color. The code for color is just col equals. We can make it, let's make it purple right here. So now we got a purple histogram. We can make it bigger. And there's a lot better ways to make graphics, but looks weird now. There we go. So there's a histogram right here. Bin widths are 5 and the standard deviation is 6. It kind of makes sense. The mean looks to be, it's a little bit right skew with some outliers. So the mean is probably about here. I'm going to say the mean is 23. What do you think I'm going to type for mean? I'm just going to type mean, and then I do that. And I say it's going to be 23. That was a guess. It's 20. I was off in my guess. But, yep. Isaac, you're awesome. Isaac is totally right. R is open source, completely free. Exactly. And so watch this. If you see this, I want someone to click and go ahead and give a shot on this because this is one of those interesting times. If you notice, you've got options. Oh, wait. We don't know who this is, so we're going to do this. If you notice, something's going to appear on it because I do not. Maybe I should. I don't know. We've had interesting things. I don't know what that says. So that's what I kind of do right there. So every once in a while, I'll have someone jump in. So exactly. You guys see it now. You see your options. This was a test. But I don't think that was anything too bad. I don't know. But I'm always wary. So exactly. But I think Siberian might be visiting us and just saying hey, and they're free to hang out. If they're in our class, I make them a mod. But those are the kind of options, and that's what you guys see right there. We've had people come in and say crazier things, but if they're nice and they're chill, we just like, hey, come in, say hey. They don't get a grade, but they get to at least hear a little bit. And I'll probably make these videos unlisted. I just want people to know that the videos still exist. And if you saw that playlist I sent out, which is also unlisted, that'll have all the videos in it. So standard deviation. Let's take a look at it right here. Exactly. I like it right there. So exactly. Do you see her there? Yeah, let's see her. Cool. You guys are awesome. I have now decided my backup, his physics research doesn't work out. Yeah, no, that's great stuff. Here, we'll finish off. We're going to finish off the notes. We're so close. Yeah, we can do that whole thing tomorrow. We got that. Okay. So standard deviation. Okay. Which of these, here's the tricky ones. We have put stuff on this like on the test. We go until 12. Remember, we've done a lot today. Thank you, Sarah. So what do you notice right here about these histograms? The first one is uniform. It's uniform. The second one right here is bimodal. And the third one is unimodal. Which of these would have the biggest standard deviation? And think about how standard deviation is calculated. It's calculated from the mean. So which of these deviates the most from the mean? You are right. It's definitely B. B deviates the most from the mean. Is it? Yes, Isaac, I think you're right. Maybe C is the smallest. C is the smallest, and then A, and then B has the most deviation. We've got some more slides here in just a second. Let's look at this top one right here. Now, which of these has a bigger deviation from the mean? So I think this will help out right here. Which of these, like if you were to take these and either clump them together or push them apart or clump them together, which of these has a bigger standard deviation? So I might have asked that. Which of these has a bigger? Whoops. Oh my gosh, guys, I'm sorry. Does A have a bigger standard deviation or B have a bigger standard deviation? Which of these deviates more from the mean? I've tricked everybody. For the top graphic right here, the one with the bigger standard deviation, you have to think, which of these deviates more from the mean? Oh no, I've tricked everybody. I want you to think of these as balls of clay. I'm going to do some magic right here. I'm going to move through the screen. So watch this. If I were to take this data right here and push it together, I'd be clumping. So hopefully, Isaac, I'm going to try to make sense of this right here. But I want you to look at A. A has been more spread out. A has been more spread out. If you were to take it and push it together, you'd be bringing it more towards the mean like B is. B has been pushed together, which means it deviates less from the mean. You'd have to take B and actually like smash it down and press it out and spread it out to make it A. I'll probably put myself right back where I was. But does that make more sense right here that A is more spread out? It has more deviation from its center than B, which is tighter towards its center. That hopefully makes some sense right there. So the more you have to clump it together, the less deviated. Clump together has less deviation. So uniform plots, larger. Yeah, uniform can be larger standard deviation. It's the spread, not the quantity. Exactly. It's how spread out it is. That's because it's a measure of spread. The bottom one, that was a little tricky. Let's not do that one. Let's do obvious ones. Okay, the top graphic right here. I'll highlight it. So let's do the top graphic right here. Top graphic. Which of these has a bigger standard deviation, A or B? This one should be pretty obvious right now. A or B? You guys got it because B has been pulled out from the mean. B has been pulled out from the mean. Which of these bottom ones right here has a bigger standard deviation, A or B? Which of these down here has a bigger standard deviation, A or B? Which of these has a bigger standard deviation, A or B? A. Because A has skewness and not really outliers, but a little bit of skewness. B is more clumped together around its center. Which of these? This one's super obvious. This one, oh no, if this was on a test, which of these deviate more, A or B? Which of these has more deviation, A or B? Which of these? You got it, B, because it's more spread out. Now the bottom one, which of these has more deviation, A or B for the bottom one? Which of these has more deviation right here, A or B? They would be the exact same because they're just mirror images. They're just mirror images. So that's a mirror image. It has the same spread. It's still spread out the same way. It's just a mirror image. Exact same. And then I think that's just other examples. I'm not going to put the trick question on the test. Last one's a trick. Don't worry. The last one, it's actually B. It's a trick question we put here. Fun times with trick questions. This one, I'll say this one. This one's more spread out because it's further out. This one's a trick question because of the scale. If you look at the scale, this one right here would have the bigger standard deviation because of the scale. Trick question, it's because of the scale. So the graphic B, because it has a much longer scale to it, has more deviation from its center. It's trick question scale. I don't know. No. Wait, what? I didn't see that. Wait, what? I didn't see it, Isaac, if it happened. What do they tell us? I think we got it. Woo! That is one of our longest lectures. So when you get done, will you explain about the note-taking quiz? Yes, I might have to extend that. Last but not least, let's talk about that. That's what I wanted to talk about at the start that I was ADD about. Oh, no. I'll send out a reminder about this. Let's go show that right here before class ends. Oh, my gosh, I had that up in my background. And let's show it. Okay, great question right here. Here is the note-taking quiz. Amazing question. Who said that? Let me give them points. I'll add points to you in a moment here. Claire, I'm going to add you and add points to you here in a moment. So the note-taking quiz, I'm going to add points to Claire right here while we do this. I know you guys can't see the screen properly yet, but I've got it up and going. So this is the last little bit of class. Make sure to stay to the end. We are still teaching right now, so let me add the points to Claire in the background. So what is the note-taking quiz? The note-taking quiz is simply very easy tasks that I like to give you to see if you are on track. Thank you for the reminder, Claire. So the note-taking quiz is simply writing down, I think it is the 3 types of variables. Claire, you got points added in. The 3 types of variables, and I want you to also put in 3 examples of them. So upload a picture of your notes where you recorded the 3 types of variables and 3 examples for each. That's all you have to do to get a 100 here. Does that make sense? All you have to do to get a 100 is upload a picture of your notes with the 3 types of variables and the 3 examples for each. That's it. Once you do that, you are good. So upload a picture right here. You see we've got 3 submissions. Just go to your notes, write down, quantitative, put 3 examples, put categorical, put 3 examples, put identifier, put 3 examples. You got it. I think I put it due for tomorrow night. So I'll probably send out reminders. Pretty easy to do. You can type it in a Word document that we're in snipping tool. Claire, excellent idea right there. You got it, Claire. I'll totally accept that. Are they usually due right after class? Nope, they'll be due at midnight. I always make a lot of stuff due at midnight, so watch out. There are quite a few things. I like to send out reminders. You don't want to be getting reminders. It's not bad if you get a reminder, but hopefully, and let me say this. I don't want to put down anyone who gets a reminder. A lot of people have work. A lot of people have other classes. Well, I guess, I don't know. Maybe someone has another class. Maybe not right now. But you might have, either's fine, Hannah. Either's fine, handwritten or notes, whatever you most prefer, whatever works best for you to take notes on. But you might have kids. You might have other responsibilities. Parents you're taking care of. Who knows? You got Tyler, just write down a sheet of paper, take a picture of it. You're good. Upload it. Boom. Got the grade 100. And really, these are 100 or zeros things. They're easy to get. They're one of the easiest parts of your grade. If you do it, you get the grade. If you don't, you don't. As long as you don't turn in something that's like not it. You're like, hey, I turned in something. I turned in ordinal, nominal. And they're like, well, those are 2 types of categorical. I need identifier, categorical, and quantitative, and I need 3 examples of each. Like height would be quantitative. So there's 1. You already got 1. So if you can't tell, this should take... Has anyone done this? Is anyone one of those 3 submissions, and how long did it take you to do this? This is due tomorrow night at midnight. Did anyone do this, and how long did it take you? Did anyone do this, and how long did it take them? I would say this should take no more than 5 minutes. About the easiest. Just submitted it. I like if you did it. Like you did it while I was talking about it. Yeah, exactly. And it should be in your notes. That's my goal with these note-taking quizzes, is if you were in the lecture, you're like, oh, I've kind of done this. I pretty much do them to see if you're just following along. And it's my goal to keep you guys on track. It's already in my notes. I just had to submit it. Boom. That's the goal. So you get points for just being in class and doing what you should be doing. So great job. So we're going to start office hours here. I'm going to be right back. So wait here just one moment. I'm going to be right back. We'll be starting office hours, and I'll probably stay for at least like an hour. So one moment. I'll be right back, everybody. So I'm going to put up the screen, but I'll be back in probably 3 minutes. And put questions in the chat if you have them. 3 minutes. Be right back. Hey everybody, I am back. Who's still here? I like it. Are your office hours also uploaded to YouTube? You bet. I just downloaded ours to give you a watch on the basics and fundamentals of the platform. Yes, Ben. I've actually, Ben, if you want, let's do this real quick. So Ben, do you have R and R Studio? So if you download R, you want R and R Studio. So great job. I think it's a great thing to learn. You can get stuff pretty easily into R. On slide 40, yeah, we can go back and look at that. Let's see. So we'll see if Ben has R and R Studio. And Ben, if you start asking like, hey, Brian, can you make a video on this? I uploaded some videos yesterday, and I'm more than happy to start putting out concept videos because I want to. This one right here is bimodal, and it's a little bit symmetric. It comes with R Studio. Oh, so did you, yeah, download, yeah. I would highly suggest what Isaac is saying. It seems like a really good thing. Yep. And Isaac has a good idea right there. So download Anaconda, I guess it's called, Navigator, and it comes with R Studio. I'm probably going to be putting that on my computer. Oh, and then PyCharm. So PyCharm is what I have also, Isaac. I downloaded PyCharm, and I'm just getting used to it. I need to look like how PyCharm is, because that's what I put on my Mac yesterday. I actually had it, and then I updated it, I think. So you have R console. R console, let me show that right here. So the R console is just going to be like this thing down here. But the reason we like R Studio is it kind of gives you a whole layout. Thank you very much, Isaac. Awesome stuff right there. So you guys are awesome help right there. There it is right there. And so the basics with R is the following. Here's some very, very basics with R. And if you have questions, feel free to ask. We can go back to doing jump stuff or R stuff. Thank you, Isaac. Huge help right there. So here's the very, very basics with R. We can do it. Yeah, Claire, do you want to do that next? We'll do that next, Claire. It's in yesterday's video, but stay here, Claire. Stay here, Claire, and we can go through chapter 2, homework and quiz, and review the topics. Always helps to review. Make sure we know it. Make sure we can understand it. The better and quicker we get at it, then we have it down. And once you know these things super well, it's like, boom, I got this. Okay. So the very basics of R right here. So Isaac, Ben, I'm gonna give you some super basics. You ready for this? When you're inside of RStudio, which you'll probably be inside of shortly, you have 4 windows on the screen right here. So let's do this. I can't draw in Word. No, I should have fixed that when I went away for a moment. So here's your 4 windows. I'm going to hover over them. Your 4 windows are the following. You have right here kind of your free space. This is just where you can type whatever you want and just like a document. Think of this as a Word document or whatever you want. It's just a free space to start typing all of your code. Now, this is like the computer or the console part of R. There's other tabs here, but this is where all the calculations are done. What is that all about? So, I have no idea what that's about. So this right here is where all the calculations are done. So if I write something up here like 2 + 2 and I hit enter, nothing happens. But I can send this down to here where the calculation will be done. If you're on a PC, it's Control Enter. So make sure to hear this. I'm going to hit either Control Enter on a PC or Command Enter on a Mac. And if you notice, this is a different color. I'll explain that in 1 second. But you can send this to the bottom console by doing that. And so this brings up a very important thing that you notice right here. R kind of color codes things to help you out. This right here, these are numbers, and I just wrote an equation right here. So this is actual code that's going to solve for an equation. And this is what we call a comment. A comment can be anything. A comment isn't really code. You use a hashtag, and then it's just a comment. So I'm telling you kind of like how I'm sending it to the bottom. I could literally write any sort of comment I want. I can write here, still solves for 2 + 2 with the spaces, because R reads through spaces. Spaces are just blank inside of R, so it doesn't matter how many spaces I put. It's still going to solve that, and it puts the comment beside of it. But that's just like me telling you something about that code. You just put a comment beside it, and to put a comment, you put a hashtag. So we see right here, this is where I can just do my work and write it. Now, you can technically do stuff, how to figure out the abbreviation formulas such as standard deviation. I have videos on that, and the formula for standard deviation is just SD, and I'll tell you all about that in 1 second here. So with that, great questions, Ben. Amazing questions. You could just do 2 + 2 down here, but if you notice, you can do it down here, but then you can't really access it. You can do scrolling down here and scroll through your commands, but it is advised when you're coding that you do your work up here, because you could simply edit this right here. You can edit this code right here. Much easier to go about with code you can edit and keep changing rather than going down here, because if you write code down here, you'd have to scroll through. This is not the best way to write all your code and edit it. This is kind of a workspace for you to write out all your code and then just to edit it as you're doing it, because then you can just fix it up here. So the question about standard deviation gets a little bit more complicated now. We're going to mention a new window right here and talk a little bit about standard deviation just previously. So standard deviation inside of R, for those doing in Jump, is simply going and doing analyze distribution, and then you'll choose a quantitative variable because we need to do standard deviation for quantitative amounts, and then we'll go to tip amount. We'll put in here analyze distribution. We'll go to stack, and it gives us standard deviation. Now, it's not much more complicated inside of R, just you have to do it a little differently. Inside of R, we first need data. So this brings up a new thing. Do you notice this up here? This is the brain of R. It's above my brain. That's the brain of R. That's everything R knows right now that you've told it. So I'm going to do a code that's a little bit interesting right here. I'm going to write 1 through 10. 1 through 10 is just the numbers 1 through 10. This is the same code as simply doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you notice, these produce the same things right here. This is a pretty big jump in what we're learning right now, because now we see this will do a vector of numbers 1 through 10. Just the same as I were to concatenate a vector, this is called concatenate, and then you're putting things in a list. Like you're saying, okay, join these two things together into a vector. So you have to do concatenate, which is C, and they have to join everything by numbers, by commas right there. So we could give people's ages, and we could do like, oh, Brian is 38 because he's old. And then we could do someone else 19, 25, 31. There we go. And it'll give us those numbers right there as a vector. So we probably want to store these things. Let's call these numbers. And I'm going to do that. This is going to store these numbers into this. And if you look, they're now here in the brain. R now knows about them. I could just take and call these ages. And so, Ben, what am I going to put that ages will now be stored into that? How am I going to make ages stored into that? I'm going to write a what? How am I going to put ages into there? I'm going to put those numbers into ages. So that way ages becomes those numbers. Left arrow technically, still right. It's going to be a left arrow. It's going to think of which way it's storing into it. It's like you're going to take these and put them into this. That's the way I think about it right there. What you call the brain is the global memory. Yep, there's global environment and function environment. You're totally right. It's the global environment or the global memory. It's like what R knows at all times. It's got some other stuff like some base functions, base R. Isaac, great questions right there. It's the global memory right there. And so now it knows ages. And so now if I call ages, guess what? There's ages. I could do ages plus ages. Now this will give me like 76, 38 right there. And it's just adding together the ages. I could do ages minus ages, and I should get 0 for all of them because I'm just subtracting the same age from the same age. So you can do vector mathematics on this pretty easy. I could multiply everyone's age by 100. So it's just taking that vector and multiplying that vector by 100. So vector mathematic, very easy. Is there ways to download stuff from your PC into the global environment, kind of like ArcGIS? Yes, you're probably thinking about libraries. I'll mention that in just a second here. Do you work with any clusters are used with secure frequency, or is it more freelance or business? I don't. You'll have to explain more about that. I know SSH, like secure, what is it? Oh, I forget what SSH is. No, I don't work with that too much. Isaac, great job. Isaac, you're on some technology stuff. They're kept in directories typically under our local machine. Yeah, I don't do that. Yeah, because like that's what I use for like my website and stuff. I'm always secure shell. That's what it is. Yeah, I know what it is. Like when I have to go through there and upload to like my Unix site and stuff like that, I'm using SSH and all that good stuff. Man, that's good stuff to know. Like you guys can always help my knowledge of these topics grow because there's so much to know. There's so much to know. You work with a remote, yes, exactly. And so yeah, you have to SSH into it. So I use like putty and stuff like that. Bash is yeah. I'm not gonna run some bash scripts. That's insane. We basically know what all these windows are. This is the brain of R. There's other stuff. You can go into packages. There's like this is the basics. I haven't talked about everything yet, but this is kind of where the global environment is. But you kind of mentioned, Ben, you asked, is there ways to get like new stuff inside of here? We'll take a look. We've got different packages. So there's an R server, the CRAN server. You can do install.packages and go to like reg class. Reg class is the regression class thing that we use. And so if you notice, it's downloading it from the R server, the CRAN server, and then we're going to load this up. This will probably be one of the last things I talk about here before I explain how to do standard deviation real quickly, is I want to explain what this does right here. Okay. So what is install.packages doing? Yes, it's basically this right here. Yep. So this downloads the video game. How many times do you need to download a video game generally? Like, I know you can delete it, but how many times do you usually download a video game? How many times would you download a video game? Like, if you're going to play the video game, how many times would you usually download it? Yep, super user do. I love it. Got some Linux right there. You download the video game once. I guess does MATLAB uses Linux? And then how many times would you need to run library? So plays the video game. Think about this. How many times, every time you want to play the video game, you have to run this. Now you might say, well, why doesn't R just start up with all the video games on? And these aren't video games. They're libraries of stuff. But Python does. I don't know how to use MATLAB. Oh, it's Python uses Linux? Is that real? Well, I know a little Linux. I know a little super user do. Sudo. I need to learn more Linux. I use Linux on my Kodi machine. That would be so much memory your PC would. Exactly. Isaac is right. The reason you don't load all the libraries, yeah, that's cool. I didn't know Python used Linux. I really should be. I need to learn more Python. I keep saying that, and then I don't have time. I never have time. So there's just no time. So with this right here, what do we have? We have that we are turning on the packages of stuff. And what's really cool about this is when we do things like correlation, there's a correlation demo inside of here. And so I'll probably show this later on in the semester. I can run correlation demo right here, and it'll give me the values of correlation. And so this is just a graphical demo of different correlation values. And so you can just make a correlation plot. I know it's pretty neat. It's just a neat little thing that Dr. Petrie created. And so this is the graphic plot over here that just shows where your graphics are at. Pretty easy to do, and it's just a function right there running. Yeah, it's super convenient. Just does your graphic. And if you look at this core demo, you can tell it's inside of reg class because this is the package it's inside of. So this is the reg class package right here. I'll load up another package. Do I have string R on here? I should have string R. So can't type library. There's string R. So I have to load string R. Don't worry, that's a graphical error. Don't worry about that. You didn't see that. It's nothing big. It's just saying my graphic window is too small, so it got mad at me for a moment. But if I type, if you notice all these right here, these are in the string R package. You can take a look at what's inside of here, but I now have all these functions. But it's really neat. I am doing all this stuff. I'm trying to get better understanding because I feel like it would be very helpful. Yes. And then Isaac is totally right. This, if you know how to program, if you know how to code, these are very useful skills. They're very important to put on like resumes and stuff. It is an uphill climb. It's kind of like learning how to ride a bike. At first, you're going to just fall off a bunch and be like, I don't know what's going on. But Ben, everyone starts with not knowing anything. You're right. And that's how we started with the most basic of stuff. And we started pedaling downhill pretty fast. Like if anyone's watching this, they're like, whoa, he's just flying downhill. Like, the wheels are spinning. And Google is your best friend. Stack Overflow. I'm sure Isaac knows Stack Overflow. But I will say this. My brother needed me to kind of help him out with something in, why can't I think what it is? SQL. He needed SQL coding help. Oh yeah, start with hello world and build yourself up. My brother needed help with SQL. I know I'm not a big fan of SQL. I don't really use SQL much, but I was able to help him out and figure it out. And he's like, I've been working on this for like 5 hours. And then I was able to figure it out in about 20 minutes. And I don't do SQL coding, but I was like, well, here's your function. Here's the things it takes. He's like, what do you mean by function? I was like, okay. So function takes an object and manipulates it. It like runs code on it. A function could be something as simple as this. Here, I'm going to write a simple function for you. Ready? Here's a simple function. Let's do this. Let's call this function add two things. If I knew how to spell, my fingers went off by one. Add two things. And then we're going to take x and y is what we're going to take. And then the function is going to return x plus y. So my function is called add two things. That's all it does. And so I should know that right there. I think that's a different one. So add two things. And then I want you to tell me what this is going to return. Ben, do you have any idea what this will return if I run this function right here? So it's going to take two inputs. You got it, Ben. That's all it's going to return. And if you notice, the function is actually stored over here because I stored the function as called add two things. I could call the function Brian. And now the function is called Brian. But you know we should... Oh, so nice autocomplete. And now it runs there. But I could change it. Brian could multiply these two things. So now the function Brian multiplies 4 times 5. Yeah, and that's how we define functions inside of R. Very quick and easy to write. You have the things that this is going to take. We could have Brian take 3 elements. You can do crazy stuff like this. Brian now takes 3 elements. We could do some crazy stuff right here. This is the last thing I'm going to do. Because we could do if... If... There we go. Is.na... No, not is array. We don't check if it's array. Is.na z, lowercase z. Then we will return this right here. And if not, because the return will run. We could put an else on that, but yeah, this is... I've went kind of crazy right here. If not, return x plus y. Oh, cool. So this could be a logical... Well, I could do it that way. Okay. Cool. So currently Z is NA, but let's put in a Z right here, and now it adds them. So did you set XY to NA? I always get confused on NA means it does not exist. NA is basically there is no value. And then R also has NaN, which I'm always, that is things I even need to sharpen my knowledge on a little bit, because there's null vectors, there's NA, there's all these crazy things. But we, yeah, exactly. And so I went a little bit complicated right here because I went to conditional statements. I literally just put you on the highway going downhill right now. Like, we started out, you had the training wheels on, like, this was the training wheels. Then I took off the training wheels and I was just holding the bike. Then I was like, okay, you're going downhill. And then I was like, okay, now I'm going to put you on the highway downhill. And you're like, Brian, what are you doing? Stop. Get me out of here. So, but exactly. And yeah, I think it does. I think that's the same way. I think you're right about that. Whenever I say I think you're right and I say it that way, I'm like 99% certain. It's just someone could correct me and be like, actually, NA capital N means this. I don't know. Does R use? I've seen it. Oh, there it is right there. It called it. Okay. Well, I don't think you can evaluate these objects with logical. You see, you can't. That means the logical evaluation of these are missing. And so it can't evaluate these right here. So I might have to read Stack Overflow on these to see, but I can't. You know what I maybe do? Is identical. No, wait. Identical is the function. I don't think it can evaluate these. So let's see if it evaluates these. Maybe they're not identical, but identical will tell you if two vectors are identical, or that's how I generally use it. I was hoping to return true. See, it tells me that those two things are identical. Or, going back to the very beginning here, this is our last topic, then let's start talking about those homework and quizzes. If you notice right here, numbers, let's call this numbers 1. Yes, and please email me. I know I just went from 0 to 50, but I can go identical right here to see if numbers 1 and numbers 2 are identical. Oh, they're not? That was weird. Am I losing my mind? Is it identical? Well, why did this work? Let me go back and look at this. This is the last thing I've just broken my mind. Why would they not be identical? Okay, that returns true. When code doesn't run the way you expect it to. And let's look at numbers 1. Oh, I see it. I see it. Well, that's interesting. Numbers, really? It evaluates, yeah. Numbers 1 is stored as an integer, and number 2 is stored as numeric. That deals with how much memory it takes. And Isaac, you might, since I will try to put these videos to private, but you might want to remove that message after Ben sees it, like after Ben confirms it, just in case. Yeah, exactly. You found it out. Awesome. Just like, oh, you're fine. I don't mind. If you're like, I don't care, I'll be like, I don't care. Like, I just, no worries. Just since they are like, that's what I always remind people. Yeah, Ben got it. That's awesome. And I love, like, let me just say this. We've gone on a little rant here for like 20 minutes, but this is one of the things I love most about this class. I love coding too. If you can't tell, this is like, I just can't stop coding. But, and I'll fix this so that it says identical here. Let me fix it. Numbers 1 is that. So, as.integer. So I'm going to make it so it's identical. Numbers 2. There we go. Well, we could put this inside of here. So we'll do that. There we go. Stop giving me the graphical errors. There we go. So that's a graphical error. It pops up. One of these days I'll figure out how to stop that error. It's just a graphical error because it's trying to use like the graphical window, at least from what I understand when I read up on it. But if you notice now, the issue is that numbers 2 is numeric. So I ran as.integer on it. All that does is turn it into integers. So now these are being displayed as integers instead of numeric, which deals with the amount of memory that it's holding. One of them takes up more memory. It deals with like double decimal precision and all that stuff. So it was telling me that they were not identical because one of them was being stored as integer and one was being stored as numeric. Yeah, exactly. It's very similar. And that's why if you know Python and R, is numeric like float? I think so. I'm so bad with these things. Like, computer science people come in and explain things to me. I'm definitely not as educated. I will say this, like, I totally want to give credit to computer science majors. Computer science majors, know this stuff better than me. Like, you'd be like, Brian, you teach classes. Well, I mean, they're computer science. They get their degree in computer science. So I think it is a float. I think I just don't have to know it at that deep of a level. I just have to know how to like utilize code. That's what I do. And I have to know how it kind of sees the object. And then I have to be like, okay, what's going on? Yeah, computer science, man, that is a hard degree. I'm not saying like any degree is easy, but man, computer science, comp sci. And one of our students who took our classes is getting her PhD in computer science. She just got in. They make fun of physicists. I think everyone has their own way they code, but obviously coding is very important. And do we still have, let's see, are you still here? The person who wanted to do chapter 2. We can go ahead and Claire, you still here? We'll start doing some, Claire, say hey in the chat. If you're still here, Claire, we'll do chapter 2. We could even look into chapter 3. Claire, if you're here, we'll do chapter 2. Just be like, I'm still here, and we'll hop in. We'll start doing some chapter 2. It is in yesterday's video, so that's why I might not do it again. Hey, Claire, it's time for chapter 2. You're here. You got it. We're going to do it. Sometimes if someone's not here, we'll do something else if it's in a previous video. If it wasn't in a previous video, I'd probably be like, well, that's in the previous video, which it has the timestamp on it. But you're here, so we're going to do it, and we're going to explain it. So let's hop over. We kind of had some fun here. That was just some kind of fun advanced coding. You guys can obviously tell I love doing that stuff. It's just fun. It's just like, it's like when the code didn't work, my brain was like, okay, why did this code not work? It was a puzzle. It was like, I thought it would do this, but it didn't do this. What about my code is not telling me that the two things are identical? And the issue was the numbers were identical, but the class of the object was not identical. So you can check the class should get me that. So the class of the object, because identical also checks that. So the class of the object was not identical. So because the class of the object, so the code for class is class. And then I think we didn't mention standard deviation. If you got numbers stored, you can just do standard deviation. There you go, standard deviation. And you could check. They both have the same standard deviation. That's the code for logical equals. That will not save. That'll do logical equals. And they do equals. This is not, that is an error because that is saying store this into this. That is saying, are these two things equal? That is, are they not equal? Because they're not equal because they are equal. This is, are they greater than or equal to? It's true because it's equal to. And you could just do greater than. It won't be greater than because it's equal to it. So just logical things right there. There's so many. Oh, I don't want to do it. I'll confuse people. Okay, we almost have the stuff up right here. I'm pulling up the assignments. Let's get chapter 2. Do you want to do homework or quiz first, Claire? Homework or quiz first? Homework or quiz? You get to pick. Homework or quiz? Which one do you want to do? I'm going to go towards the homework until you say a certain one. Currently installing RStudio and my computer's screaming, oh no, Isaac, I'm so sorry. Homework or quiz? Homework or quiz? I'm pulling up homework now as we speak. Homework. We got the homework up. Quiz. Oh, let's do the quiz. Okay, quiz more difficult. Then it's definitely the quiz. So let's do the quiz. What are you doing? Don't get mad at me, computer. Preview the quiz. We got it right here. Here we go. Whoa. Yeah, Isaac was totally right. This is looking complicated. I'm glad, Claire. Amazing question, because I bet a lot of people are getting ones like this that are pretty difficult looking. What do we got right here? Now, the important thing is to look at this and first start to think about it. We have right here we have right here stem and leaf plots. The stem and leaf plots are univariate quantitative displays of data. The way they are displaying this is that the decimal point was right here originally. 42-4 means 4.24. So what does this represent right here? What does this 51.9 represent? What does that represent? What is that number? I don't know. Someone's got to help me in chat. I know we don't have as many people, but I still need help. I'm stuck. Oh, no. And if you don't know, just say, like, I don't know, and I'll be like, I'll figure it out. But I need people to help me. What does that 51-9 represent? What is it? I probably need to use this key right here. What in the world does it represent? That is an observation. That 9 is an observation right there. Like, that 9 means something. So what does this 51.9 mean? Close, close. Well, this 42-4 means 4.24. So wait a minute. It's almost like the decimal goes right here. So maybe. You got it, Isaac. You're right. It'd mean 5.19. Well, wait a minute. Why is there a 1, 4? I don't know why either. Why is there a 1 and a 4 right here? What's going on? I sound like Morty there. Like, and I sound like Rick. And I can't do a Rick. I almost did it. And I can't. So what is going on right here with this 50.1, or what's going on? Where's the decimal? The decimal would be between these numbers. So let's see. This right here would be 5.01, and this would be 5.04. How many observations are they saying would be right here in this stem and leaf? How many observations? I want to hear it in the chat. How many observations are there in this area? How many observations? Are there 4 or are there 2? Are there 4 observations or are there 2? There are. See in the chat. It's a good review. It's good practice. There are 2 observations. Nice job, Neil and Isaac. You got it. There's 2. We should see a 5.01. Look, 5.01. This 1 right here is represented by this 5.01. And look, 5.04, boom, we got it. So we've eliminated this one right here, and we've eliminated this one right here. It has to be C or A. Does that make sense? Now let's look at C and A for a difference. Do you see this 4.98? Because this is the observation. Do we see a 4.98 up here? There it is. It has to be this answer. Hopefully I've done it correctly. But this number right here, this 4.98, is represented by 49.8. Look down here. We've got a bunch of 4.3 something, 4.3 something, 4.3 something, 4.3 something. There's 4.38, which is that one right here. There's 4.36, which is this one right here. Those are all the observations that are 4.36 something. There should be 5 of them total. So 1, 2, there's another 4.3 something, 3, 4, 5. There was 5 of them total. 4.32, 4.33, 4.36, 4.38, 4.39. I'm pretty certain we've got the right one. Which of the following best describes the graphic? We need to zoom out a little bit here. Okay, this one's tough. This one is where people get it wrong. But let's remember, right to the high, left to the low, whatever way the tail goes. Now I want you to draw your little monster dude, and where's his face going to be and where's his tail going to be? Is his tail going to the high or is his tail going to the low? Which way does his tail go? To the high or to the low? Right to the high, left to the low, whatever way the tail goes. Which way does the monster's tail go? Right to the high, left to the low, whatever way the tail goes. His tail goes to the what side? To the high, to the right. Neeland, you're doing an amazing job. Keep it up. Amazing job. I wouldn't really... Yeah, the possible bimodal is a good answer. Definitely not multimodal. I mean, even bimodal, you could say is multimodal. It's definitely not... It's got slight bimodality. It's not symmetric, that's for certain. Symmetric eliminates this. Symmetric's wrong. Left is wrong. And so it has to be this one because it has to be skewed right. I don't like that they said multimodal. I wish they said uniform. It's not a large mode. They probably said that. The outlier, yeah, I think they're kind of saying that. Yeah. And this is kind of it's a very small second mode. I think this is an obvious wrong answer. That's an obvious wrong answer because it's definitely skewed. These are the only 2 plausible answers, and so this one has to be it because it's the only plausible one. Is that it? We got it? I like that one. I wish they kind of... The possible bimodal is a good way to phrase it. I wouldn't say it's like weak bimodality because you can always say like weak or strong. Like strong means the 2 mountains are very far apart, and then weak means they kind of don't have good separation, or you've got like a weaker second mountain. So the stronger the bimodality, the greater the separation in the mountains. Like, I'll do a quick drawing of it right here. Yeah, these slides are a lot shorter, and this is a very easy. We'll do these slides tomorrow in an hour. They're super quick. This is just one of the longest lectures of the semester. Literally on the slide. So if you look right here, so each of these is getting stronger as I go down right here. So the peaks are getting more distinct, and they're getting stronger as you get like more separation and higher peaks. So the top graphic right there at the very top that I drew is the weakest. The second one is probably where I'd start to see some bimodality. And then the bottom one looks like the graphic here, which has pretty strong bimodality. So that really good stuff right there. That is very good questions and all that good stuff. So I think I still have the right one selected, right? Yes, good stuff. Let's look at the next one right here. The dot plots. Dot plots are a univariate quantitative display of data. So dot plots are univariate, which means we're going to display one variable quantitative data. So we see here this goes from 0 to 4, all that good stuff right here. And how many zeros are there? 1, 2, 2 zeros. Okay. This one is in, this one is in, and this one is in. I'm going to look at, is there only one 4? There's only one 4. Look at that. There's only one 4 right there. So boom, I think we got it. Hopefully I didn't get tricked. I think we got it. As long as there's not, there's only 2 zeros. 2 zeros. There's your 2 zeros. And then there's your 1 4, and that's a dot plot. Dot plots are univariate quantitative displays of data. Which way does the tail go? Right to the high, left to the low, whatever way the tail goes. This is definitely, I need some help. This is definitely skewed to the what? Right to the high, left to the low, whatever way the tail goes. Definitely skewed to the what? Definitely skewed to the what side? I need to know. I need you guys' help. Someone has to say it in chat. If you're thinking it right now, be saying it to yourself. Right to the high, left to the low, whatever way the tail goes. Right. Claire, nice job. And Nealon, great job. This is a unimodal because it has one peak. It's a one mode, one area, and it is right skewed. Okay, now we need to go to a review slide. We've got it in here. Since we said it is skewed, oh, I don't like, the last things I wrote was that. I don't like this new, okay, good, it worked. Since we said it is skewed, what will be the proper measure of center and spread? Since hey, good to see you again, Shady. What will be the proper measure of center and spread? What will be the proper measure of center and spread since it is skewed? We said it was skewed, so the proper measure of center and spread will be what? Proper measure of center will be this. Proper measure of spread will be this. Since we said it is skewed. Any ideas? Proper measure of center would be what? Since we said it is skewed, we just need to trace across skewed, and we have our answers. We know the correct measure of center, and we know the correct measure of spread. So it's definitely going to be median. Great job, Claire. Amazing work right there. So the median is going to be the answer. You're averaging together 1 and 2. It's not put in order, but you're averaging together 2 numbers. You'd have to put them all in order and average the 2 numbers. We did with this one yesterday also, but remember, and Claire, you're right, median will be the center. I'm going to put this in the notes in the chat just so you see. Median, because I think you know, but I want other people to see. Median is center, and IQR is spread. Let's type it again. Because skewed data. There is one question here that asked for the 5-number string. I used my code I sent you, and it told me I was wrong. It was the only one I missed. Isaac, go ahead and just email me about that, and I'll fix it. I think they're just doing it slightly differently. Your code looked to be good. I think I saw your code was doing the quantiles, like you did a code that calculated that. Just email me, and I'll fix it. I know, I hate that. I don't know why. Please email me if you get something wrong and you feel like you shouldn't. You might have gotten it wrong, but I saw your code. Your code looked right. This goes from 0 to 4. Are there any unusual features? Nope. There's no outliers. There's no gaps. Yeah, you're 100% sure. I never say 100%. I'm always like, I'm 99. I probably say I'm 100% sure on some stuff. This one is a pretty tricky one. Gets a lot of people caught, but it's pretty symmetric and pretty normal. So we're going to use the mean and the standard deviation right here. So if you think about what we're trying to review right here, we're literally going back to this again. Because in this one, we have data now that is normal. So now the proper measures for normal are mean and standard deviation. Now, the mean is the average of all the values, and the standard deviation is going to be how far the things generally deviate from the mean. We can look here, and the mean looks to be about 15. So the mean is closest to 15 because it's the balancing point. Is that right? Yeah, they call the mean the balancing point. Why is there an extra space right there? Oh, you know what okay, wait. I see the difference right here. This is where people might get tricked. Read what it says. The mean is 50%, or the mean is 15 because it splits it into 2 even parts, like a 50-50. What splits the data into 2 even parts? Who knows in the chat what splits the data into 2, like 50% above it and 50% below it? What would split the data into 2 even parts? Now, the mean could possibly do that for many symmetric distributions. It could possibly. But the median splits it into 2 even parts because the median is the 50th percentile. So what you notice here is that's a trick answer. That's the median. That's the definition of the median. It splits it into 2 even parts. It's the 50th percentile. The mean is the balancing point. My person needs to fix their space. That's getting on my nerves right there. There's a space. This one gets people a lot of times, though. They say, well, Brian, how do you know the standard deviation? This is a little bit of a trickier advanced question. I showed it yesterday. I'm going to show it again. When you have normal data, we usually go out about 3 standard deviations. So I'm going to go to a site called the David M. Lane site, which is something we'll use in class. And let's take a look. So on the David M. Lane site, where's it at? Where'd you guys go? When we take a look at this on the David M. Lane site, let me copy it again right here. I'm going to go here, copy here, go over here, drop in here. So if you look at this, we said the mean is 15, and it gave us a few values. It gave us a value of either 5. Ooh, that's way too spread out. It gave us a value of 3, looking better, and it gave us a value of 1. So now the values here go from 12 to 18 with 3 standard deviations. We'll talk more about this in chapter 5 a lot, but when you do the standard deviation, most of the data, if not all of it, 99.7% according to the empirical rule, is contained within 3 standard deviations. So standard deviation gives us a typical distance something is away. We can use things like the empirical rule with it, which is the 68, 95, 99.7. You'll be learning that soon, but that means 68% of the data. Let's show it right here. So the rule is, let's do between, and let's show it. 68% of the data is between plus or minus 1. 95% of the data is within plus or minus 2. And 99.7 within plus or minus 3. Hey, Calzone, I told them about you. Feel free to come in from 9 to noon, and you'll get some people being like, whoa. So I told them about you day 1. The David M. Lane applet, if you've used a Z-table, it's like an interactive Z-table. Good to see you here, Calzone, again. Fan favorite Calzone Tyrone shows up. I tell them about you. They're like, I think Brian's making this up. But this is mini term right now. I'm teaching another course. I'm always teaching. So good to have you here. And I'm making some new videos, Calzone. Calzone, if you're learning some stuff and you want videos on Python or R or Jump, email me. I think you know my email. It's just bstevens@utk.edu. Feel free to say hey and be like, hey, Brian, I'm learning these topics in statistics or we're using it in another class. I like making videos. And I put out some new videos last night. Go check them out. Like them if you want. Throw some comments. Helps us get in the algorithm. If you want, your call. So we're doing a homework question right now, and we need to figure out the standard deviation for it. And the standard deviation, if you go out 3 standard deviations, is usually going to be about all the data. So let's take a look. Well, here's our homework question right here. And look, 3 standard deviations. And it's not perfect, but looks to me to be about 3. As in going out 1, 2, 3, and the standard deviation is 1. So it's not the distance you go out total. It's that 3 standard deviations usually contains about all the data. So we'll check our answer. We got it. We're good to go. Excellent work. So continuing on, now these are the harder things. These are the much, much harder ones that people get stuck on. I'm glad we're doing this one. I don't think we did this one yesterday. So what do we got right here? We've got data. Now, I will mention this. Let's do a little self-promotion right here. What you can do, and I think they're saying this is the one they got stuck on, so I think we found a really good one right here. So let's go and take a look. And let's go. What was I going to go to? I lost my mind. I'm going to go to my webpage. That's where I'm going to go to. Let me go to TI playlists. TI calculator videos. Haven't made one of those in a while. TI tutorials. And let me go to the 5-number summary. Cool. Okay, cool. We got it. Okay. So this video that I'm putting in the chat right now, we didn't get an ad. Oh, no. My dad's calling me. We can say hey to my dad right here. Yeah, tell me about that, Isaac, and we'll fix it up. So here is the video right here in the chat. I took my mom's call last semester, and then If I answer my dad, I'll be like, hey, Brian, I'm doing something here. And I'll be like, Dad, I'm teaching. He'll be like, he'll be like, why are you answering the call? I'll be like, it's for fun. So he's a statistician. He's an actual statistician. This one can be done in the TI calculator. I'm just going to play the video a tiny bit in the background. So I'm doing video and video now. But the link is in the chat if you're watching this. So if you're watching this later to get help, all you do is pull out your TI calculator. Great stuff right here. So on the TI calculator, it's my own video, so I can show it. Good job, Claire, but I'll watch the rest later. Awesome. We'll work through it all. Great job, Claire. Good job. Get through the work. So all you're going to do is you're going to go to Stat, which is above my head right here. So eventually, let's go to Stat. So I'm going to click the Stat button right here. Whoop. Click Stat. You're going to go to Edit. You're going to have to enter in all the numbers under List 1. So here we go. Enter in all those numbers. Nice job entering all those numbers. All those numbers are being entered in under List 1. Once you enter them in under List 1, you're going to click Stat again. After you click Stat again, you're going to go to Calc. You're going to click 1var Stats. And under 1var Stats, you will then go ahead and go to Second. Oh, no. Block the number. You'll go to Second, and you'll go to List 1, which is going to be this button down here. Go click Second. Go click the button down there. I'm taking views away from my video, but I don't care. If you guys get it in this video, that's more helpful. And then once you get this, you'll click down, and it'll give you the 5-number summary. The 5-number summary is going to be things right here, like the min, the Q1, the median, the Q3, and the max. That is the 5-number summary. That explains how to do it. But guess what? And hopefully we get it right. You can go ahead and copy the numbers and bring it into Jump. We're going to copy to clipboard. We're going to hit Control-C or Command-C based on Mac or PC. We're going to go over here, and we're going to open up a new sheet inside of R. So we're going to go inside of R, Jump, not R, and we're going to go to File, Data Table, and let's go right here. So now we are going to simply paste the data. Now this is where a mistake can happen. Make sure you either paste with column names or without. The options are either to paste or paste with column names. If you look, the 209 should not be here at the top. That's a mistake. You want to not paste with column names. So when you do this, I'll do it one more time to show you. In this instance, and it depends on the data you have, I just want to paste. Notice how when you paste with column names, the first thing goes in the column name. You don't want that. You want to just paste, and this is your data. So this right here is wrong. This right here is right. On this question, you'll use paste, but it varies from question to question if there's column names or not. So now we're going to go to Analyze Distribution. We're going to double-click this. We're going to click OK. And we get this right here, and we click Stack just to make it look nice. And now the 5-number summary is here. Here's the min. Here's the Q1, because that's 25 cents. Here's the median, because that's the 50th percentile. Here's the Q3, because that's that. And here's the maximum. Now we're going to cross our fingers as we usually do. And we're going to hope that my Pearson likes these numbers. If it doesn't, please tell me. I'll trust you, especially on these, because I have seen some weirdness. Here we go. I'm going to put this on the other screen. Yeah, I'm going to put it over here so I can see it. So you guys are not going to see my numbers. I'll show you them again in a second, but I'm going to have it over here so I can see all the numbers. And hopefully I type them in the right way. So as long as I type them in the right way, we should be right. As long as it likes the numbers. Please tell me if you're like, Brian, I did it and told me I was wrong. I will correct it. We will see if I get it correct. My hair goes in my face. I don't know why. I need to talk to my Pearson people. The IQR, distance. What's really great about Jump is we can think about the IQR right here. The IQR is going to be about, simply, we can calculate ourselves. Let's just do it. It's going to be Q3 minus Q1. Here's Q3 minus Q1. So let's take those numbers. 551.75 minus 387.75. That's the IQR. And if you're afraid you did your math wrong, we can customize our summary statistics. We can go here to IQR. There it is. I always forget where it's at. We can click OK, and I did calculate it correctly. It's only the distance between these two numbers. We go back here. We type in the IQR. It's not that. It's that. We type in the mean. I'm going to have a heart attack because I'm going to get it wrong. Not the mean, but the other ones. How many decimals? 1 decimal, so 468.4. Be careful, especially if you get things off by a decimal. Just tell me. I'll fix it. Once again, please email me. Like, Brian, I was off by 1 decimal. I typed in 468.3. I don't think you guessed that. The standard deviation to 1 decimal, 101.5. Determine if these scores are skewed or symmetric. Okay, so let's look at it. We have to look at the distribution. That is skewed. And one thing I want to point out, this is a huge thing. Jump actually shows you the mean right here. This is the mean, and this is the median. We'll talk more about box plots tomorrow, but the box plot is the line in the middle of the box plot, and the mean is actually shown in Jump, so it's skewed to the left. If you are super concerned, we can go to Customize, and this is something above and beyond the class. We can go to Skewness, and we'll see a negative skew. It is negative, so it's skewed to the left. If you were to draw your little monster dude, he'd have a tail out here. This is his head. This is his tail. He's got a little spike on his back right there, but this is still the tail of the distribution. So it's skewed to the left. Let's see here. Because the mean and the median are not approximately equal. So if you also notice, here's the median and here's the mean, which is what we notice in the distribution, that the mean is lower than the median. So there's the median right there, and there's the mean. So kind of some interesting stuff to notice graphically, just helps us see what's going on. Describe the middle 50%. I wouldn't say falls. I'd say it goes between. Oh, we get checks on our answers. Awesome. Okay, so my answers were wrong. So you do get checks. It's going to want 390 here. Why'd you do that? And then what's it going to want, like 554? 551. Okay, did it say to round these? Type in exact answers. Well, the good news is that these answers right here go to your ones that are the closest. It should like these now. Sorry, I don't know how they're calculating these in my Pearson. I really don't like that. I try to select the ones that don't have this issue. Please tell me. Oh, no. What happened right here? Which one did it not like? Well, it can't be that one, because that's the median. It has to be this bottom one. It's not going to be. That's the median again, isn't it? Oh, type in exact answers only? It's not mad about the 0, is it? Please tell me something about that. Okay. So you want me to round this up? No, it definitely wants me to keep that. What is it mad about? I mistyped something, it looks like. That can happen. We all make mistakes. Pretend this never happened. You didn't see this. So 209, 387.75. We did the same thing? What happened, Isaac? Tell me. What did I do? See, mine, it should round up. I don't even know either. I don't know. It says the quartile is going to want... We see... Let's check. We'll check it. Well, let's find out where the wrong answer is. You ready? Okay, that's a right answer. We're narrowing it down. We're going to narrow this down. So that's a right answer. Let's just type in something ridiculous. Okay, that was a right answer too. That was a right... Okay, wait. That's a right answer. We're going to find out where that wrong answer is. That's... Oh! Wait. Oh! Oh, this recalculates the IQR. That's what it is. That's what it is. Okay. There it is. That's got it. We got it. Okay. Don't worry. Just tell me if that happens. I'll fix it. Just write me an email. Be like, hey, Brian, the way I calculated it, it was different. Because down there at the bottom, it changed what the Q1 and Q3 were. And I used this from the original numbers. And I didn't go back through and recalculate my IQR. Maybe they added in this part at the bottom, which basically gives away these answers to be like, here's the answers you need. So you know what's interesting? Watch this. If I were to do this question again, here's what I would do when I do this question. I'd go down here to the bottom, and I'd look at these answers. Now, I probably can tell what the median is. I'm going to take a guess what the median is. This is my way of doing this by not using technology. You should be able to see your answers. Tell me if you cannot. You should be able to see them. It looks like... Oh, man, it's so hard to tell. Can I see them in an order? Oh, I wish I had them in ascending, descending. Is it 609? Oh, wait, they are. They are in order, right? Yes, they are. Okay, so the median, how many numbers are there? There's 22. Okay, cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The median has to be between these two numbers. So the median is, let me see, that's a distance of 24. Why is my median coming out differently? Looks like the median is 520. Maybe I miscalculated. Oh, yeah, 17. That's what it is. So the median is 520. That's the median. Don't worry, that's the median right there. So that's got to be that. That's got to be that. So the median is 520, I believe. I'm just doing this all by checking it. They are in order, so we can do this. And then the maximum is 609. I'm not going to get the mean because I can't figure that out in my head. And then the median is 520. We already got that. And then the Q1 is 467. And then the Q3 is 572. And then the IQR is the distance, which is 105. I'm calculating right there. You can't get those by knowing it. I have to go and use, I have to copy these to get the mean standard deviation. I can't do that in my head as good as I am. So I'm just doing this one really quickly. If you know the shortcuts, you can do it really quick. So there's that. I've done this a lot. 500.9 and 93.5. 500.9 and 93.5, did I say? Double check. 93.5, 500.9. I think I did everything correctly. So I got it. Ah, what do we do? Oh, wait. Wait. Oh my gosh, what am I doing? There we go. Sorry about that. I don't know if I even clicked that one. I just didn't read it. I didn't check it yet because I didn't look at it. Yeah, that's skewed. You can see it. There's the skew. It's skewed to the left. Sorry about that. You should be able to look at the attempts, Isaac. You might have to log into my Pearson to look at the attempts, but you should be able to see them. So we gotta speed run this question again. We gotta get it right first try, 100%. Can't make mistakes. So here we go. Let's do this. Okay, you ready? I'm gonna start the speed run timer. Let's bring the speed run timer over here. You ready? Let's see. Can we get this question done in? I think I can do his question in 40 seconds. Devil email me. We got this. 40 seconds. Here we go. Okay, we're going to copy the data into here. Go, we got it. We're good. Let's go over to jump. Let's go. We're talking about boom arrow right here. And then we're going to go to analyze distribution. We're going to go ahead and click here. We got it. So now we go, we stack it. 472.4. So that's this one. 472.4. And then we go over here. I got to go quick. And then we go 78.9 right here. 78.9. Is it still skewed? Is it still skewed? It is. Oh, yet it's still skewed a little bit, but this one's not as much. And then we got to get the other numbers right here. The IQR. I'm going to get under a minute. I'm not going to pick 40. So let me figure out the IQR perfectly. Customize summary statistics. IQR. I got to break a minute. The IQR is 96.5. Thank you for giving me a decimal. 96.5. The lowest number here is 248. I'm still going to make a mistake again. Under a minute. 603. And then the median number. What is the median? The median number is 485. 485. And then the lower quartile is 430. That is correct. And the upper quartile is 525. I'm kind of taking guesses at those. Let's see if they are very close to what I got. Yep, that's close. And yeah, that's close. Yep. Okay, good. Those look very accurate to it. So 430 and 425. 525 was it? Oh my gosh, what am I doing these days? Is it symmetric? Are you kidding me? No, it's not. It's still skewed. Where did I make my mistake? Wow. Let me slow down here. I shouldn't have speedrunned it. 603. I must have mistyped something. Let's look down at these numbers. 425. 430. These have to be accurate. It's still skewed. Standard deviation. Did I type those in incorrectly? 472.4. 78.9. Really? It's because of this. I hate that one. Oh, I did it. I did the same thing again. I did it again, Isaac. I did it. I know. We're just having fun here. Okay. Got to get it right 100%. Just so people can see how to do this one. This one is not a nice question. I don't like it. Okay, you ready? We got to get 100%. We got to go sub a minute on this. This is the real speedrun challenge right here. Here we go. Okay, we're going to copy it to clipboard. We copied it. We're good. We're going to go over here. We're going to go into here. We're going to open a new sheet. We're going to paste. We're going to hit graph button. We don't want to do that. We want to go to analyze distribution. We go here. We got no. There's not speed strats. These are swag strats. So we go right here. 467.5. That's the mean. You have to get the mean by using a calculator or something. 467.5. And then we go over here. This is definitely skewed. Standard deviation is 95.1. 95.1. This one is even more skewed than ever. Now, when we get the standard deviation, we're going to go back to here and to the IQR. We got 390 and 548. So that and 390 something that looks accurate, and 480 must be this. Let me zoom out here. So this is 480, I think it was, and this is 546, and this is 399, and the minimum is 208, and the maximum is 583. Oh no, I thought I could break a minute, and no. And then this would be 147. Please tell me I'm doing the math accurately in my head. Boom, man. Oh, you can't, at least can't tell I have fun with this. Okay. I don't think I need to go sub 1 minute, but yeah, that's got it right there. So just to review the best way to do this problem, the best strats for it, I think I can go sub a minute now. Why not? We're just having fun. Please ask a question if you have, if you're still watching. This is just Brian goofing off, having fun. You're like, you have fun doing assignments? Yeah, I do. Okay, so here we go. Okay, so we're going sub 1 minute. We have to go sub 1 minute on this. You ready? Here we go. Okay, we're going to copy the data to the clipboard. We got it. We're doing this. And then we're going to hop over here to a new data sheet. We're going to paste in the data. We got it. We're going to go to Analyze Distribution. Boom, got it. Click it. We're going to go to Stack. We're going to memorize the mean and the IQR. It's 443.3 and 105.4. 443.3 and 105.4. Now we need to see that this is skewed, which we saw just a moment ago. We're going to double check our numbers as we look at this. 105.44443. Yeah, got it. The median is 465, and there we got that. So let's put 465 right here, and then we can confirm. And then this was 300 something. That's 346. And what was the other one? The other one was 533. 533 is going to be that. That's a difference of 180. So this is a 180. Then we go right here. The min is 176. This right here is 346. This right here is 526. Oh, no. Come on. No. 526. This right here is 582. No. Oh, my gosh. Did that count, Isaac? Did I get it? Like that? I didn't hit my timer, but I swear that was it. I swear that was the sub 1 minute. Do I need to do it? You call it, Isaac. You might be the only person watching right now. But do I need to do it again, or do I need to what do you think, Isaac? Was that it, or do I need to go one more time? I'm willing to go one more time. If you call that nope, if you say nope, Brian, you didn't get it, I'll do it again. Just so that we can ace this one repeatedly. That's what I'm trying to show. So anyone who watched this question a whole bunch, I'm glad it's hilarious. But if you're watching this question a whole bunch, I'm just trying to show that you can get these questions down. You would count it. I'd count it too. So I'm going to count that speed run right there. That was an excellent speed run. We'd have to look at the time. It was that I hit that one. Like, it's so fun doing this to me. You stop your computer yourself. Exactly. Like, you can go and manually look at the time. I think, you know why I think it counts, Isaac? Because I had all the answers in there. That's when the clock should end, is when I have all the answers. Because then, if this was a homework, I could have hit enter, but I had all the answers in, and I made no changes to it. So I got all the answers. I just didn't hit the check answer button. So I aced it. I got 100 within a minute. I just didn't check it. It won't let you access them. I'll take a look at that. You might have to go through My Pearson. Sorry for the confusion there, but if you go into My Pearson, I agree too. We'll do the last one right here. Let me zoom in a little bit. The reason I zoomed out was I usually like to make the text big enough so it's pretty easy to read on the screen, but I zoomed out so I could have the full thing. I didn't have to scroll up and down. So that was a lot of fun. The guys can't tell. Like, oh, wait. It's important to know how spread or tightly clustered out the data is. Which of these is not a measure of spread? Isaac, you got this. Which of these is not a measure of spread? One of them is a measure of center, and we should know it like that. Look at that. Last question. We're like, boom, got it. One of these is not a measure of spread. One of them is not. Is definitely the mean. Because the mean is a measure of center. We'll move the speedrun timer out of the way here. Mean is a measure of center. So mean is for normal data. What's the difference between My Pearson's like the site we use, so it might have more additional options. So the mean's the one. Mean is a measure of center. So you're right. Nice job. So if you're looking at My Pearson, it should have like more options for you to look at. I guess you might have to go into My Pearson to see what you got wrong. Sorry about that. So if you go to the My Pearson site, let me put that in the chat for you. Going to the My Pearson site should allow you to access. And so cool. Okay. So if you log in through here and tell me if you have problems, the exams are probably going to be a great question, Cooper. This is a likely thing. Likely, the exams will be, great question, Cooper. Appreciate the question. Probably Thursday, Wednesday. This is a likely scenario right here. So these are when the exams are most likely going to be. I hate to be like, I can't promise, but it's just because one day is like 8% of the course. So if I'm off by one day, then I might, like, we might have to adjust things. So I'll probably know as we get closer, but expect like Thursday, Wednesday. So 3 exams, and we will have class on the days of the exam. We will review some too, but 3 exams. And remember, your quizzes are averaged in. So how important, Cooper and Isaac, how important is it? I know I ask this question all the time, but how important is it to get hundreds on the quizzes and the homeworks? How important is it to get hundreds on the quizzes and homeworks? Like, it's like, like, maybe I'll do the quizzes. Maybe, I don't know. I'll just ace the test. Like, that's my plan. My plan is to ace the test. Well, if you ace the... See, look, I'll show you this. If I touch the pen against the screen, the pens come up, and then I can write, like, Brian right here. And it'll change that. Yay, it understood it. But I don't know why I don't have the pen options. I don't know. Extremely important, exactly. Oh, no. Okay, Isaac, we'll have to look at that. You'll tell me if it was the code or something. So I think, and are there more questions? Does anyone want me to work through a certain topic or go over anything right now? Like, what are people wondering and what are people stuck on? We will see. Got all my soundboard options. What's the soundboard? The tray's not loaded up? That's interesting. Is that why things started working better? Or is that why Streamlabs? There's things I don't understand right now. Which I should. Let me look at something. I'm going to look at something real quick here in the background. So that's the Go XLR audio. That's awesome. Let me hit mute on it. Oh, whoa. Okay, that is muted. And there we go right there. Okay, good. But the Go XLR is not in the tray, so I can't do certain things. Interesting. Interesting. What other questions are there? We might head off here. Just depends. Some days we'll probably have longer office hours. But Isaac or anyone, do you have any other questions? Any last questions before we head off right here? Great stuff. People are way ahead of schedule. I feel like a lot of people are doing the assignments and the quizzes, staying on track, knowing how to do your work. And my Go XLR, it's not currently running in the background. Let me put it in one volume. Boop, one volume up. So all that stuff right here. What questions are there? What questions? I wonder. Watch this. Here, wait. I'll be right back. 2 seconds. I'll be right back. Actually, I think I can't turn on Go XLR. I might crash the stream. I've seen it do that. I was like experimenting with stuff, and I don't know why the Go XLR is not on. Like the app isn't on. The board is still working, and I can still mute my audio and stuff manually. But when I click the button, lowering and raising my audio right now, but when I click the buttons, they don't do it. And so I don't want to run Go XLR in the background now because I think the way it handles the drivers, so Isaac, you might like be wondering about this. I think the way it handles the audio drivers or whatever, or the outputs or the inputs, it'll actually crash the stream. It'll crash Streamlabs. I've had issues because like, why is Streamlabs exiting? And then, so I think the Go XLR, but it's working. I can lower and raise my audio. I can see it on my levels. So interesting. The Go XLR is a new piece of software. I love it. And I don't know why it doesn't have the things working right now. Do you want, Isaac, are you still here? I might show you something cool. We'll see if it works. If you're still here, Isaac, I'm going to try something. See if you're in the chat. See if my audio is working. Test, test, test. Okay, we still have this. Okay. This is my like listen to stream audio right here. Might not be here. Let's see. Does this change the sound of my voice? Might not. Oh, it's not doing it. Okay. Yeah. Okay, I got to reset the Go XLR. And it might just be me hanging out by myself right now. So that's what you're here. Okay. No worries. No, the Go XLR is not doing what it should be doing right now. You just have so many tabs open. No worries. I am the king of tabs. I sometimes have about 20 tabs open on Chrome. You got memory. Why not use it? That's what I say. So I think we've covered all the questions for today. We had a really great lecture today, and I'll put segments in the video again so people can see what's going on. I'll even divide up the lecture into parts. The video does take, I'm looking through at this code. It was given me the wrong values, but it works for every other problem. Yeah, just email me. I'll fix it. Since you wrote the code, I'm totally fine with that. I don't know what my Pearson is doing. I blame them. And I want to kind of write them and be like, hey, what are you using to calculate it? Like, what code are you running? Because all the software, like your software is not getting the answer. My software is not getting the answer. I put the problem on them. Because what we could do, let's take one more look at this. You ready? It's our last little thing to look at this. Because my Pearson's good, but nothing's perfect. So here's the answers we got. Let's copy these answers. You know what I could do? Can I really do this? Oh my gosh. It says comma. Oops. Don't want to do that. Cool. It says it's going to be comma delimited if I do this. Let's go into R. And let's see. Those are not comma delimited. Those are not a comma delimited numbers. I don't think there's a quick way to add all the commas to this. Let's call it values. See, that's ridiculous. What you'd have to do here is you'd have to put a comma after all of these. It's about as quick as it gets. Cool. That's got it. Okay, that should store it into values. It's a really horrible way of writing it out right there. I don't like that, but that's one way to get it. Now that we have it stored into R as values, we can go here and run the values. So that's just our vector of values. To get the 5-number summary, we can run summary of values, and there's the 5-number summary. Let's confirm this with jump. Just so we know we have the right numbers in here, we're going to redo it, which is just analyze distribution. A little easier to get into jump. And there's the values right here. And so let's bring these out of the way right here. Are these both the same? They look to be. Cool. And let's minimize that one. Okay, cool. And what do we see? We see the third quartile. You see even jump and R are doing these differently, I think. Unless I've gone mad. The median is that. Where's the mean is 443.3. Yep. You did it by hand, and I wonder, it's one of those things I hate about statistics. Q3, I think there's different formulas for, and Q1. You see Q1, we even get different answers. Now, is R giving the same answers? 346.5, what did we get? 346.5, let's get to the mystery of this. 346. Okay, that would round to that. And then, what did R give for the Q3? See, Q3 is often R also. I don't know what they're using to calculate it. I don't understand. And I'm so sorry. I half want to delete this problem. If anyone's watching this right now and you get this problem wrong, I probably need to send out an announcement about this one. I mean, let's try another way. You can go here and go quantiles. Quantile, and just do this right here. And do the 75th quantile. I mean, that's what it's reporting. If you want more decimals, you can do things like options, digits, equals 6. And there's just no more decimals for perfect. So it's like, nope. It's like, I'm not going to do it. What is it? Is it round? Well, that's doing that. Why is digits not reporting? No more than 22. Okay, 22. I want all the digits. So, and then why did summary not report more things? There we go. That's what I want. I want ridiculous stuff. That's ridiculous, though. You wouldn't want that. You want, like, report. Oh, it's how many digits, of course. So I probably want 8 digits reported. And then you can change the round also. So now it'll report 8 digits max. Or it's going to report 8 at all times, I think. Yeah, so there it is. And so, or it's reporting it, because you just 9 right here. There we go. And so we get this stuff right here, and then I did the round. Do round equals. I'm setting options inside of it. Still reporting it though, but it's going to round it. So, yeah. All this fun stuff right here, changing certain global options inside of R because it's just the options it uses to run. You don't need to know all this stuff right here, but just looking at the last little bits of code, we always bring it back to code and just trying to figure out what each one of these does. I just don't, digits, I'm always a little bit like, wait, what's going on? It just adds and subtracts the amount of digits that are reported. And so if we were to do something like that right there, that's reported. There we go. Did I really type it to almost the last number? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 after the decimal. But if we go to digits, and if we go to 5, maybe it doesn't count the leading 0. Oh, it's like significant digit. Yeah, that's what it's doing. So that totally changed the output right there. It's counting, it's the 5. It's like significant digits or whatever. So I think it counts the 0 as a significant. So this is, there's the 5 right there, right? And there's the 5. It's just so weird. Because if I add the 0, now it reports it even longer. Oh, no, it just reports that. Oh, because the last one's a 0. That's why. That's why it changed. So it's all the significant digits it's reporting, and it's not reporting the 0 because it's not a significant digit. So that's what's going on here. So if I do something like 0.02, it'll just report that. But if I do this right here, it'll still just put that, and that's got that. And then if I put this, it'll report that 2, because that's still the 5th digit. It'll report that 2. And if I put this, it won't report that. Got it. Significant digit reporting. That's what the digit option controls. You didn't implement it. It's also not functional. Yeah, you'll have to send it to me, Isaac. I'll take a look. If you can't tell, when something isn't working the way I expect it to, I'm always like, what is going on? Why is this not reporting the way I thought it would? And there's just so many things to remember. There's so many things to remember. All these little nuanced things that it's like all these dials you can turn. You're like, okay, what does this dial turn? So you just mess with it. You just keep changing and be like, okay, wait, how is it working? And there's also the help options. So maybe you didn't know this, Isaac, but when you're inside of R, you can do question mark anything, and it'll give you the help menu for it. So you can just go here and do question mark mean, and it'll tell you all about doing the mean. That's the graphical layer again. Love it. But you can just run a question mark on anything, and it'll give you even examples down here at the bottom. It'll long tutorial on everything. I mean, I wouldn't learn how to do it using this. I mean, I go to this for like references when I'm stuck on how to use it. I'm like, okay, wait, what does the color do? Okay, col is the color with the British spelling of how to change the color. So whenever you're stuck on something, you can always just type question mark it, and it'll bring up the help menu that someone wrote for it that explains. I mean, it's a little complicated. Like, you have to have a little bit of knowledge a lot of times, and then there's Stack Overflow. But it's really great. It's like, okay, there's a help menu inside of here that explains how to do everything. And that's why we use RStudio too, because it has all these other options. Like, this is kind of your help area, your plot area. So I make a histogram. We can make a uniform histogram right here of the numbers 1 through 10. We can color it equal to yellow. And there we go. There's a uniform histogram right here with a color equal to yellow, and it's got all these options. I think that's got it. We had a lot of fun today. I think today was a pretty big lecture. I know today was a lot of material, but I think we also went a little bit slowly because we covered a lot, but we took a lot of time on each topic, and we had some fun. I think, Isaac, you might be the only one here, or other people might be away, but any other last questions or anything else? I'm going to probably try to make some more videos later. Are there any videos? Oh, I'm glad that helped you out a lot, Isaac. I'm really glad. And you're doing great. You said your physics, Isaac? What, are you, don't tell me that, because I don't want you to tell you class level you are. But you'll have to tell me via email, like, more about, like, what you're doing, what you're studying. Like, you said you're doing research. That's really awesome. But, I don't know. I like students who are always trying to utilize coding. And, like I keep saying, I'm really proud of, I mentioned yesterday, my one student is going to get a PhD in political science. I got another student getting a PhD in computer science. I have students going on to their MSBA, their Masters of Science, Business Analytics. Obviously, I like business analytics, but if that's not your thing, that's totally all right. If you're like, I'm going to get my PhD in physics, I'm going to be like, man, Isaac got his PhD in physics. I now know, like, Dr. Ownby and all this stuff. Like, that's so awesome, Dr. Isaac. So I want you guys to do what you love. And I hope that statistics, coding, analytics is a part of that. I mean, if you're like, I never want to do statistics after this class again, that's fine. You never have to do it again if your major somehow doesn't use it. But statistics and business analytics are used everywhere. And you were mentioning the power of coding. Coding is used everywhere, not literally everywhere, but it's used throughout all disciplines. Coding is very popular. Knowing it makes you very desirable for graduate schools and for jobs. Jobs and graduate schools want people with analytical skills, coding skills, computer skills, technical skills. And that's one of the things. Yeah, no, that's amazing. And I'll say the last thing. I never want anyone to think that I'm being like, you need to do business analytics. But so this is probably for someone other than Isaac right now, but it could be for Isaac if you wanted. But if you're ever interested in business analytics, if you ever want to be like, Brian, I want to know more about business analytics, I'm always open to talking about that. One of my students came to me and he was so sad. He was like, Brian, I'm changing my degree out of business analytics. I'm sorry. And I was like, what are you talking about? And he's like, you were so excited when I changed it. I was like, yeah, because I don't know. I like business analytics. He's like, well, I'm going to do marketing. And I was like, cool. He's like, cool. And I was like, yeah, that's awesome. And he went on to get like a chancellor's award and all this great stuff. So I'm really proud of him. I was actually just recently helping his dad. His dad's getting a PhD and had to call me about statistics. So I helped out his dad with some questions he had about some PhD stuff for education. And I was more than happy to help out. And I'm more than happy that he's doing what he likes. That's all I want. I mean, if someone's like, Brian, I got the major I want, I got the career I want, that's all I want for you. I don't know. I don't know. I remember one time when I was undergrad. This is my last rant. Brian rants. We'll put a tag at the end. Brian rants. One time when I was an undergrad, people came in to advertise their major to us. Well, thank you, Isaac. I appreciate that. And when they advertised their major to us, they were like, you need to do this major. You'll get a good career with this major. You'll be happy with this major. This major is for you because it's for everybody. No, there's no major that's for everybody. If I had to grade English papers, oh my gosh. I know there's people who like that. Like, people are like, oh, it's so cool. Like, people will be like, Brian, how is math cool? How is coding cool? I don't know. I kind of thought it was cool when I was entering these commas. I was like, cool, I just do this. And I was kind of thinking in my head, how quickly can I do it? Everything to me is like a video game, and how quick and how fast can we do it? And so I was like, okay, and like solving it. It's like, okay, they said it was comma separated. I don't get my commas, which I need between the values, and I wouldn't write it like this. This is ridiculous. I'd put it like all the values like this. Now I'm like, okay, how quickly can I do this? I hate that oh, wait. Oh, we figured out. We solved it. We just have to go to the end of it. So even this right now, I'm like, I want to make this look nice, and that looks okay right there. I'm going to fix this up because I want everything to look nice. And that's something also, if you ever take more classes with me, I'll talk about making nice code. I'm sure Isaac probably has heard of making like good looking code that looks nice. And you notice it also kind of indexed it on the C right there, kind of put it to there. Like, that to me is like writing music or something like that. I also play music. I play piano. So I want things to look organized. I want them to look nice. That's how I'd prefer to write my vector right there. It just reads through the comma to the next line. And I almost get like a little bit of enjoyment out of fixing that. And so you'd be like, Brian, you're crazy. And probably the first time people start coding, that's not what they would feel. They wouldn't be like, oh, it's fixed. But you get that sigh of relief, like you beat a video game, like you beat a boss, like you did something special, like you got an achievement. We'll just put hashtag achievement. Achievement. Vector looks nice. There we go right there. You got to make it readable. You got to have someone understand what's going on. I got an achievement. Vector looks nice. That was worth like 20 gamer points right there. There we go. 20 gamer points. 20 gil. So you got to, and you have fun with it. You got to make it readable. You have to have someone understand what's going on with your code. And so if you kind of enjoy these things, when you fix it and it works, you get that little enjoyment out of it, then maybe things are like this for you. If you do this and it's like insufferable and you're just like, I can't stand this, then no, don't do this. Don't do this. I mean, it is a good skill set, but I mean, having good grammar is a good skill set, but grammar just destroys me. I wish my grammar was better, but every time I try to get better grammar, I'm just like, I hate this stuff. I hate grammar. It's so, hey, what's up, Ben? If you have a question, feel free to ask. Brian was just ranting about do what you love. I know that's so trite to say, but, you know, I like fixing code. So that's why I teach code and I teach how to fix it. So yeah, if you don't like fixing code, then don't become a teacher who has to fix people's codes, because I fix a lot of code. So if you don't like fixing code, you can still code. Just get good enough at coding where your code doesn't usually need fixing. But I have to like fixing code, or it helps me to like fixing code. But Ben, if you have a question, feel free to ask. If you're on a quiz, if you're on a homework, I'll go to 2 most times. So that way the video can compile, because it usually posts the first 2 hours, and then about at 5 p.m. yesterday, it posted the whole video. For some reason, YouTube. So I might try to usually end around like, I don't know, 1:32. Just depends. If we have a lot of work, I'll keep going. But Ben, if you have a question, is Streamlabs still going? 330. What did I do? You guys are going to do awesome. But that's Brian's rant. It's the tritest thing we can ever say. Do what you love and you'll never work a day in your life. So I know it sounds crazy, but like, it can be stressful to get a degree. It's tough. I'm sure physics courses, I would not excel in those. And I'm sure, Isaac, it seems like you love physics, which is awesome. But I bet some of your courses are still pretty tough, still pretty challenging, and still like keep you up, like working on assignments. And that's all right. That means you're learning things other people don't know. And you're probably, I think from what I gather from you, you're enjoying it, which is good. Like to some degree, you're like, this is what I like. But you still have to like I like playing piano, but it doesn't mean I'm going to play piano all day. I get burnt out on it. Thanks. I like that right there. I'll take that. I like that. So you really have to find that thing that you get excited. Like, you're in the right major when you sign up for a course and you're like, ooh, I'm going to be taking this course. And you're like, oh, what am I going to be learning? This is like, oh, like advanced physics or advanced particle physics. You're like, oh, that's so cool. They make me want to cry. Yeah, exactly. Exactly. Like, I can't tell you how many times I've coded something and just wanted to throw my computer against the wall. And I'm just like, and then when you fix it, you're like, yes. Or when you learn it or you understand it, you're like, it works. I'm all about puzzles and solving things. And that's all code is. It's solving something, making something work. And that's, I don't know. That's what I love. And that's you're doing the right thing. And that's what I always encourage people to do. It's just keep, and, talk to people in your major. A lot of great avenues, a lot of great majors. Always be doing like internships or shadowing. Like find people in your major, start doing internships, start shadowing as soon as you can. And then you'll probably find a career path that you love. Like I can't promise people things, but the more people you know in your field, the more experience you have in the jobs in your field, the better opportunities you have, and you're more likely to get a great opportunity you love. It's that, I don't want to say simple, but the steps, which take a lot of time, are very short. Find something you love. That's tough. That's a tough step. Find something you love. That's so hard. That means like, do you love this? Like, I guess. Find something you love. Talk to other people who do what you love. Reevaluate if you still love it, which probably is yes. I mean, probably like, okay, I still love this. Okay, got it, like what they're doing. And then work towards it. 3 steps. That's all it is. But it's a lot of time, a lot of investment. Well, that's Brian's life advice today. Brian's life advice corner. We need you know what that was? You guys get a surprise. That was a little bit of randomness, complete and utter randomness right there to end today. A little bit of randomness from Brian. Little 10-minute rant. It said it'd be a short rant, but complete and utter randomness from Brian. But Isaac just had that happen on his tabs. He's like, what just happened? But I think that's it. I'm going to head off, eat some lunch, and I hope everyone else has a great day. If you have a question, throw it in the chat immediately because I'm going to head off. So bye, Isaac. Bye, Ben. I'll talk to you guys later, and we'll probably be doing a lot of office hours tomorrow. I know it's Friday, but we'll probably have some big assignments to do, so stay tuned, especially for office hours tomorrow. I will see everybody tomorrow. Bye, everybody. Bye.